Hi everyone, this is Roshni Tayal, a lead data scientist at Yum Brands and an educator. Welcome to the tutorial on data wrangling. Here we will embark upon a journey on how to uncover the hidden insights within a data and learn how to pre-process the data in a better way. Also, before we get started, do check out Scalar's masterclass by industry-leading experts on Scalar's event page. Link is in the description. Let's get started. So let's start with the topic, which is data wrangling. So, what is data wrangling is the first question. So, you may also know the term data wrangling with the word data pre-processing, right? So, it is also known as data pre-processing, which refers to the process of cleaning, structuring the data, and transforming the raw data into a usable format for analysis, modeling, or any other downstream task which you are performing to take out the meaningful insights from it. So, data wrangling is basically the unsung hero or behind the scenes magician which transforms your raw data into meaningful insights. Right. So, now the question is that why data wrangling matters? Why are we even studying about it? Why are we even talking about it? Right. So, imagine you are given a mountain of unorganized, messy data, right? It is highly unreliable. It's filled with missing values. There are a lot of duplicates in it. There are a lot of inconsistencies and inaccuracies in it, which you can easily identify, right? How would you make sense out of that data? You need some tools to make some sense, right? So that you can provide some meaningful insights for the business. So, this is a critical step that ensures data used for analysis or machine learning is accurate, it's reliable, and appropriately formatted for the intended purpose. Right. So, proper data wrangling can lead to more meaningful insights and more robust models. So, it depends on you that how well you are performing data wrangling, how well you're cleaning your data and structurizing it to have more insights from it. Right. So, it plays a pivotal role in today's data driven world. Now we know this, right? Because this is highly essential for data analyst as well. So, in today's topic, we will talk about the following methods in pandas. First is ways to merge data frames. Second is joins. And the third is the very famous group by operations. Right. So there are multiple ways to merge data frames. Those all things we will be talking about in here. The joins concept, which is a very common question in interviews as well, and group by operation. Right. So let's start with the first topic, which is ways to merge data frames. Okay, so why are we talking about this topic? So let's say if you have multiple tables given to you, multiple data frames in terms of Python pandas given to you, how will you make sense out of them? How will you deal with them? How will you make it as one table? Right. So here we are studying about merging data frames. So there are two ways to merge data frames. First is concatenation and the other is merging. Okay. So let's talk about the concatenation first. So in order to continue with this tutorial, I have taken two libraries, which is pandas and the other is numpy. So pandas library is built on top of numpy library. Numpy library provides a lot of numerical abilities and pandas is built on top of the numpy library. So, in order to import the libraries, we might know till now that we use the keyword import and then the library name, which is pandas or numpy or any other library that you want to use, and then followed by the keyword as, which helps us give an alias to the libraries. Right? So for the pandas library, I'm using the alias pd as a shortcut to use it again and again, and for the numpy library it is np. So these are the very common aliases that we use for these libraries. If you want to have something else for these libraries, you can have it, you can definitely change them. Now, I I'm using the dataset which is cardekhodataset.csv. It is easily available on the Kaggle website. You can go and download it. Okay, so I'm using this dataset, and in order to use it in pandas, we need to read this dataset, right? So you can see that this is a CSV file. And how to read a CSV file? It's very easy. You can just use this method available in pandas module, which is read CSV. So I'm using the same because it's a CSV file. I'm using pd.read CSV. I'm providing the file path here, okay, and storing it into a variable which denotes data frame. DF is the short form for that. You can have any variable name over here. Okay, so I'm using it, and you see, once I read it, let me run this cell. Once I read it, I will see this data frame. Okay, so there is one problem here, and what is that? You see, I have the column names present in the data set, but along with it, I'm getting one unwanted column with the name unnamed, right? So this is the unwanted column. I do not want it, and my index column has got shifted, right? So in order to resolve this, I will just add one parameter, which is index col equal to 0. So I'm just setting the index column at the 0th position, and I will get rid of that unwanted column. Okay, so let's talk about this data set. As we can see, there are 13 columns in the data, and we have 15,411 rows in the data, right? So these are the data set. So how to list down the columns that we have, right? So you can just use df dot columns. This will list down all the columns that are there in the dataset. Okay, so I can see that there are 13 columns, but with these names: car name is there, brand is there, model, vehicle age, kilometer driven, seller type, fuel type, transmission type, so on and so forth. Okay, I want to see first few columns of this dataset, first few rows of this dataset. How will I see it? You can easily use the head method inside this pandas module, and you see, by default you will be able to see first 5 rows of the dataset. Okay, you can mention as many rows you want to see. If you will mention 10, you will get first 10 rows of the data. Okay, if you want to see the end part, the few rows from the end of the data, you can just mention the tail column. Okay, so by default, if I will not mention any number here, it will open up the last 5 rows of the data, which is this. You see, yeah, we can see the last 5 rows of the data. If you want more, definitely I can give any number that I want. Okay, so this is how you will see the first few rows and the last few rows of the data set. Okay, now let's move on. um, Once I print the data frame like this, I can easily see the shape of the data, but if you want to see it separately, we have the shape library, package with us. Sorry, yeah. So you see, it has 15,411 rows and 13 columns. So this is how you will get the shape in x comma y format. Okay, so now let's say I'm assuming that we might have duplicates in this data set. Okay, we might have a lot of duplicates in this data set, and I want to get rid of those duplicates. Okay, at a first glance, I'm not able to spot that which columns have duplicates or no. So what I will do is I will just use the method drop duplicates. Definitely there were duplicates. Why I'm saying that? Because it is impacting the number of rows in my data. You see, initially we had 15,411 rows and now we are having 244 rows. 15,244 rows. Right. Definitely, so difference is there and we have got rid of the duplicate rows in here. Right. So I can store it into a new variable which is cardf, and I can do this way in order to just check the shape. You see, I'm getting 15,244 rows, and the number of columns is definitely intact because drop duplicates doesn't impact the columns, it impacts the rows. It will remove the duplicates, it will remove the identical rows in the data set. Okay, so now, next is to get unique values. How to get unique values of a column? So, let's say I can see there are a lot of car names here. I can see there are a lot of models in here, but I want to see unique model names, let's say. How will I do that? So, let's also check that out. Okay, so in order to check the unique, what I will do is I will just take, let's take brand. Yeah, dot unique. Okay, so there are these many unique values in the brand column in the data. Okay, similarly I can have the unique value for seller type. Let's take that out. I will just copy this line here and substitute this with the this. Okay, so I can see here are so many rows, but there are only three unique seller types: individual, dealer, and trust mark dealer. Okay, so these three unique seller types we have in the data. Okay, we can also take the unique of the fuel type. Fuel type, definitely petrol and diesel we might have. So let's move to transmission type. What are the unique transmission type? I will just copy the column name from here itself. Dot unique. I can see there are only two unique values for transmission type, which is manual and automatic. Okay, so this is how you check the unique values within a data frame column. Okay, now let's say you want to, now I have taken out the unique values in the brand column, but it's hard to count manually that how many unique values are there in this column, right? So I will not manually count it this one, two, three, four. I just want the number that how many unique values are there in this brand column. So how will I do that? So for that, we have another method with the name nUnique. This will help you get the number of unique values in a column. Okay, so you can also verify by counting from here. So there are 32 unique values in the column brand. Okay, these are easy to count, but this is not easy to count, right? So you can use this method. Okay, now let's come back to our topic, which was how to merge data frames, and we wanted to discuss about concatenation. So this is how you can just analyze the data set on a very basic version, right? Now, in order to um, merge the data frame through concatenation method, I need to split the data into multiple data frames, right? So I'm creating some subsets of the main data, which is car df. Now, how to create that? So in order to create that, what I will do is I will just do so what I'm doing over here is I'm taking the seller type column. We have seen that there are three unique values in this column, right? Individual, dealer, and trust mark dealer. So, and my target is to create the subsets from the main data, right? So I am taking this column and creating the subsets. So basically, I wanting to have three subsets of the main data, one with the value individual in seller type, the other with the value dealer in seller type. I will just copy this line, paste it here, paste it here, replace this with dealer, and here I will replace this with trust mark dealer. Okay, so and save this into three variables, which is sailor 1, let's have sailor 2, and let's have sailor 3. Cool. So what I did over here is I have created subset of the data set, and this is how we have created. So using the indexing for the rows, I am just feeding the values for individuals. So I'm just trying to filter out those rows where I have the individual value for sailor type. Similarly for dealer, and similarly for trust mark dealer. Okay, so what this will do is wherever the value for sailor type is trust mark dealer, it will have the boolean value as true, right? And those rows will get filtered out. Okay, so this is there. Let us run this. Okay, so let me show you. I can see that the data set has got split. We have 5612 rows in sailor 1. We have 9459 rows in sailor 2, and similarly I can verify for the sailor 3 having 173 rows. Okay, so this is having very less number of rows, and I can verify my original number of rows in the data frame was 15,244, and I can verify that from here. I will just add up the number of rows and each of the subset that we have created over here, just to show that yes, we have created the subset successfully. Right? We are getting the required number. So yes, we have been able to split the data correctly. Now let's move forward. So talking about the concatenation is not exactly a join. Okay, so join is a different concept and concatenation is a different concept, but it's a way to stack data frames or concatenate two data frames along a specific axis. So access over here plays a major role. Okay, so either it can be row wise concatenation or it can be column wise concatenation. Okay, so with this, many people also ask me about the concept of access. It's very confusing for them, so let's talk about it very briefly over here. So there are two types of concatenation, I said, right? One is the row wise and the other is column wise concatenation. Okay, so this depends on what axis you specify. Okay, so like we have already said, if you specify axis equal to 0, it's vertical stacking. So I will help you imagine vertical stacking. So with the vertical stacking, you can imagine this, right? This is my T1 and this is my T2. This vertical stacking in terms of data frames, how would you imagine? Of course, we have rows along this and we have columns along this, right? So if we talk about vertical stacking, definitely we are talking about row wise stacking. So row one after another. And if we talk about horizontal stacking, definitely we are talking about the column wise stacking. So let's say you have 13 columns, you will be adding up the next 13 columns here, because table 1 has 13 columns, table 2 has 13 columns. So you will be stacking this way. Let's get back. So when you specify axis equal to 0, which is the default value, you are talking about the vertical stacking, which we just saw, which is row wise stacking. And if you mention axis equal to 1, we are talking about horizontal stacking, which is column wise uh, concatenation. Okay, now let's see that how this works in the actual data, the vertical stacking and the horizontal stacking, how this looks like. Okay, so in order to concatenate along an axis, what I will do is I will just create, I will just use pd.concat method under pandas module. Okay, and now I will just mention the subsets that we have created. Okay, so what are the subsets that we have created? We have created seller 1, we have created seller 2, and we have created seller 3. Okay, I'm not mentioning any axis over here. And now let's try to visualize the all seller. How does it looks like? Voila, we have been able to concat all the 3 data frames. I did not do anything, right? You just saw I just wrote one line using concat method. I just fed the subsets, the multiple data frames that we had, 1, 2, 3, and we are able to get 15,244 rows. Okay, either you mention axis or no. I have not mentioned, that means it has automatically taken the value as 0. Even if I feed axis equal to 0 here, it will give me the same result. Okay, so this is how we concatenate, which is row wise stacking or vertical stacking, row wise concatenation. Okay, so let's also see that how do we concatenate along a particular axis with the value axis equal to 1, which is side by side concatenation, right? So what I will do is I will copy this line, paste it here, and first I will show you the stacking for only 2 data frames, which is 1 and 2, and we will have axis equal to 1. Let us change the name, seller 1 2. I'm giving it the name as seller 1 2. Now let's visualize this seller 1 2. You see, something strange happened. We are getting 15,000 rows, 15,071 rows, and we are getting 26 columns, right? Like I told you, we had 13 columns in one data frame, and the other data frame also consisted of 13 columns, and that is why we are getting 26 columns. But now you see how bad we are getting the values, right? I will help you visualize this. So my data frame was ending at the column selling price. I Okay, selling price over here is not visible, but no issues. You see, vehicle age is there, and again we are having vehicle age, right? Which is, of course, you wouldn't want this. And you see, we are having values in here, but we are having non values in here. Okay. And you are you able to see that how it is being concatenated along the axis equal to 1? How this horizontal concatenation is working? We are having non values for all the rows for seller 1, and we are having non values for all the rows for seller 2 here. Okay, so if I just give you a very brief visualization for this, it is concatenating this way. This is T1, and everything over here is getting nan values for these number of rows that are there, and everything over here is getting nan values for these number of columns, for these 13 columns that we are having in T1. Okay, so this is definitely you wouldn't want when you are merging two data frames. Why I'm saying that? Because we are getting so many nan values, so many unwanted columns. Why we want to create duplicate for our columns? We are having 13 columns in our actual data frame, right? Why do we want uh, extra 13 columns, duplicate 13 columns I should say, in fact with the nan values? Okay, so the number of rows is getting maintained here, but the number of columns are getting duplicated. So this is definitely not we want. So we take the default value over here, which is axis equal to 0, and we perform the vertical stacking, which is row wise concatenation that I'm referring to. Okay, so this was all about the concatenation. Now let's talk about the joins. So the concept of joins is actually very important because this is also the interviewer's favorite question, that what is inner join, how does inner join works, what is left join, how does left join works, how would you implement left join in Python using pandas. So all these type of questions are very famous in interviews. So let's understand. So this is a very crucial concept in the data wrangling as well. Okay, because this helps us in merging data frames. We have already seen the concatenation, but this also helps in merging the data frames, but through different join operations. So let's understand each and every join in detail. What is inner join, what is left join, right join, and outer join. So these are the four types of join that we will be studying, and this outer join is also called as full join or full outer join. Okay, so you will hear these names interchangeably, and try to relate it to outer join itself, which you see over here. So you see this diagram over here. We have table A, we have table B. So this is the Venn diagram. This is also called as Venn diagram, VENN. Okay, and we have two tables here, table A and table B. In inner join, we take the intersection of these two tables. Okay, now, let me explain you what intersection we are talking about and how this intersection looks like in the real table. Okay, try to understand the crux of the inner join. So, I'm explaining you this with a very simple data set, because if you understand the concept you will be able to apply to this in the vast data set. So let's have two tables here. Table 1 has two columns, student ID and student name. And table 2 has three columns, department ID, department name, and student ID. Okay. So both the tables have a common column, which is student ID and student ID. Okay. So always understand that in the concept of joins, whenever you are trying to merge the data frames, there should be a common column between the two tables in order to merge them. Okay. If you want to apply join operation, there should be a common column. So I'm having a common column here, student ID in both the tables. Now I can see the probability of merging these two. But what join should I apply? Let's talk about inner join first. So inner join helps you get the common rows between the two tables, which we also saw as the intersection of the two tables. So it will give you the common rows between the two tables. Now, common row will be definitely decided on the basis of the common column, which is student ID. And this is a unique primary key column, which you know, right? So if I see these two tables at one glance, I can see that one is student ID 1 is there in both the tables, 3 is there in both the tables, 5 is also there in both the tables, 6 is not there, 7 is there. Okay. And similarly, in this table 2, 8 is not there in table 1 and 2 is not there in table 1. Okay. So if I do the inner join of these two tables, what will I get? I will get student ID, I will get name, I will get department ID, and I will get department. Okay, I will get these four columns in my resultant data set after merging. And of course, the common columns that we talked about. Student ID 1 is there in both the tables, so I will get it. It's Raj, and Raj studies in department ID D1, which is the maths department. Okay, now let's talk about the student ID 3. 3 is there in both the tables, so this will be there in my result as well. Name is Shashi. Department ID for Shashi is D6, and it's biology. Okay. Similarly, for student ID 5, we have this in both the tables, so I will take it. Okay, so Summer is there, and Summer studies in department 4, chemistry. Okay, similarly 6 is not there. 6 is not a common row in both the tables, so I will ignore it. I will come to 7. 7 is there in both the tables, so I will get this. And 7 is Abhishek. Abhishek studies in D5 department, which is the physics subject. Okay, so this is the result of my inner join, giving me the common rows between the two tables. Okay, now the question is that how do we apply it in pandas? Okay, so over here you see we are using inner join to merge these two data frames. And before coming on to merging the two data frames, let us create the two data frames with the name high kilometer driven cars and average mileage DF. So I will just create a data frame with this, I have already done this code. I will just copy it in order to save time. Okay, yeah, I will explain it to you. Okay, so what I am doing over here is I am grouping the car. I mean, I will explain you this group by concept later on, definitely. So over here, just understand that we are in a way creating a data frame where I am taking the mean value of mileage, right? So I am just filtering these two columns, which is brand and mileage. Okay. And the group by is on brand. So basically, we have this data frame, brand, and we have this mileage. Okay. So what I want is I want the average mileage that each of these brand has served. Okay, so we want to take the average mileage corresponding to these brand. So this is how I'm taking it. Average mileage df. I'm doing it like this. Dot mean dot reset index will give us the. Uh, so I will explain you all these things here. So over here, just understand that we are taking a data frame with the name average mileage df. Okay, so how this looks like. Yeah, you see. So Audi has traveled these much of average mileage. BMW has done this. So it's not ordered. You will see it's very unordered right now. Okay, so each and every brand has served these many average mileage. So this is my one table, table one, and this is the other table which I'm having with the name high kilometer driven cars. So over here I've created a data frame which consists of only petrol cars. Yeah, let me show you how this high kilometer driven cars looks like. So what I've done over here is I want to filter out those cars who has traveled greater than these many kilometers, 20,000 kilometers. Okay, and now you will see that in this high kilometer driven cars, you will see all those cars whose kilometer driven is of course greater than 20,000. You see, 20, greater than equal to 20,000. 20,000 is there, 60,000, 37,000. All the values are greater than this. Okay, so corresponding to this I've got 13,189 rows. Okay, so this is the other data frame that I'm taking, table 2, and this is my table 1, definitely with brand and average mileage. Now, what is the common column between these two tables for me? Table 1 you have seen, table 2 you have seen. What is the common column over here? Definitely the common column is the brand, right? Mileage is also there, but this is average mileage now. This is a new column which is average mileage. So the common column which is there between the two tables is brand. Okay, so now let's perform the inner join. Okay, so for performing join, we use the merge method given in pandas library. Okay, so this merge method, I have to feed the table names which I'm taking. So over here, the first table is high kilometer driven cars, which is this table 1, and the second table is average mileage df that you have created. Okay, now I need to mention that what type of join I want to perform. I'm mentioning inner join over here. Okay, we are talking about the inner join. Now it asks that which is the common column between the two tables that you want to join both the tables on. Okay, so here you see left on and right on. If you have the common column name between the two tables, you can just use on as well, like this. I can just use this. Okay. If you have the same name in both the tables for the common column. If you have different names in both the tables, you can use this. That in left table you have this name, in right table you have this name. You can mention it separately. It will join on those columns. Okay. So this is how you can do. Let's run any of these cells. I'm running this and let's see the table. Merged inner join df. So I can see there are 13,189 rows, which is same as the number of rows in high kilometer driven cars. Why? Because we have not filtered any of the brand names from here. We have taken all the brand names, right? That is why we are getting all the rows in here, 13,189. And you see that my tables have got merged. Average mileage have come here. We can match the value as well. We can verify the value as well in order to see that whether it is merging right or no. So wherever you see Maruti here as the brand, I can see the value as 22.425, which I want to verify from this table. Definitely, Maruti has the value as 22.425. So this is how merging happens. Okay, since we had the same number of rows in table 1, that's why we are not seeing the difference in the number of rows, but you can definitely take such example and then you can see the difference. Okay, now let's talk about left join. So this was all about inner join. Let's talk about left join. So in left join, it is also very easy. We have two tables, table A and table B. In table A, we will have all the rows plus the common rows between table A and table B in the result set. Okay, so I'm repeating again. So in left join, we will have all the rows of the left table plus the common rows of both table. Okay, so let's see this in our smaller, easier data set. Let's visualize this. Okay, so definitely I will have the same set of columns. So I'm just copying this here as well. Okay, now this is my left table, table 1, and this is my right table. Why I'm saying this as left and right? There is no logic over here. It's just that table 1 is on the left side, so this is my left table, or this is my table 1, and table 2 is on the right side. I'm just taking this as right table. Okay, I could have also taken table 2 as my left table and table 1 as my right table, however you feed it. Okay, right now in whichever order I've written, I'm taking that as left and right. So what happens in left join is we have all the rows of the left table plus the common rows from both the table. Okay, so irrespective of this, I will have all the rows of the left table. I've just copied pasted here. Now let's figure out the department ID and department for these three. Okay, so 135 we have already figured out, so I will just copy it. Okay, now we already know that student ID 6 is not there in table 2, right? Student ID 6 is not there in table 2, so we do not know the department ID and department information for them, so the value will come as null and null. Similarly, 7 we have, so we will just copy the value from here. So this is the result of left join. Okay, so this is left join. So for the rows that is not there in the right table, you will get the value as null for the columns from right table. Okay. And we have definitely the common columns in here. 1, 3, 5, and 7 is present in both the tables. That is why I'm getting the result as I'm getting all the values for them. Okay. So let's also add one new student with the name Sham. And yes, now this student is also not there in table 2, right? But since it is in left table, all the rows will come here, but I'm not able to find department ID and department in this table. That is why I will have the value as null and null. Okay, so this is the concept of left join. Similarly, on the similar note, we have right join. It's very similar to left join, what you have done in left join. So in left join, you prioritized left table and accordingly took the number of rows, right? In right join, you will prioritize the right table and take all the rows of the right table, and that definitely contains the common rows in both the tables as well. Okay, so now it's time to prioritize the right table. So my right join result will also have all the 4 columns. Okay, my right join will also have all the 4 columns, which is student ID, name, department ID. And as I said, we will prioritize this. Okay, and the student ID will also come up here. Okay, now do I have the name for student ID 2? No, we do not have. Null. Okay, do we have the name for student ID 8? I will search in the left table. No, we do not have. 7, do we have? Yes, it's Abhishek. Similarly, for 531, we have Summer, we have Shashi, and we have Raj. Right, I will get the names. So these are the common columns that we had, right? And these are the columns which came exclusively from right table. So this is right join. Okay, so I am hoping that this left join and right join is very clear to you guys. So let me show it to you here. So you see in right join, the whole of right table will be there, which includes the common rows as well of both the tables, right? So let's see over here. How to use left join? Very similar to the inner join that we just used. pd.merge, the name of the 2 tables. So left table over here I have fed as the high kilometer driven cars table, and this is the second table which is average mileage df. Okay, how do I want to merge them? I want to merge them on left join basis. And again, I could have just used on keyword on parameter as well. I've just mentioned this left on and right on. Okay, so let's try to run this, and I will get the output. The number of rows are same, and definitely over here we are getting everything. That's why we can see this. Okay, so yeah, it's working exactly the same what you saw on the Excel sheet. So do not worry that how did it came or how not. Okay, because it is prioritizing the left table, which is high kilometer driven cars. So that's why it's little unordered than the first table that you saw. Similarly, for the right join, no reference, just the how parameter will contain the keyword as right, and left on and right on you can specify like this, or you can also use it like this. Okay, let's use like this. Okay, and let me run this, show it to you. Definitely we have got the result. Okay, we have got the result and we are getting the average mileage. Okay, now this was all about left join, right join, and inner join, but let's also talk about the outer join, which is also called as full join or full outer join. Okay, now this outer join basically is the mixture of left join and right join, to be very um, intuitive, to be very precise. Okay, so let me show the output to you. Definitely in the result set, I will have all the four columns. So I'm just copy pasting these columns. Now I made the statement that outer join will have all the rows you see here, all the rows of the left table, all the rows of the right table, and definitely it covers the common rows as well. So it will have everything. It's the mixture of left table, left join, and the right join. If you combine these two, you will get this full join. Okay, so let's see it over here, how this applies to our sample data. I will take everything corresponding to the left table first. Okay, and let's just try to have the department ID department for them, which is from the left table itself. Okay, now I have definitely missed for these two student IDs, which is exclusive on table 2, right table, right? So what I will do is I will also take these two students whose name is not there definitely, like we saw in right join. I will write them as null, and department ID and department name is given for them. So I will take them. This is outer join. Okay, what did we do here? We took all the rows of the left table, like left join, and tried to find out the department ID and department information for the students not there in table 1. We were not able to find, so null, null. And these two student IDs were exclusive to table 2. They were not there in table 1. That's why we were not able to find them, right? So department 1, department 4, these all information was there. So this is outer join, left join plus right join. Exclusive rows, all the exclusive rows of left table and all the exclusive rows of right table plus the common rows are already covered. Okay, so that's it. And the only difference over here in Python code is that you can mention the keyword as outer, and rest everything will be same. You will get the output. Okay, so we can already see there are some non values here for the few brand which is Ferrari, Maserati, Rolls Royce. Okay, so which might not be, whose information might not be there. So three new rows have been added up. So this is all about the join concept. Let's move on to talk about the concept of outliers. How to remove outliers? What are outliers? Okay. Now, so outliers are those unwanted data rows, unwanted values in our data set, which actually hinders our analysis. Okay, so these are the extreme values that you want to remove from the data set in order to drive meaningful insights from your data. Okay, so yeah, let's come to this removal of outliers, but let's understand this concept first. So, why I am talking about the outlier over here at random? Because outliers in our data set is a very common thing, right? We can definitely have, if we are dealing with a large amount of data, we can definitely have a lot of outliers, and they badly affect the mean and standard deviation of the data set. Okay, so it's very essential for us to remove them because it may lead to giving us the erroneous results. Okay, and you will also notice that the even after cleaning the data set, if you have not removed outliers, the most of the machine learning models will also not work well as expected. So it's very crucial for us to remove the outliers, and that is why I've included this section in the data wrangling. Okay, so there is one way. If I show this to you in a number line, we have the concept of quartiles. This is the, until here, let's say we have the 25% of data. This is the middle part, which we can call it as median. Okay, this is the 50% of data, and similarly we have quartile 2. This is quartile 3. This is quartile 2, which is at 75%. So this is called as interquartile range. Okay, this is called as interquartile range, and over here we have the boundaries. Okay, this boundary has some value, which is q3 plus 1.5 times of this interquartile range I'm referring to as IQR. This IQR is basically quartile 3 minus quartile 1, okay, into IQR. And similarly over here we have Q1 minus 1.5 IQR. Okay, so any data points which is out of these boundaries are referred to as outliers. These data points which you see, which is out of the boundary, definitely outliers. Okay, so we want to remove these kind of data points from our data set. If so, you may also heard about the concept of box plots, which helps us analyze that what are the outliers and how we can, through box plots we can definitely visualize these outliers. So this is the box plot that I'm referring to. This is the boundary lines that I drew, 1.5, and similarly over here q1 minus 1.5 IQR, and this is q1, this is median, which is q2, this is q3, and this is IQR, q3 minus q1. Okay, any points lying over here will be the outlier. So similarly, we can do this in Python. I have already done it. Let me just copy the code in order to explain you. Okay, so we have this car df where we had just removed the duplicates and we had a few lesser rows than the original data. I'm creating a copy of this. You see, I'm using the copy method. I'm creating a copy of this data frame and saving it into a variable named df1. Over here, I just do not want to hinder this original variable that we created and just go back and run it again in order to get the value. Okay, so I'm taking two columns here, vehicle age and kilometer driven. Okay, now I'm iterating over the values of these two columns, df1 dot columns, and I'm taking the quantile value of these. Okay, you see, I'm taking the q1, which is 25% of the data. I'm also taking q3, which is 75% of the data. Okay, so quantile 1 and quantile 2 is there with us. Now I can also take out the IQR, which is interquartile range, Q3 minus Q1. And now we have this. Now I'm just applying the formula Q3 plus 1.5 into IQR. So those data points which is less than equal to the boundary and which is greater than this will get filtered out over here. Okay, and we have just we are just filtering those, you see. So all the points which is less than equal to which are lying inside the boundary, we are filtering them out. Similar here, which is inside the boundary, we are filtering them out. Okay, and doing the same. So you see the difference. Vehicle age is there, kilometer driven is there. Before removal of outliers, the data set had these many rows. And after removal of outliers, the data set now has 14,640 rows. So clearly, there were so many outlier values, right? So we cleared them up. And this clearance was on the basis of these two columns. You can definitely take more number of columns in order to remove them. I just took these two just to reduce the processing time and to explain you better. Okay, so yeah, this is how you remove the outliers. You basically try to take the boundary formula and filter the data points which is within the boundary. So yeah. Okay, let's start with our third part, which is group by operations. So in order to explain you group by with a smaller data set, let me just come to this Jamboard. Okay, so let's say we have a data set where we have these employee IDs and these employee are working on these departments. DS denotes data science, software engineering, data science, and DevOps department. Okay, and these are their salary. Okay, so let's say we want to analyze that which department earns the most. Okay, so what we will do is we will perform a group by operation. What group by will do is it will group the departments which are having similar values. It will make groups. Okay, so over here, if I do group by department, it will create a group of three because there are three unique values added up the salary for that person as well. So similarly over here, we have the scar df, right? Now we want to find the maximum mileage across different car brands. Okay, so we have different car brands we have already seen, but we want to have maximum mileage across them. That what is the maximum mileage that each of those car brands has given us. Okay, so what I'm doing is I'm doing group by on the column brand. Okay, and this particular column I'm taking as the max. So mileage dot max will give you the max of this column across these groups. Okay, so groups will be of oddie will be one group. All the rows consisting of oddie as value will have one group. So out of that, it will select the maximum value for the mileage. Okay, so maximum value we can see over here is 18.53. Likewise. Okay, I will explain you reset index. Let's just remove this. So this is maximum mileage cars data frame that I've created. Now you see that I ran this and I got such table. Okay. Once I apply this reset index, I'm getting the table in a proper format. Okay. So this reset index basically sets the index for the values and gives you the table in a proper data frame format. That's why we just use this. Okay, so this is how we are getting the mileage across the different. You can also verify this in a smaller data set. Right now, we have a lot of instances here. That's why we cannot verify this, but yes. Okay, now what I'm doing over here is I'm just renaming this mileage column with the name max mileage. So, how do you rename the columns here? So, we use the rename method. Okay, in bracket we mention the columns which we want to rename. Okay, so I'm renaming mileage into max mileage. Okay. Now what this in place equal to true does, so this in place equal to true will actually make the change in the variable itself. Okay, so let's say I am removing this and showing it to you. What if we do not apply this? I'm doing this. Okay, I can see that max mileage has come. But now again, when I will print this df, I will see that the change has not occurred. I can still see the name as mileage. I changed it to max mileage, but the change has not occurred yet. Okay, so the change will only occur in two instances: when I save this into a new variable, or if I save this in a new variable and I print this new variable, I will see that new variable has the max mileage column. Okay. Or what you can do is, in order to avoid this usage of new variable, you can use in place equal to true. It will make the change in this particular variable itself. Okay, now if you print this max mileage cars again, you will see that the change has taken place. Okay, so this is the use of max mileage. Now you can do several things. I took max, you can take median, you can take mean, whatever according to your wish. You can just take those. Okay, now I'm doing some other experiment. I'm trying to take those models which has run for greater number of years. Okay, I had these columns, right? Let me print this again so that you remember. I had car name, brand, model. We have model. Okay, we have vehicle age, kilometer driven, sailor type, fuel type, mileage, engine max power, seats, and selling price. Okay, so what I want to do is I want to analyze the models which have run for greater number of years. I mean, using this column vehicle age, I can say that, right, that this model X has run for so many years, has been running for last 5 years or 10 years. Okay, so this vehicle has run for 5 years on road. So this is what I want to analyze over here. So for that, what I'm doing is I'm grouping on brand. Okay, I could have also used model here. Let's use model. Okay. Now, this as index equal to false, I will show it to you how this is affecting our result. Let it be there for now. And we are taking this vehicle age dot max. Okay, so I'm taking the maximum year corresponding to a model. Okay. Now, let us run this. You see. Okay, so we have so and so model as well. So let's take brand only. We have some unwanted values in model. Okay, so you see that Audi, the maximum, the maximum time that Audi has run for a person is 12. So Audi has run for 12 years. BMW has been running for 25 years, right? So I can say that Maruti has run for the greatest number of years, right? So this is a long running car if anyone buys it. Okay, so this is the inference that we can get from this data. Now what I want to do is, since these values are quite unordered, I want to order these up, right? So I'm just using sort values by vehicle age. On what column do you want to sort these values? So I'm mentioning this vehicle age. In what order do you want it? I want it in descending order. That's why I'm setting ascending equal to false, and you see the result. You see, it has got ordered. So Maruti is on top with the least brand MG as 2 years. Okay, so yeah, if I remove as a index equal to false, okay, so we are ignoring the index as well here. Okay, so we are taking for that purpose. So you can definitely have more number of analysis around group by, and it serves a lot of purpose. We can take the maximum mileage, we can take the average mileage that a brand has served, we can take the models which has run for more number of kilometers, which model of a particular brand runs for more number of kilometers. You can come up with all that analysis from this data, right? So definitely this data wrangling is very helpful.
First, let's try to understand why these data job profiles are so much popular. So we all know data is the new oil of the industry. So the way raw oil empowered the industrial economy, in the similar fashion, raw data is empowering the information economy. And nowadays, every company is heavily dependent on these data-driven business decision. They want to provide best customer experience, they want to provide best customer services, and they also want to grow in their specific field. They also want to make more and more money. And how it is possible if they are able to compete with their competitors? So without analyzing the data, without checking their progress based on the stats, based on the quarterly growth statistics and these kind of insightful reports, they won't be able to figure out where they actually need to put their efforts. And that's why data is something which is important. Companies are looking for different skillful data professionals for different segments, because one particular big data solution is a combination of small segments. There will be data professionals who will be taking care of the ETL part, like the entire processing, pulling data from somewhere and then processing it. There will be data professionals who are mathematical pros and trying to solve complex data solutions, trying to create some models around it and try to predict something. Cool examples like recommendation engines, predictive models, and these kind of things. There will be data professionals who will directly interact with the end stakeholders, who will interact with the customers and business persons. so that they can represent that insightful data in some meaningful charts or graph or these kind of stats. Because the end customers, they are non-tech person, they cannot understand your terabyte and petabytes of data, and they won't be interested to aggregate and pull out the insights by themselves. They will be dependent on you so that you can present these stats in front of them. And there will be other data professionals as well who will be doing the operational related tasks. Because when we talk about processing the data on scale, distributed computation is involved, and so that we need very large scale systems, huge number of commodity hardwares and some frameworks. So we also need operations guy as well who can take care of all these things so that our system is up 24/7. So now companies understand the value of the data products, and that's why they are looking forward to hire so many data professionals for different segments. And if I can name some popular job roles in the data fields, so those are like data engineers, data scientists, data analysts, BI engineers, database admins, or we can say DBA, and Hadoop admin or cloud admin. Now I will talk about individual job profile in detail, like their role and responsibilities, what kind of role do they play in the company, their compensation, and who can take up this role. But before I start, make sure you like this video, and if you are new to our channel, then make sure to hit the subscribe button and press the notification icon. And even after watching this video, still you have any kind of doubt related to the job profiles in the data field, feel free to put it in the comment section. First, let's talk about data engineers. So the role and responsibilities of a data engineers to create scalable and optimized data pipelines. Because for the organization, they will be dependent on the raw data, and that raw data can be present anywhere. It can be a external database, it can be a different application, and we need to bring that raw data into our system. And after that, we will be able to analyze it. So there is so much engineering complexity involved here, and companies will need data engineers, and they will be acting like a frontliners because they are skilled programmers. They are the one who knows the software engineering development related things as well, all the best practices related to software engineering profile, so that they can create the highly scalable and optimized system. So that's why engineering challenges will be there, and this is the actual responsibility of a data engineer to write those custom ETL pipelines, not like using any drag and drop kind of framework where you are just using functions or any drag and drop kind of UI to make database connection and adding those transformation. No, data engineers need to use some custom tools and tech frameworks where they can write custom application in order to process the data. And once that transformed data is there, they will be loading it into the downstream system for further analysis. So they are the starting point of the data application. Any company who is solving data related mysteries, data engineers will always be there to set up that ETL pipeline on scale. Now, what role data engineers do play in the companies? So data engineers, as I said, they are the frontliners. So without them, companies shouldn't expect that they will be able to create scalable data pipelines, because they are the one who knows the engineering related stuff. There are other data related profiles as well, but they don't even bother about how that large amount of data is available in the system 24/7. So their role is very much critical in the companies. Now talking about the pay scale of the data engineers in India. At this moment, what I have seen based on my experiences and based on the facts available on the internet, on an average, data engineers are making at least 10 lakhs per annum as their compensation, and which I feel is a decent start. If you are getting this much of average salary as a beginner, that's definitely really good enough. And talking about important point, who can take up this data engineering role? And that was one of the challenge in front of me as well when I was moving into the data engineering field. So how I did that part, I tried to map my interest to this data engineering profile. I explored other data profiles as well, but I was the guy who was very much interested in the programming, very much interested in the large scale backend system, how API works, how to interact with the databases, how to pull the data, how to process the data. So if you are also in the same zone, you feel that you will be able to understand those software engineering plus data related concepts, then data engineering is the good profile for you. If you feel no, you are not that much tech savvy, then there are other job profiles which I'll talk about next. You can focus on that one. Now let's talk about the data scientist. So the role and responsibilities of a data scientist to solve complex business related problems. So once data engineers are done with their ETL pipelines and transform data is available in the downstream systems, from there the responsibilities of data scientists will start. Because data scientists are the one who are really close to the mathematics, statistics, probability, machine learning and deep learning related things. And these are the actual things which will be solving those complex data related mysteries. For an example, recommendation engine built by Amazon, Netflix, YouTube. What they are doing, these platforms are capturing the user activities, and based on the training and test data, these data scientists will try to figure out those recurring patterns so that they can observe what that particular customer is liking, because that way they will be able to recommend those kind of products or those kind of advertisement to you, and you will be clicking on those products, you will be interested in it and you will try to buy it, and that's how they will be making more and more revenues. So this is a kind of example which clearly depicts the role and responsibilities of a data scientist, and they are not the one who will bother about the pipelining, bringing data from sources to the end system. They just need the clean transform data so that they can build their accurate data models and machine learning models on top of it. Now talking about what kind of role they play in a company. So as I said, their role is very much important. Data engineers will be responsible for the pipelining part, but the data scientists are the one who will analyze the data in mathematical aspects. They will aggregate the data and will try to find the patterns in such a way so that those complex business use cases are actually solved. So their role is very, very much important. Talking about the average salary of data scientists in the India. So as of now, by 2022, data scientists are getting paid on an average 10 lakhs per annum, which is again a very, very decent start. And the salary part is something which will depend on multiple factors. Whatever I'm telling, that is based on fact, and that is based on the average or median salary, you can say. Whenever you will be interviewing in different companies, if you had a different number in your previous organization, you will be getting on an average 40 to 50% of salary hike. So that's why I'm saying salary part is something which will depend on other factors as well. If you have multiple counter offers, you can negotiate better. You can even double down this number like 25 to 30 lakhs per annum as well. So now the question is, who should take up this data science role? So as I said, if you are someone who is not enjoying the typical software engineering related stuff or creating the challenging engineering related products in order to process large volume of the data, but you are someone who want to solve the data mysteries, complex data related challenges, and want to predict something and want to add some meaningful business values in the organization, then this data science role is a good fit for you, because here you are the one who will be having those kind of mathematical skill sets, analytical, probability stats, machine learning, deep learning, which is very much required in order to solve these kind of data related challenges. So now let's talk about the data analyst. So data analysts are the one who work with lots of data to find the meaningful insight out of it, which can be helpful to point out business problems and can be helpful to discover meaningful trends and patterns from the data, and which can be leveraged in order to meet the business objective. And along with that, their main responsibility is to work with the end customers, end users, because they will be getting the requirements related to the data representation from the end customers itself. So what role the data analyst actually play in the company means kind of mediator who is working in the middle. On the left hand side, data engineers and scientists can be there, and on the right hand side there will be end customers who will interact with these data analysts that hey, we want these business matrices, and data analyst will take a help of transform data and will present those kind of matrices. So that is why the role of data analyst is also very much important in the company. They are the messenger, you can say, and they are the mediator in that entire big data solution pipeline. Now talking about the compensation of the data analyst. So on an average nowadays, data analysts are getting 6 lakhs per annum, and which is again a decent start for any of the beginner, because data analyst is a kind of role which is not that much technical, and that's why I can explain who should take up this data analyst role. So if you are someone who is having decent understanding about programming, but you are good at data analysis, you are good at creating dashboards, and you are good at the data analysis, SQL part and databases, then this data analyst profile is best fit for you. And one more advantage with this profile is that you will closely working with the end customers. You will understand the business problem more than anyone else. Like, forget about data engineers and data scientists. You are the one who understand the business really well. And now let's talk about another popular job profile, which is BI engineering or business intelligence engineer. So BI engineers are actually responsible for turning data into meaningful information, which is very critical to the business. And these folks, BI engineers, closely work with the data analysts and data engineers. Why? Because in big data, we have a concept of data warehouse and data lakes. So these are the central repositories where we will be putting our raw data, and in the data warehouses, we will be putting our transform data, which is completely structured and having different insight out of it. But who will actually decide that entire ecosystem? Data warehouse means there will be multiple fact tables, multiple dimension tables, and data engineers will be dumping data into those data warehouses. So deciding that overall relationship and setting up that integrity, deciding all those important fields, and deciding how those business matrices can be derived, how this entire ecosystem of business intelligence will be working, and even they will be helping data analysts in order to build those dashboards. That's why sometimes people treat BI engineering and data analyst as a similar role, but still BI engineering is something which is more towards the creation side, whereas data analysts are more onto the interaction part, business understanding. But BI engineer is something which will be closely working on the central repository, setting up the entire ecosystem. Now talking about what kind of role do BI engineers play in the companies. So again, their role is very critical. So these are the things which run in bits and pieces. Everyone is dependent on other job profile. Like data engineers somehow will be dependent on front and back end application. Scientists are dependent on the transform data. Same, data analysts are dependent on the end customers and whatever engineers have produced. Whereas BI engineers are setting up that entire warehouse and data lakes. So everybody is connected together. Without any of the job profile, you cannot imagine that in a company they can build a proper big data related solutions. So nowadays, on an average, BI engineers are also making similar salary to the data analyst, which is on average 6 to 7 lakhs per annum. Again, a very decent start. Now you might be thinking, who should actually take up this job role of BI engineering? So again, since this role is very close to data analyst role as well, so anyone who is very much interested in the business side of the data, right, not too much into coding, not too much into the big data frameworks and all, then this is the best profile for you. And honestly, this is a recommendation. If you are someone coming from a non-tech background, non-CS background, and you are not interested at all into the software part, then BI engineering and again previously what I explained about the data analyst, both can be a good fit for you. Now let's talk about another very crucial job profile, that is DBA or database admin. So the actual role and responsibility of a DBA is to work on the operations side. Operations, as an DBA name itself suggests that these people will be closely working on the databases side. Let's suppose a very large scale application. So its database will be also very huge. There will be n number of tables in it. There will be n number of columns in each table. So we need a dedicated system. That system, the entire database is something which is an application and when there will be a huge traffic on the databases, that application may go down as well. So continuously we should have a DBA or a DBA team who is taking care of that entire database system so that it is operational 24/7. And in big organization, whenever there is a small change in the application, there can be extra addition in the tables and even extra addition in the columns. So this is not a very simple change. It has to pass through a proper channel, and DBA are the one who will be taking care of all those things. They will be the one who will take care of the security part of the databases as well. Nowadays, data is very critical and very sensitive. If we are not putting relevant security checks on our databases, then this can break the trust of customers in case data leak happens. So that's how the role of DBA is also very much important. They will be the one who will set up that entire database, because data engineers or software engineers are not the one who will keep on creating the tables in the databases, maintaining it, taking the backup all the time and cleaning up the database server and looking at it 24/7. They have much more important work like creating the application part. So that's how DBA role is also very important in order to keep your application up and running 24/7 and also make your data very secure. And not talking about what kind of role do they play in the company. As you can understand, their role is very critical. Anything which is related to data and databases, that will be taken care by the DBAs as well. Now talking about the average pay scale of the DBA. So by looking at the complexity of the job role and the kind of operations they will be doing, on an average in India, DBAs are getting 8 lakhs per annum, which is again a very good amount for the operations role. And now the question is, who should take up this kind of DBA role? Because this sounds more like an operation or support role, but honestly speaking, very much interesting, because not everybody can move into the data engineering, data science, not everybody can become a pro coder, and there is a need of other job profiles as well. That's how DBA is into the picture. So if you are someone who is really good at the databases part, you understand the databases, whole complexities of DBMS concepts, SQL, PL/SQL, working with the Linux based system, doesn't matter you have a programming background or not, or anything very fancy related to big data, still you are a good fit for the DBA role, because your core skill, your fundamental skill is the DBMS, SQL and PL/SQL. So if you are good at it, this is the profile for you. Now let's talk about another interesting job profile, which is Hadoop or cloud admin. So the role and responsibility of this admin profile, which is more related to the infrastructure. So let's imagine the work of data engineers. They will be writing those distributed computation application, but where these applications will be executed, obviously on some cluster, and the cluster is a combination of so many number of commodity hardwares like some external hardware and machines. And obviously there are organizations who have created a whole package in order to set up and install those things which are related to distributed computations on a particular cluster. So we also need admins like most popular Hadoop admin or cloud admin who can manage our infrastructure related to the cluster. Because whenever we will be computing so many applications on our cluster, we will be storing too much of data on our distributed environment. Obviously, there is a possibility that our cluster may go down, and time to time we need to take the backup, time to time we need to clean up the space from our cluster as well. So there will be a need of person who can take care of these things. Let's say there is another team who is working on different data application and they want to access our cluster. So there will be a proper access mechanism in between. And who will take care of this part? Admins will take care of this part. They will be creating different users. They will grant the access, revoke the access, and everything which is related to the admin task, managing whole thing from the infrastructure perspective. Here, the Hadoop admin or cloud admin kind of job profile will come into the picture. Now the question is, what is their role in the company? As suggested, their role is very crucial, because when we talk about large scale production applications, you cannot imagine that 24/7 your application will keep on running without any failure. Because in the IT world, systems can fail at any particular point of time. You cannot predict that at what particular time you can expect this much of traffic on your network or on your cluster. So you have to be ready with your operation or admin teams. So in case there is very critical failure, you can fix it as soon as possible. And this becomes very much important if your application is too much customer centric. You cannot lose the trust of your customer, and it is only possible if you have that kind of admin role or you have that kind of admin folks in your team. And that is why this role is also very much important. Now let's talk about the average salary of this Hadoop admin or cloud admin related profile. So in India, as of by 2022, people are getting approximately 8 lakhs per annum for this admin kind of role. Again, you can clearly understand the complexities and the stress on these folks because they are dedicatedly monitoring that entire infrastructure and cluster. Because if anything goes down, that will be a great impact on the business, and the company need these kind of admin people who can take care these things 24/7. And that is why this much compensation is very much obvious for the Hadoop admin related job profile. Now, who should take up this job profile? So again, as I said, if you are someone who is willing to move into these kind of admin roles, who want to just manage this whole infrastructure side of the company or anything, let's say you are doing in the big data space, distributed cluster, distributed computation, distributed storage, managing those access patterns, granting access, revoking, or anything which is related to the management task, then this is the job profile for you. Again, programming is not needed here. Little bit of the SQL part, but more understanding of the big data fundamentals, how those frameworks like Hadoop, Spark, their architecture work, and how the system scale up, scale down, managing all things there. And also anything you can grasp about the cloud, that will be a plus point for you in this profile, and you can easily get a job into it. So by looking at the number of job roles available in the data field and their challenging role and responsibilities, the kind of compensation they are getting, you can clearly understand their importance and what is their future in next coming years. So data is the crucial point for every company and they are heavily dependent on it. So there is no doubt that every job profile will be needed in future. So based on your interest, you can figure out which one is the good fit for you. So I hope based on the provided details which we talked about for individual job profile, you are very clear about these profiles. You can pick it according to your interest. Myth number 1. Data analysts, data engineers and data scientists are doing the same thing, which is completely wrong. Because their job and their role and responsibility is completely different. And I know why this is getting confusing, because all these people are working under the umbrella of big data. So first, let me explain what data engineers are doing. So their responsibility is to actually work on the core engineering stuff and to create those scalable data pipelines so that the raw data can be pulled from multiple sources, then it can be transformed and it can be dumped into the downstream systems. And the data scientist and data analyst, they are dependent on this process because for them, the transformed data is something which matters a lot. Without that, they won't be able to represent the meaningful insight, and data scientists won't be able to create their accurate machine learning models. So you shouldn't get confused that all people are doing the same thing. Their skills definitely can overlap, but their responsibilities are completely different. And that's why companies are hiring people for different job profiles, else they would have hired a data professional who is doing all the things together. Myth number 2. PhD or master's degree is required to become a data scientist. This is also completely wrong, and I would say partially true, and it will highly depend on a kind of job role you are getting for. So there are 2-3 segments in the data science as well. Let's say if you are going for specifically to the research field, right? Or if you are going for the applied scientist kind of role, then in that case you need this kind of master's or PhD degree. But if you are someone who is just want to solve the complex data mysteries and want to work around the deep learning, machine learning, then you are the one who is working on the data science stuff using the libraries and using the data analysis approaches in order to create those complex data mysteries. And that's why you don't need any kind of master's degree for that. Even if you have a decent bachelor degree, even if you're coming from a non-tech background, non-CS background, you can definitely get into the data science domain. In my past experience, I have worked with so many data scientists who are just college grads, like doing BTech, BSc, MSc, these kind of thing, and they are not having any sort of master's degree, let's say MTech or MTech in the data science or any kind of PhD degree. Still they are working as a data scientist in good product based companies and making a good money out of it. In my past experience, I have worked with so many data scientists, and guess what? They are not holding any PhD or master's degree. Nowadays, everything is all about the skills. So if you have the right skill set for the data scientist, then you can definitely get into it. Based on my experience, since those people didn't have the master's and PhD degree and still they are working in good product based companies, getting a high compensation. So if they can do it, you can also definitely do it. Myth number 3, data scientists need to be a pro coder. This is also completely wrong, because as a data scientist, your job is to work on the data extensively. And when we talk about the pro coding, that means like working too much on the competitive programming side or having a very strong knowledge of typical data structures and algorithm. And honestly speaking, in my 5 years of experience, I haven't seen any data science interview process where companies are heavily focusing on data structures and algorithm knowledge from the data scientist. Definitely your problem solving skills should be good, and in the data science world we have languages like Python and R, and they provide a very strong support for multiple libraries which you can use in order to solve complex data related problems. So your focus as a data scientist should be that how you can use those libraries, how you can use different modules of it so that you can create those best data models and machine learning related models. So as a data scientist, make sure you are not wasting too much of your time in the competitive programming or practicing typical data structures and algorithm. Myth number 4, data science is only for CS graduates. For this one, my answer is no, and this is one of the most important myth which need to be busted. Why? Because I would like to share one really important fact. In the data science domain, most of the people are actually coming from non-tech or non-CS background. Very less number of people are actually moving from CS domain to this data science profile. And here I will be sharing my personal experience, even in my college time, and also I have seen this thing in my professional journey. In colleges, companies were visiting to hire candidates for the data science and associate related profile, and majority of the people who cracked those job opportunities were actually from the non-tech and non-CS background. And why? Because those people are really good at problem solving, aptitude, and understanding the business use cases. And this is one of the important thing to understand. In the data science interviews, companies are not going to focus on typical coding, DSA related things. And that's why the people who are coming from non-tech, non-CS, they can easily crack those interviews because they are good at aptitude part. They understand the case studies. They can figure out what kind of important business matrices they can pull from data and what kind of complex data related problems they can solve. So do not ever think that being from a non-CS background or non-tech background, you cannot get into the data science profile, because I'm not saying this thing. Facts are actually talking about this part. And here I would like to share my personal experience. Even I have seen this thing during my college time and also in my professional journey. So during college time, when companies were visiting for the placement, specifically for the data profile and associate related profiles, so mostly people from the non-tech and non-CS background were able to crack those job opportunities. Because for the CS graduates, their first priority is still software engineering and they want to make their career into that. And that is why in this data science domain, more and more job opportunities for the non-tech and non-CS people. So nowadays it doesn't matter if you have that kind of specific to CS related degree. Degree doesn't matter. Skill is something which will help you to land into the good job. So if you can acquire the right skill sets for the data science profile, doesn't matter you come from non-tech and non-CS, you will be able to crack this job profile. Myth number 5. Data science is only about predictive modeling. Let me talk about an interesting fact. Data scientists invest their 80% of time in cleaning and transforming the data, and 20% of their time goes for the data modeling part. So being a data scientist, if I want to create a very accurate machine learning model and a data model, I need a clean and transformed data. Because when we work on a particular big data solution, there are multiple steps involved in it. And the first and very important part is transforming the data. Nowadays, data is coming from multiple sources, and that raw data sometimes contains the error prone values and also garbage records as well. So in order to create a very accurate machine learning models, if we are not able to clean our data and we are not able to get the meaningful transformed data, without that we cannot create the accurate model. That's why data science is not only about creating the predictive model and regression models. It is a good mix of cleaning and transforming the data, and after that creating the accurate machine learning models. Myth number 6. Data science requires a strong mathematical background. This is also completely not true, because being good at the maths is definitely one of the important part of your day-to-day activities as a data scientist, because while analyzing the data, we would definitely need those mathematical concepts, let's say aggregating the data, statistics part, probability part, but that is something which is a not must to have a skill set to become a data scientist. And as we know, in the data science, we have amazing programming languages like Python and R, which provides a great support for amazing libraries as well, which we can directly use in order to perform those typical mathematical calculation and computation. So until and unless you need to innovate something or you need to create any new algorithm, you don't need to be a mathematics expert. Myth number 7. Learning a tool is enough to become a data scientist. So in the data science profile, it is a combination of multiple skills. Technical skills plus non-technical skills, both are required to become a good data scientist. You cannot just rely on programming or any specific tool which you think is getting used in data science and you are a good expert of it, then you can become a good data scientist. Because when we work on a complex data problems as a data scientist, we need to interact with multiple stakeholders. We need to work with the business directly so that we can get all the requirements. We can understand the data domain, why we are processing it, what kind of meaningful insights we can bring out from the transformed data, and how we can solve it, what is relevant and what is irrelevant. So everything is needed in this data science domain. So don't think that only technical stuff or any specific tool like a language or a database is just enough to crack the data science profile. You need your non-technical skills and soft skills as your support system to become a good data scientist. Myth number 8. Companies are not hiring freshers for the data science role. So this is the most common question which I have received from the freshers, that why companies are not hiring fresher for the data science role. So if we would have discussed this topic 5-6 years back, then this was completely true. Companies were not focusing on the freshers for the data science role. But now in 2022, this thing has changed a lot, because nowadays freshers are self-aware and self-motivated. They are very much interested to explore the fields like data science, data engineering, and they are putting their own efforts without depending on someone else to explore these job profiles. And they are also taking participations actively in the competitions, in hackathons, open source contribution, and trying to build cool projects by their own. And that's how they are able to acquire the right skill sets for the data science profile and also amazing dev skills. And that's why companies are also preferring freshers to join their company for the data science role. Myth number 9. Transitioning into data science domain is impossible from the different job profile. So let's say if you're coming from a data related background, let's say you worked as a data engineer, data analyst, business analyst, then this transition will be easy for you because you already know about the data, how to work in it, different tool and tech frameworks. But if you are coming from the different job profiles as a testing profile or a software engineering profile, then transition into data science is not impossible. It will be challenging. What you need to do, you need to work on right skill set, you need to acquire those skills, and you need to work on some realistic projects which you can showcase in your resume, and you can prove your capability that how much you are interested for the data science profile and what value you can add into the company as a data scientist. Myth number 10. Data science competitions are going to make you an expert. So data science competitions are definitely a good idea to acquire the right skill set and also to get a feeling of data science environment and even to acquire the dev skills. But if you think that by taking participation in hackathons only and to create projects in the competitions can help you to become a data science expert, then this is not true. It will definitely boost your resume. It will add good values in your resume so that you can showcase your good work and what kind of achievements you have. But if you actually want to be an expert, then you need to work on some realistic use cases or a production level application. And for that, what I would suggest to all the freshers, you should target the internships. Like you are in your final years, you can try to get internships via off-campus opportunities. It can be a remote internship or it can be in any of the startup, so that you can get a overall feel how to work on data science, what kind of projects you can create, and those valuable real production level application as a project you can mention in your portfolio, and that will give a great weightage to your profile. You can showcase your skills, and based on that you will be getting interview calls from amazing companies, and you can also crack the interviews of them.
A data scientist is in charge of generating actionable insights from the data and building accurate machine learning model that can help the business grow. A machine learning engineer is a professional that takes next step and put this model into the production that faces the user queries directly. While data scientist and machine learning engineer have a lot in common, their pathway differs early from their career itself. Consider these two relationships as passing of a baton. Data scientists use statistical technique to develop the right machine learning strategies. They also identify right model to feed into the machine learning model. Machine learning engineer takes the next step and put that model into the production where it ensures the model works correctly. Data scientists have a STEM background or even higher degrees such as PhD in biology, mathematics, to name a few. Machine learning engineers are having the background in software engineering. Machine learning engineers are specialized in scalable software engineering such as model deployment and putting them into the production, while data scientists are more related to model building. Data scientists must have proficient knowledge of data mining algorithms like bagging, boosting, generalized linear model, deep learning, and some statistical concepts. While machine learning engineers need solid understanding of software development lifecycle plus some basic knowledge of feature engineering and model building. Now we have seen the differences between these two roles. Let's move further and check the roles and responsibility expected from each role. Roles and responsibilities. The main objective of both of these positions to use the data and solve complex problems. However, the difference lies in terms of their responsibilities. Let me give you guys a brief overview about the responsibility of each of these roles. Now, let's get into roles and responsibility of a machine learning engineer. Think of a machine learning engineer as a specialized software engineer with the knowledge of machine learning. Machine learning engineer uses basic data science knowledge to put the model into the production. Now let's discuss some general responsibilities of a machine learning engineer. ML engineers are responsible for handling software architecture and data pipeline end-to-end and make sure data flows smoothly into the production. They also work with stakeholders to understand more business needs and scope. Post-production, ML engineers also work on eliminating errors and deploying the model successfully. They also do some kind of model optimization. The part of some of the data science work is also machine learning engineer's responsibility. Now, we have understood the roles and responsibility of an ML engineer. Let's do the same for the data scientist. According to Harvard Business Review, data scientists spend 80% of their time in just cleaning of the data and rest 20% in model building and validation. On a lighter note, data scientists are one step ahead of data analysts whose primary responsibility is to collect the data, examine and find unique trends. In many business scenarios, these terms, data scientist and data analyst, are interchangeable. Here are some of the general responsibilities of the data scientist. Data scientists are responsible to examine the data and find the valuable extract out of it. That means you need to spend time with the data. Next is about features. You have to find the right measurable features from the data. After you find the features, you have to build the predictive models. Once the model is ready, you have to show your result to the stakeholders for the approvals. And finally, you also have to work with data engineering team to make sure your model works properly in the deployment environment. These are some generic responsibilities of an ML engineer and a data scientist. Now let me tell you what a role of ML engineer and data scientist look in an organization like Twitter. Twitter look for machine learning engineers who can improve their existing search and recommendation engine. They should also know about user intent for business relevancy. And they also need to team up with software engineering and data science team to put the ML solution in Twitter's tech stack. As a data scientist in Twitter, you will get the access to the Twitter data which you can use to design and deploy your statistical models. You can use machine learning, deep learning, and graph approaches to identify relevancy between people and show them the right content. You also need to know about crowdsourcing and some of the labeling efforts so that you can reduce the human approaches. So this is about day-to-day responsibility of ML engineer and data scientist. Now let's look at the compensation, what is offered on these roles in different regions. First, let's look into the salary of a machine learning engineer. According to Glassdoor, the average yearly income of an ML engineer in United States is $131,000. Meanwhile, in UK, 51,000 pounds, and in India, it is 8.9 lakhs. Now, we have understood the salary of an ML engineer. Let's do the same for the data scientist. According to Glassdoor, the average yearly compensation for data scientists in United States is $117,000. Meanwhile, in UK, it's 46,000 pounds, and in India, it is 11 lakhs. Although both of these career options have very similar salary range, but we can say both are very well rewarding career options. By now, I believe you get a better understanding of what is the difference between these two roles. Now, if you're convinced enough to pursue either of them, let's take what is the ideal roadmap for these roles. Roadmap for an ML engineer. Programming language is a necessary skill for ML engineers. If you want to put your model into the production, you need some kind of coding language. Not only the language knowledge, but also you need some libraries like TensorFlow, PyTorch that can help you put your model into the production. I have two programming language options for you guys, Python and R. Python is the most popular language for data scientists. It uses everywhere, including Google, Amazon, Instagram, Facebook, and many other tech companies. These companies also provided some great set of libraries like TensorFlow, PyTorch, OpenCV, PySpark to make your life easier. With the help of Python, you don't need to focus on writing code from the scratch. You can just use these libraries and focus on your business impact. R is the second most popular language for machine learning engineers. With over 2 million users and 18,000 plus open source packages, R is very much popular in statistical inferences and building the model visualizations. With the IDE support like RStudio, generating graphs and managing the library is very easy. Not a big fan of coding? Don't worry. Machine learning can be done with the help of some graphical interfaces like BigML and Weka. However, some basic coding skills are needed to enter in the field of machine learning. If you want to specialize in machine learning, you don't need a lot of mathematics because you have a lot of libraries and packages available. But a good knowledge of linear algebra, probability calculus will make you a great machine learning engineer. Machine learning algorithms needs data to solve business problems. Data cleaning is a crucial part in machine learning. A clean data can multiply the performance of your model. The tasks needed in data cleaning are handling the missing data, handling the outliers, removing the bad data, and fixing the structural errors. The next phase of machine learning engineers' roadmap is to learn machine learning concepts. You need to have some basic knowledge of supervised learning, unsupervised learning, and reinforcement learning. Once you are done with learning algorithm, the last step in this roadmap is to learn about deep learning. Deep learning contains deep neural network that is used to solve some highly complex tasks. For example, today, speech recognition, voice recognition, natural language processing, computer vision, face recognition, all uses deep learning techniques. Roadmap for a data scientist. Mathematics is the backbone of data science. If you are a beginner and you want to become a data scientist, you need a strong foundation in mathematics. That includes some of the concepts like linear algebra, probability, differential equations, metric decomposition, and calculus. Mathematics is more enjoyable when you put your work into the actions. There are a good number of libraries available which have ready-made functions for you to use. For that, you need some basic programming language. I recommend you to start with Python because that has the most useful libraries and a lot of functions are predefined. Once you mastered coding, the next step in this roadmap is to learn about algorithms. You can start with supervised learning algorithm. After that, you can go for unsupervised learning and reinforcement learning. Once you complete this, you can go for deep learning algorithm. You should also know about parameters of your model so that you can tune it for the improved performance. You also need to know about the key differences between different algorithms. You might have heard this popular phrase, jack of all trade, master of none. Like everyone, data scientists also have their own biases. They are very well versed in some of the specific subdomains like natural language processing or computer vision. I recommend you to work with different professionals and build your knowledge in different data science areas and applications. Practice makes one perfect. As you practice your skills on more data science problems and data sets, your skill will improve. Wondering where and how to start your data science and machine learning journey? Scalar has a perfect solution for you. Join Scalar's Data Science and Machine Learning program and land to your dream job. That's it from my side.
What exactly is data? So, whenever we talk about data, just look at different things around you. On a daily basis, what is it that you're doing? So, let's say you go to Amazon or Flipkart or whatever shopping site it is, and you make some online transaction. What are you doing over there? You are generating data. Similarly, let's say you have an Instagram account and you upload pictures onto your Instagram account. What are you doing over there? Again, what you're doing is generating data. Similarly, you have a Facebook account. Let's say you put up a post that could be a written post, it could be an image, it could be a video. So what are you doing over there? You again, my friend, are generating data. Similarly, we have a lot of these streaming sites. We have YouTube, we have Vimeo, and so on. And when you upload videos onto these different streaming sites, what you're basically doing is generating data. And especially right now, we are sitting on huge amount of raw data. Now, here you have to understand the difference between data and information. So those folks who are watching right now, if you guys could let me know what is the difference between data and information, let me know. I'll wait for a bit. I'll just add that question over here. What is the difference between data and information? So let me just put that up in the chat for you folks. Now, if you guys have any idea of what is the basic difference between data and information, let me know. And it doesn't have to be perfect. Whatever you think is the difference, just put it up over here. So Vineet Khandelwal is saying data is raw. That's correct. Anyone else? Anyone has any opinion on what is the difference between data and information? Well, information is making sense of data. That's absolutely correct, Vineet. So whenever we look at data, so let's say if I give you a huge Excel sheet, and that Excel sheet probably has 10 million rows and probably 1 million columns. And if you are just looking at this huge Excel sheet, what you're looking at is raw data. So when you're just looking at raw data, you do not have any information from it. But let's say from this huge Excel sheet, which has 10 million rows and 1 million columns, when you try to find out simple information. So let's say from this huge Excel sheet, if you're trying to find out maybe, and if this Excel sheet is pertaining to college students, and you're trying to find out, which student has scored how many marks in the mathematics exam year on year. So what you're trying to do is finding out information from this raw data. And this basically is the entire point of data science. So let's come to the main part. Let me write down the main question over here, which is basically what is data science? So simply put, you have raw data all around you, and that data is coming from a lot of sources, and that data is present also in a lot of formats. Now, if you'd have to make sense out of those raw data, or if you'd have to find out some business insights out of that raw data, what you can do is you can apply some data science techniques on top of it. So you have a lot of data science techniques, and those data science techniques, basically we call them as ML algorithms, and you apply these ML algorithms and you find out beautiful information from that raw data. So this basically is the essence of data science. So I hope you guys are clear on what exactly is data and what exactly is information. So now that we understand what is the difference between data and information, and also we understand what exactly is data science, we shall look at the life cycle of data science. So let me put up the next topic over here. Let me just write it down as life cycle of data science. So whenever we talk about the life cycle of data science, the first stage in any life cycle is acquiring data. So let me just show that to you over here. So the first step in the data science life cycle is to collect data. Now, let's say you have a client coming up to you with a problem statement. Now, that problem statement could be related to any domain. It could be a healthcare domain problem. It could be an e-commerce related problem. It could be probably a blockchain related problem. So what you're basically doing over there is, when you have the problem statement, your first step needs to be to collect data from all of the sources. So let's just take a simple example over here. Now, let's take an example of a food delivery app. So this is just a very new food delivery app, and the problem statement is such as this. So it wants to increase its customer base. So if it wants to increase its customer base, it has to understand how its customers are behaving, and also how can it increase its market share. So the first step, and what the company has to do is collect all of that data and analyze that data. Now, this could be the data which is present of their own customers, or this could also be the data of their competitors. So let's just say we have this food delivery app. Let's just name it as, let's call it Food Delivery X. So we have a food delivery app. Let's call it Food Delivery X, and it wants to increase its customer base. The first step needs to be collect data, and collect data from multiple sources, and not just its own customer data, but also understand how its customers, how its competitors are playing the field. And here you'd have to understand that this data is present in multiple formats. So either you can just have simple raw data, which is basically log files of all of the customers. That is something which you can have. Apart from that, you can have data in the form of images as well. Apart from that, you can have data in the form of videos as well. So right now, especially in the current digital age, and also where we have pandemic, almost everyone is online. So there, the first step needs to be, let's say if I am a data scientist at this particular food company, what I'd want to do is I'd want to collect all of this data, and probably I'd also go through some of the some of the sites such as Twitter, Facebook, and LinkedIn, and I'd also want to see what are customers currently talking about my food delivery app. So this stage is very, very important in any data science life cycle. Vineet Khandelwal is saying collect data, data wrangling, and then analysis, and then predict. So that is sort of right. Yes. So in the first step, what we are essentially doing is collecting the data. Now that we have collected the data, the problem with this is it is raw data. So we have collected the data from everywhere, but it's quite raw. The problem with this raw data is it will have a lot of missing values. It will have a lot of outliers. It will have a lot of anomalies. And if I give you a simple example, so let's say if we take that same Excel sheet, which has around 10 million records and 1 million columns. Now, in that huge Excel sheet, there might be cases where, let's say, some of the rows are empty. There might be cases where the column names are incorrect. There might be cases where some of the values are they totally do not make any sense. So these are outliers or anomalies or missing values. And once you collect this raw data, your next step needs to be to clean all of this data. And here what you're doing is you're converting this untidy data into tidy data. So it is as simple as that. So you have collected your data, you have cleaned your data. Now, after you do that, what you'd have to do next is basically you would have to manipulate your data. And when we say data manipulation, what you're basically doing is exploratory data analysis. So once you have your tidy data, on top of that tidy data, you sort of employ some data manipulation as well as data visualization techniques. So let me give you certain examples of data manipulation and data visualization. So whenever we talk about data manipulation, again, we have this huge Excel sheet which has millions of records. And out of this entire sheet, if I'd only want to look at, and this again is, this would tell me about the different details of a particular college. So from this huge Excel sheet, if I'd want only those details where, let's say, all of the students have scored more than 90 marks in their maths exam. So I don't want records of only those students where the students have scored greater than 90 marks in their maths exam. What I can do is I can deploy some of these data manipulation or data wrangling techniques. And for this, I have different languages. I can either use something as simple as SQL. I can just use an Excel sheet probably. So all of this can be done in the Excel sheet too. I can do this with the help of Python. I can do this with the help of R. So I employ different data manipulation techniques and I can find simple insights from this raw data. Now, apart from this, I also have something called as data visualization. So with data visualization, what I do is, so again, if I just show you this huge Excel sheet, which has all of these records, the problem is I wouldn't be able to understand anything by just looking at this huge Excel sheet. Right. So I just have this huge Excel sheet right in front of me. And if I'm just looking at this huge Excel sheet, I wouldn't be able to figure out anything. I wouldn't know where is the head of it. I wouldn't know where is the tail of it. So for me, the best option would be to sort of create simple graphs on top of this or simple imagery on top of it. So on top of this huge Excel sheet, which has millions of records, what I can do is I can just create probably a bar chart or a pie chart or a histogram. And on the basis of that, I'll be able to understand simple insights. And also it has said, so a picture speaks more than 1,000 words, isn't it? So instead of just looking at the data, if someone actually shows me a beautiful picture of that data, I'll be able to understand much more from that. So I hope this is clear. So we collect the data. So when we collect the data, that data is quite raw. The next step would be to convert this raw data into tidy data. And we convert that raw data into tidy data. Next, what we have to do is we have to employ certain exploratory data analysis techniques. Over there, we have data manipulation and data visualization. After this, we head on to machine learning. So in machine learning, this is where we have certain intelligent algorithms. So for now, let's just call these as intelligent algorithms. And we shall be applying these intelligent algorithms on top of the tidy data which we have. And we will be applying these algorithms on the basis of the problem statement. So let's say if the problem statement is such that I do want to divide my customer base into different groups or different clusters. So what I'm doing is I'd have to group them or I'd have to cluster them. So here I have an algorithm such as k-means, or I have other clustering algorithms as well. Similarly, let's say I'd want to probably determine by how much can I increase my market share in the next quarter. So let's say in this particular quarter, I have a revenue of around, let's just say around 10 crore rupees. I do want to predict by the next quarter, how much revenue can I generate? So for this, I can use an algorithm such as linear regression or probably random forest regression. So on the basis of the problem statement, I shall use a particular machine learning algorithm. So once we apply an ML algorithm on top of our raw data, we shall get a result. But it is not necessary that the result which we get is 100% correct, right? So let's say the target was to predict how much our company revenue will be in the next quarter, and I've built a linear regression algorithm for that, and this linear regression algorithm will give me some sort of result, and it's definitely not necessary that it will give me 100% result, and in most of the cases, or in general, it will not give you the 100% accurate result. So this is where what you'd have to do is you'd have to evaluate the algorithm, or you'd have to tweak the algorithm again and again. And this is where, so if you're working with Python or R, you have something called as hyperparameters. So you keep tuning or you keep updating these hyperparameters so that you get that perfect accuracy with respect to your machine learning algorithm. And once you get that perfect accuracy, that is when you can say that the result which you get is actually correct. And that is when you finally go ahead and show your result. And now, whenever you are talking about showing a result, you are probably showing it to your customer or to your client. And in most of the cases, your customer or your client would not be as technologically or technically savvy as you. So here, what you'd have to do is represent your result using really beautiful graphs or really beautiful dashboards. And you'd have to do it because data visualization is also a very important skill set of a data scientist. So you as a data scientist might be able to understand all of this technical jargon quite easily. But put yourself in your client's shoes or put yourself in your customer shoes who probably wouldn't even know the D or A of data science. So that is where if you create some beautiful dashboards, they'll be properly understand, they'll be able to interpret your result easily. And this is the entire data science lifecycle, my friends. I hope this is clear for you. So now that we understand this, so we have understood what exactly is data. We have understood what is data science. We have also looked at what is data science lifecycle. Next up, we shall look at certain applications of data science. So first application is obviously finance. So whenever we talk about finance and banking, so there are certain roles such as financial analyst. So you have financial analysts working in the banking sector or in the trading and stock market sector because you have a lot of fraudulent cases happening. And one of the simplest case over here in a bank to understand with respect to data science is to figure out if the person who takes a loan would be able to repay your loan or not. So as a bank, you obviously will again have a large number of customers, probably in millions, and it is not feasible for you to give out a loan for every person who applies for it. So there you will check different factors. So probably you will check at the age of the person, you'll probably check the gender of the person, you'll check the salary of the person, you'll check if there are any defaulting cases by this particular customer. You will again check in what area is he living. You will check what is his work experience. You will check, probably if he has a house or not. So you will evaluate all of these. And these are what you call as your independent variables, or these are your factors. So you'll understand all of your factors, and understanding these factors, you shall probably decide whether to give this person a loan or not. And all of this can be automated by using simple data science algorithms. So here you can use simple binary classification algorithms. So you have different classification algorithms such as logistic regression, random forest, decision tree, and so on. So you can use these different classification algorithms. And what you can do is on the basis of all of these factors, you can probably create an automation app which would tell you to whether to give a loan to this person or not. Probably this algorithm could also give you a percentage of how much percentage of by how much this person can default. Right? So let's say if the default rate of this person is around 95%, which would mean that definitely or most definitely this person would default. On the other hand, let's say the default rate of this person is in low double digits, which could be 10% or 12%, then you might be more inclined to give this person a loan. So these sort of algorithms can be applied in the finance sector. So I'm just checking if there are any questions over here. So that was the finance sector. Next up, we also have the healthcare sector. So right now in this pandemic, People are trying to understand the spread of this particular disease. People are trying to understand when will the third wave come in India, or when will will probably give out all of the doses properly. So all of this research can be done using data science. So I shall give you certain simple examples over here. So you do not need to be an expert in data science. If you just know some basics of data science, what you can do is you can probably understand how the coronavirus has spread across different states in India, or probably even across different countries. And all of this data would be available to you across free open source sites. You have sites such as Kaggle. So you can just go on to Kaggle and you will have multiple data sets related to the spread of coronavirus and so on. So what you can do is you can just go ahead and go through that data set, browse that data set, and you can find out simple insights on, let's say, from when the pandemic started and how many cases have been increased since the last 2 years when it actually had started. You can probably compare how the virus has spread by comparing different states. So you can probably compare a state such as Karnataka and compare it with probably Maharashtra, and understand how many new cases have come up, how many people have recovered, and so on. So these are different things which you can do in the healthcare sector as well. Then next comes marketing. So marketing is something where data science is used a lot, because marketing folks, they normally have targets to increase their market share, to bring more awareness to their particular brand. And here, data science plays a vital role in understanding the customer sentiments. So here we a particular and a very interesting example of data science is known as sentiment analysis. So if you're actually able to gauge the sentiment of your customer, if you're able to gauge whether your customer sentiment is positive or negative or neutral, then on the basis of that, you can probably tweak your product. So let's say there is a shoe manufacturing company, there's a shoe brand, and it launches a latest, new shoes over there. So what it can do is the data science folks in that particular company can just go on to Twitter, Facebook, or LinkedIn and probably understand what are different customers talking about their latest launch. And if it's positive, well, that's good for them. If it's negative, that is also good for them, because they can go back and tweak their product a bit. So here, using sentiment analysis, again, you can use different algorithms, use sentiment analysis, and have probably a score over there, right? So let's say if the score is between 0 and 1, and if it is above 0.5, you can probably say that the sentiment is positive. If it is 0, or if it is less than 0.5, you can probably say that the sentiment is negative. So all of these things can be done in the marketing side of things. Then we have entertainment. So the simplest example of how data science is used in entertainment could be all of your streaming services, and one of your best streaming services, Netflix. And Netflix has this really amazing recommendation engine. And how do you think this recommendation works? Well, the answer, my friends, is data science again. So what Netflix uses is something called as user-based collaborative filtering, where it is user-based collaborative filtering and item-based collaborative filtering, where, let's say, if you normally watch something related to sitcoms. Now, let's say if I watch this TV show Friends and I add it to my watch list, since it is a sitcom, since it is a comedy genre, Netflix will recommend similar sort of shows to me. Right? So this is a simple recommendation engine, which is an example of data science. So I hope this is clear to you, folks. So these are some applications of data science. So now that we've understood all of these basics, in today's particular session, what I'd want to do is I'd want to start off with one particular algorithm, which would actually be linear regression. So let me open up Jupyter Notebook over here. So I hope you guys can see this properly. So let me just write down a comment over here, linear regression, and I hope you guys can see this. And linear regression is a machine learning algorithm. Now, in machine learning algorithm, it can broadly be divided into 3 categories. So let me just write that down as well. So if we have machine learning, so you can probably divide it into supervised learning. You have something called as unsupervised learning, and you also have something called as reinforcement learning. So you have supervised learning, you have unsupervised learning, and you have reinforcement learning. Now, I'll give you a brief example of all these three different things. So let's start off with supervised learning. So let me write down supervised learning over here. And when it comes to supervised learning, what you can possibly understand over here is, let's say you have data and that data is associated with labels. So to give you a simple example, so let's say I have this water bottle with me. Now I'll just not have this water bottle, but I'll also have a label. So I'll have a text which would say water bottle. Similarly, let's say if I have this phone with me, I'll not just have this phone, but I have a text which will say that this is a phone. And this is the basic idea behind supervised learning, where you're dealing with data which has labels. And here you have something called as an independent variable and a dependent variable. So you have two things. I shall write that down. You have something called as dependent variable, and you have something called as an independent variable. And you normally try to understand how does the dependent variable change with respect to independent variable. So you can probably denote this dependent variable with y, and you can denote this independent variable with x. And what you're basically trying to find out is y as a function of x. So when you say y as a function of x, y is your dependent variable, x is your independent variable, and we are trying to understand how does y change with respect to x. And this is your simple underlying philosophy of supervised learning. And here both your x and y, you have data and you also have labels over there. So to give you a very simple example over here, let's say I do want to determine probably, so let's say if someone passes the exam, I'd want to understand what is the probability of a student for them to be a girl student or for them to be a boy student. And I'm giving a very, very simple example over here, right? So here my y is, let's say, girl slash boy. My x is pass slash fail. So let's say it just so happens that my data is quite skewed. I have 10 students in the class and there is a particular subject. And in that particular subject, it just has happened that out of the 10 students, we have, out of the 10 students, we probably have 5 girls and 5 boys. And all of the 5 girls have passed the exam and all of the 5 boys have failed the exam. And if I take this very data and if I feed it to this particular algorithm, so let's say if a new student comes in and if that new student is a girl, then probably the result, this algorithm will predict that the new student will pass the exam. On the other hand, let's say if a new student joins and if that new student is actually a boy, now even though, so that student is really brilliant, and in reality, that student might actually pass the exam, but due to my skewed data, this algorithm will predict that the student will fail the exam. So this is how, or this is the basic idea between supervised learning. And also in supervised learning, we have something called as classification and regression. So supervised learning can be further subdivided into something called as classification. Then you have something called as regression. And in this particular live session, we'll only focus on one thing, which is linear regression. Let me write that down properly. And before I move forward into linear regression, let me see if you guys have any questions. So Sandeep says, hello, everyone. Hello, Sandeep. I hope you are doing well too. So when we talk about linear regression, just take the simple formula over here. I shall just write down y is equal to mx plus c. So when I write down y is equal to mx plus c, what is happening over here is, here again, since linear regression is a supervised learning algorithm, here y would be my dependent variable, x would be my independent variable, and I'm trying to understand how does y change with respect to x. And here, this is the equation of a linear line. So, probably you would have learned about this in your 8th or 9th standard. You would have learned about linear equation of a line. And this is how the linear equation of a line looks like. So this is your dependent variable and this is your independent variable. And it's not necessary that you can only have one independent variable. You can have multiple independent variables as well. So when I say you will have multiple independent variables, this is how your equation shall look like. So here I shall write down y is equal to m1 x1 plus m2 x2 plus m3 x3 plus c. So here y is a dependent variable, and this dependent variable is probably dependent on your multiple factors, which are x1, x2, and x3. And this is the basic idea behind linear regression algorithm. So once we've understood this, what we shall do is I shall open up RStudio and we shall look at a simple example of linear regression. And before we do that, we shall also do a bit of data pre-processing as well. So let me just open up RStudio for you guys. So this is RStudio. So if you never used RStudio before, let me just give you a glimpse of it. This, what you see, my friends, is known as the script window. This is where probably, let's say, if you'd want to write a huge script, this is where you shall write your entire script. This is your console window. This is where you'll be executing all of your commands. So let me just write in a simple command over here, 3 + 7. You shall see that I have successfully executed this. Then you have this environment window over here. Here you shall probably have all of the commands which you have done so far. So I have this history command, and these are all of the commands which I have executed so far. Then here you have, if you'd want to install some library, so you can just click on install over here, given the name of the library. So there would be certain libraries such as deployer. You have a library called as ggplot2. You have different libraries. You can just click on that and click on install, and all of these libraries would be installed. Now, in this particular session, we shall probably focus on both R and Python, and both of these are really important languages when it comes to implementing any of the data science tasks. And the specialty of R is it is a language which is developed by statisticians for statisticians. So if you're dealing with any statistical problem, however complex it is, then R is your best friend. It is your best tool to go with. And if you want to do probably any visualization, then R again is a really good tool for that. So there is a particular library in R called as Shiny R, and with the help of Shiny R, you can create beautiful dashboards straight out of this. So this is a simple example of RStudio for you guys. And now that we know this, what I'd want to do is I'd want to give you guys certain basic idea of what we can do over here. So let's look at certain basic things. So if you'd want to do any operations over here, you can just do those. So let's say if I want to add two numbers, I'll just write down 12 plus 23. I can just execute that over here. And then we have simple variables. I can just go ahead and create a variable. So I'll have variable a is equal to 10, and I'll have another variable b, and inside this I shall store 20. So here you have seen that I've just created these two variables. Again, I shall write down a plus b. You will have 30 over here. So these are some basic operations which I can perform. And now, since the topic for today is data science, let me actually open up a data set and perform some, data manipulation and data science techniques on that. So by default, we have this data set called as Iris, which is stored in RStudio. So let me just open that up. Here I shall write down view of Iris. So this, with the help of this view command, I can look at a data set. So this is the data set which I have. This is inbuilt in your RStudio. Now, if I want information about this, what I can do is I can just give in a question mark over here, and I shall write down Iris. And you would see that in this help window, I have information about this entire Iris data set. So Edgar Anderson's Iris data And this famous Fisher's or Anderson's iris data gives the measurements in centimeters of the variables, sepal length and width, petal length and width. So you basically have this iris flower over here, and this iris flower has 3 different species. So these 3 different species are Setosa, versicolor, and virginica. And for those 3 different species, you have details about sepal length, sepal width, petal length, and petal width. And this is one of the most basic databases or data sets that you shall work with when you are beginning out as a data science enthusiast. Deceit Gaming is asking, do I really need to learn R to master in data science? So when you say mastering about data science, it has different pillars. And learning R language is just one of that pillar. So I'll just give you in brief about what are those different pillars. So first is obviously statistics and math. And as a data scientist or as a data science enthusiast or as a data science beginner, what many people find it difficult is get started with the maths of it or the statistics side of it. But it is extremely important that you do not ignore the statistics components of data science, because that is the building block of data science. So if you're good with the statistics fundamentals, if you're good with the math fundamentals, that would form the foundational stone for you to further learn other important or other complex topics in data science. So first step is master probably the statistics fundamentals, the math fundamentals. After that, what you can do is you can probably start with basic steps such as data manipulation and data visualization. Then going ahead, you'd have to, now when I say master data manipulation and data visualization, again, you would need certain tools for that. So data manipulation, probably as a beginner, you'll start off with SQL. After that, you can pick up languages such as Python and R. So one thing which I'd like to tell you folks is both of these languages are quite similar. So if you know Python, then you can easily pick up R. Similarly, if you know R, you can easily pick up Python. So both of these are dynamically typed languages. Both of these are object-oriented programming languages, and both of these have sort of a similar syntax to work with. And if, let's say, if you know Python, then it is sort of quite easy for you to pick up R as well. So pick up R and start implementing these tasks. So first pillar is statistics or math. Next pillar is your programming language. Next pillar is obviously your ML algorithms. So it's not just necessary for you to directly implement all of these ML algorithms by the libraries which you're using. Also try to understand the underlying concept behind all of these ML algorithms. So that would be quite helpful for you. So I hope that answers your question. Aniket is asking, can one become a good data science learner beginning with Python? So when you ask, can anyone become a good data science learner beginning with Python, the answer would be yes and no. As I've said, Python is again only one component. So if you are good with Python, now it opens up a lot of doors for you. So here you'd have to decide what you would actually want to do with Python, right? So because if you only know Python, then probably you'd have to choose, if you can create web applications with Python, you can create gaming applications with Python, you can probably become a full stack developer, you can probably become a backend developer, you can create games, or if you actually want to venture into the field of machine learning, then you look at also other pillars of data science. So start learning the ML concepts, start learning the stats concepts, and start implementing them with Python. So if you ask, is Python enough to become a data scientist? I'd say no. And if you're asking, is Python important to become a good data scientist? Then I'll say yes. So it is one of the pillars necessary to become a good data scientist, and it is not the only pillar. So I hope that answers your question, Aniket. Great. So now that we have looked at this particular data set, what I'd want to do is I'd want to do certain basic manipulation on top of this data. So to perform data manipulation, I have this library called as deployer. So to open any library over here, I shall just use library. Inside this, I shall pass in the name of the library, which is deployer over here. I have loaded this. So now that I have loaded this, what I want to do is, so let's say from this entire data set, I'd want to extract only those records where the sepal length is greater than 5. I shall write something like this. So here I shall write iris filter, and here I shall give in the condition sepal length is greater than 5, and I shall go ahead and store it in a new object. I shall call that object as iris SL. Now let me have a glance at iris SL, view of iris SL, and if you look at the sepal length column of iris SL, you shall see that all of the values over here are greater than 5. Right, so what I've done is a basic data manipulation, and I've been able to do this by just using one particular line. And this filter method, which you see, is part of the deployer library. So if you do want to work with this filter method, you'd have to load the deployer library first. And what I've done is from the iris dataset, or on top of the iris dataset, I have applied this filtering operation, and I've filtered out all of those records where the sepal length is greater than 5, and I've stored it in this iris_SL. So I hope this is clear to you guys. Now, similarly, let's say from this entire original iris data set, I do want to extract all of those records where, let's say, the petal length is greater than 2. I shall write a similar command over here. I shall write down iris. Let me put this down properly. I shall give in the filter command, and inside filter, I shall write. So I would want all of those records where petal length is greater than 2. So let me write down petal dot length is greater than 2. And I shall store this in a new object called as iris PL. And let me have a glance at this view of iris_PL. And if you look at this petal length column, you shall see that all of the values are greater than 2. And if you look at this 32 to 49 of 100 entries, which would mean that, so in total, this data set has 150 records. So out of those 150 records, I have 100 records where the value of petal length is greater than 2. Similarly, let's say, again, let me dive into this a bit deeper. So out of 150, I have 100 records where petal length is greater than 2. Similarly, let's say I want all of those records where petal length is greater than 3. So here I shall write down iris filter petal length is greater than 3. I shall store this in iris PL3 view of iris PL3, and this is what I get. So here it seems that I have 99 entries. So out of the 150 entries, I have 99 entries where the petal length is greater than 3. So this again is an interesting insight, which would mean that there is actually one record where the petal length value is between 2 and 3. So this is quite interesting, which you have over here. Ashish is asking, could you start Java also? Yes, we actually have a plan of starting a live session series or probably uploading videos on Java too. And that is something which we shall definitely do. And also this weekend, what we are doing is we are doing a marathon live session on C++. So our instructor, Satyasai, he shall be doing a marathon live session on Saturday and Sunday. So if you do want to get expertise in C++, please do attend that live session. So we shall probably, make it live anytime soon, and you can join us this weekend. So now that we have understood about this, again, what I'd want to do is I'd want to make simple visualization on top of this. And to make visualization on top of any data, I have a library called as ggplot2. So let me actually install that library packages. I'll click on install, and let me give in the name of the library, which is equal to ggplot2. And probably this shall take a couple of seconds for the library to be installed. Right, so we have successfully installed this library. Now that we have installed this, let me go ahead and load this library. So to load any library, I just need to use library. Inside that, I shall write down ggplot2. And over here, what I'll do is, I'll start off by writing ggplot. And onto this, I need to map in the data for which I need to make a graph. And the data which I'm working with is iris. So data, iris. After this, I need to use this parameter called as aesthetic. So here aesthetic would mean the metrics onto which I map my variables. So here, let's say I'd want to understand the relationship between sepal length and petal length. And I'll map the sepal length onto the x-axis and petal length onto the y-axis. So here I shall write x is equal to sepal dot length and y is equal to petal dot length. So I'm building a scatter plot on top of this iris dataset where I'm mapping sepal length, this particular column, onto the x-axis, petal length, this particular column, onto the y-axis. And since I have to make a scatter plot, so to make a scatter plot using ggplot2, I have this command called as geom. This would be actually point. So let me just select geom point over here and let me run this. And this, what you see is the scatter plot result between sepal length and petal length. So hopefully you guys can see this properly. So on the x-axis, we have sepal length. On the y-axis, we have petal length. And as you see, the sepal length value increases, the petal length value also increases. So you can sort of say there is a linear relationship between the sepal length and petal length. So also this is a positive linear relationship. So as and when the sepal length value increases, the petal length value also increases. So let me just go ahead and close this out over here. Now, if I want to add certain color onto this, what I shall do is I'll take this same command and inside this, I want the color to be determined by the species column. So I have the species column and I'm mapping the species column onto the call aesthetic over here. Now, when I run this, you would see that I have 3 different colors over here. And now when you see, so I have 3 different colors. I have these pink colored dots, and these pink colored dots show all of those records where the species is setosa. I have these green colored dots, and all of these green colored dots are records where the species is versicolor. And similarly, I have all of these blue colored dots, and these determine where the species is virginica. So I have created a simple scatter plot, and also we can make some simple inferences over here. So out of these 3 species of iris flower, I can clearly say that the lowest petal length and the lowest sepal length would be of the setosa species. And the maximum petal length and the maximum sepal length would be of the virginica species. So these are the sort of simple inferences which you can make from this. Let me also again close this up over here. So these are basic things which you can create. Again, let's say if I want to make a simple histogram for any of these columns, that is something which can also be done over here. So what I shall do now is probably create a histogram for this sepal length column. Let me clear this. Again, I shall use ggplot onto the data aesthetic. I shall again use iris. Now after this, I shall have aesthetic. And I shall have only one attribute over here. So normally whenever we are making histogram, we use histogram for univariate analysis. And when I say univariate analysis, we are basically observing one observation at a time or one variable at a time. So here onto the x-axis, I map sepal length. Let me write down sepal dot length over here. And what I want to do is, I map sepal length and I'd want to make a histogram. So let me just write down geom histogram over here. And I've successfully created this histogram. Now let me also add certain color to this. So here I shall use a fill color. I shall write down fill is equal to pale green 4. And I shall also give a boundary color over here. I shall write call is equal to green. And let me zoom this up, and this is what you shall get. So I've created a simple histogram for the sepal length column. And over here, what you can probably understand is, let's say, so majority of these observations over here. So this, what you see is the sepal length value, and this, what you see is the number of records over here. So I have probably around 11 records. So I have 11 records where the sepal length is around 6.5. Similarly, I have very few records. Probably I'll have one record over here where the sepal length is almost equal to 8. Similarly, I shall have only one record over here where the sepal length is probably around 7.1 or 7.2. So this is exactly this 10 mark over here. So I shall probably have around 10 records where the sepal length would be between 4.8 to 5. So again, all of these interesting metrics can be found out by using this histogram. So hopefully this is clear as well. Now what I'd want to do is I'd quickly want to create a linear regression algorithm for this. And since today's topic is introduction to data science, and I have also said that we'll be covering one particular algorithm, what I'd want to do is I'd want to build a linear regression algorithm on this particular data. And since linear regression, I would need a dependent variable and I'd want independent variable. So here I'd want to determine, again, how does sepal length vary with respect to petal length. So here sepal length would be my dependent variable, petal length would be my independent variable. So to create a linear regression model, I have this method called as LM. And in LM, I'll just write down, let me write down sepal dot length over here. I'll give in this tilde symbol. And here I shall write down petal dot length. And here I shall write data is equal to iris. So I'm creating a linear regression algorithm. Here, what this basically means is, this is a linear regression algorithm where my dependent variable is sepal length and my independent variable is petal length. So whatever you give on the left side of the tilde symbol, that would be your dependent variable. And whatever you give on the right side of the tilde symbol, that would be your independent variable. So this is the formula. After you give your formula, you'd have to give in the data from which this formula comes in. So sepal length and petal length obviously belong to the iris dataset. And I'm creating this linear regression model over here, and I shall go ahead and probably store this in a new object, and I shall call this as linmod1. I've created my basic linear regression model. Now let me actually go ahead and predict the values. So to predict the values, I shall use predict. This takes in two parameters. First parameter is the model which you built. So the model which I built is linmod1, and obviously test data is again the data which I'm using. So here I shall write new data, and new data again is iris over here, and this I shall go ahead and store it in a new object and call it as lin result1. So let me show you lin result1, view of lin result1, and this is what I have over here. So I have certain values. Now what I'd want to do is I'd want to find out the error in prediction. So if I'd want to find out the error in prediction, what I can just do is find out root mean square error. So this might be a bit complicated for you guys, but just bear with me right now. So probably in the future sessions, you shall probably understand what exactly is root mean square error and why are we doing this. So right now we have predicted something, but it's not necessary that the value which we get is actually correct. So what I shall do right now is I shall create a new data set, and what I want to do is I shall use cbind over here. With the help of cbind, I can combine different columns. So from the iris data set, since my dependent variable is sepal length, I shall take sepal length, and I shall take lin result1, which are the predicted values. And since this is actual, I shall call this as actual. Since this is predicted, I shall call this as predicted over here. And I shall store this in a new object and call this as new iris. Now let me have a glance at new iris. So new iris, what I have are my actual values and the predicted values. So folks, we have just built our linear regression algorithm. These were the actual values which were present in the data set. And what we've done right now is using the linear regression algorithm, we have also predicted these values. So very simple application of how you can do it using our language. So folks, I hope this is clear as well. And I believe we're also done with today's time. Hopefully this was quite informative to you folks. So also just a quick information, today at 9 o'clock, we have another live session taken by Mohit Yadav. And he shall be taking a live session on system design, and it will be a live mock interview on system design.
Let's break down data science into its two components, which basically are data and science. Now, we have the social media site called this Instagram, and whenever you upload photos onto Instagram, what you're doing is generating data. Similarly, if you upload videos onto any streaming service, what you're doing again is generating data. And if you do any sort of online transaction, guess what? You are generating data. Now, if we apply certain scientific techniques on top of this raw data, we get valuable information that can be used for varied purposes. And this is the process of data science. So in this video, we'll properly understand the entire data science life cycle through this simple example of how we cook. So let's get started. Let's say a client comes to you and gives you a problem statement. Now, for you to approach this problem statement, the first task would be to collect data. So this first stage is known as data acquisition or data collection. And what you do over here is you collect data from all the sources, from all the multiple sources. And this data will also be present in multiple formats. So to understand this through the analogy of how we cook. So let's say if you'd have to cook a certain dish, what you do is you collect all of your vegetables first. And all of these vegetables would be different. So you'll have capsicum, tomato, potato, onion, and so on. Now, if you apply the same thing to data science, what you're doing is you're collecting all of your data, and that data can be present in the form of a CSV file, a PDF file, a Word doc, and so on. So in the first stage, you collect all of these data items. Now, once you collect all of these data items, the problem is all of these data items are pretty raw, or they have a lot of untidy elements present in them. So in the second stage, you'd have to clean your data. Now, in terms of cooking, what I do is once I have this raw data with me, I'd have to clean this data. So let's say I have this bowl of water. So I'll just put my vegetables into this bowl of water and I clean my vegetables. And if you have to understand this in terms of data science, what we do is I take my raw untidy data and I remove out all of the anomalies, outliers, and whatever other things I do not require. And once I convert my untidy data into tidy data, this is where my data cleaning is done. After this, once I thoroughly clean my data, I'd have to understand my data in a better way. And over here, this process is known as exploratory data analysis. Because what I'm doing is, I am properly understanding the underlying features of my data. So in terms of cooking, what I do is, once I have my proper tidy data with me, I chop it down into simple parts. So here what I'm doing is I'm wrangling the data, or I'm managing the data or manipulating the data so that I can further understand the interesting properties of it. So this is exploratory data analysis. And after exploratory data analysis, once I have chopped up my data and properly understood its interesting features, what I'll do is I'll go ahead and apply certain machine learning algorithms or data mining algorithms on top of it. And this is the main part of any data science lifecycle. So depending on the problem statement, you can apply a classification algorithm, a regression algorithm, or a clustering algorithm. So Again, in terms of cooking, what I'll do is I will have a cooking utensil. So let me just take this cooking utensil and let's just consider this as our ML algorithm. So what I'll do is I will feed my data into this ML algorithm. So I'll take all of these chopped up data items and I will put them up into my ML algorithm. Now, once I put all of these into my ML algorithm, what I'd have to do is I'd have to properly train my data. So just you can consider as me training the data items. Now, once the training is done, what I'll get is the final result. So let me also get my final result. So here what I have is my final result. So I've applied my ML algorithm on top of my data and this gave me a particular result. It's not necessary that the result which I get is correct. So what I do over here is I evaluate the result and this stage is known as pattern evaluation. So what I'll do is I'll just go ahead and taste what I've cooked. So it seems like this might need a bit of salt. And this is where I evaluate my data and I keep hyper-tuning it or I keep tweaking it so that I get the optimal result. Again, in terms of cooking, what can be understood over here is since this lacks a bit of salt, I also have salt ready. So I'll just put 2 or 3 spoons of salt into this so that I get my perfect dish ready. Now, once I have my perfect dish ready, I can go ahead and serve it to my guests. And this stage is known as knowledge representation. So once everything is set, I'll go ahead and serve this particular dish to my guests so that they can go ahead and happily eat it. In terms of data science, once my final result is set, I'll go ahead and show this to my clients in the form of beautiful graphs or beautiful dashboards so that they can use it for better business insights. So folks, this was all about data science and we've understood the process of data science through the simple example of cooking. So thank you very much for watching this video. And if you find this video insightful, do not forget to like this video and also subscribe to our channel. Thank you very much and let's meet in the next one.
You all would have heard this term at least once in your life. Such is the kind of buzz that artificial intelligence or AI has created. Almost everything in today's world uses AI in some way or the other, be it your daily Netflix recommendations or predicting the stock market prices. With more and more data being generated each day, the need for technologies like AI is now more than ever. So what really is artificial intelligence? AI is the science of simulating human behavior in machines that are programmed to perform tasks like humans and mimic their actions. Any machine that exhibits human-like traits such as problem solving and learning constitutes AI. Ever wondered about how a Tesla drives by itself from one place to another without the intervention of any humans? This is possible due to AI. You would be surprised to know how that AI is not a new technology. It all started with the simple question, can machines think, which was asked by mathematician Alan Turing in the year 1950. A side note, Alan Turing was the man behind decoding the Nazi encryption machine called Enigma, which led to the victory of Allied forces in the World War II. The term artificial intelligence was first coined in the year 1955 by John McCarthy from Dartmouth College, Nathaniel Rochester from IBM, Marvin Minsky from Harvard University, and Claude Shannon from Bell Telephone Laboratories. The first artificial intelligence program, The Logical Theorist, was presented by Alan Newell, Herbert Simon, and Cliff Shaw at the Dartmouth Conference in the year 1956. The program was designed to mimic humans' problem-solving skills and went on to prove 38 of the 52 theorems of Principia Mathematica by Whitehead and Russell. From imitating mere problem-solving skills to currently building driverless cars, we can see the significant improvement of AI over the years. Now, how does AI work? The main principle of AI is feeding input data, processing it, analyzing it for any patterns or correlations, and then using these patterns to make predictions or future decisions. Therefore, it emphasizes on 3 human-like behaviors: learning, reasoning, and realizing. Learning. In this stage, the main focus is to acquire data and make rules or algorithms as to how we can turn that data into something useful. After defining a certain number of algorithms in this learning stage, we now have to choose which is the best one for the task. This is done in the reasoning stage. In the realizing stage, the algorithms are trained over and over again with the right data to ensure that they provide accurate predictions and make important decisions. With that, now we will look into four major subdomains of AI, namely machine learning, deep learning, natural language processing, and robotics. We will now be discussing these in detail. Firstly, let us look at machine learning. Machine learning or ML is the idea or the science of computer programs that can automatically learn from their previous experiences and adapt to the new challenges without any human intervention. It is one of the most used and demanding fields of AI, and that is the reason we'll be discussing it more in detail. The machine learning algorithms are coded in certain order to perform tasks, analyze, and predict information from the given data. And depending on the type of data that is available and what they want to be predicted out of the data, ML algorithms can be divided into three types. Supervised learning. Supervised learning algorithms are the most commonly used type of algorithms. You may ask why. It is due to the fact that they're simple and easy to implement. The input is in the form of label example pairs, which are usually in a text, spreadsheet, or a CSV file. These label example pairs are fed one by one to the learning algorithm, allowing it to predict the right label for each example. The algorithms are focused on one single task or a problem. An example of a label example pair is as shown below. Here you can see that the employee name, employee ID, gender, position, department, and employee satisfaction are all attributes of one dataset. Moving on to the next one, unsupervised learning. We can say that supervised and unsupervised learning are two extreme ends. Here we do not give a specific target for the model, nor do we give it a feedback. Instead, the machine only has to find a way to learn by itself. Input data is usually in the form of unlabeled data and unstructured data, which is basically data that contains missing values or unknown data. Examples of unstructured data include text files, flat files, system logs, etc. Moving on to the next one, we have reinforcement learning. The models in reinforcement learning are trained to make not one, but a sequence of decisions in an interactive or a complex environment by using the feedback from its own previous experiences and decisions. Here, the models use trial and error methods. An example of this would be self-driving cars. The input data here consists of data from a wide variety of sensors on the car. If you guys want to know more about machine learning, there is a dedicated video for that, for which I'll be providing the link in the description box down below. Moving on to the second subdomain of AI, deep learning. Explaining this will be easier now as we already know what machine learning is. We can say that it is a type of AI that teaches a computer to behave exactly like that of the human brain. From the learning stages to predicting and classifying information, a deep learning network processes and analyzes data like how a normal human brain would process it. This is done with the help of neural networks. Neural networks are a set of algorithms that are modeled after the human brain, with recognizing patterns as the main motive. Structure of a neural network consists of a number of nodes, which are loosely designed to compute like that of a neuron in the human brain. Typically, neurons are arranged in a series of layers. The input layer, which receives various forms of data from the outside world. The hidden layer, this is where the computations happen. This layer consists of many units and its main job is to convert the input data into something that can be used by the third layer, which is the output layer. An analogy of deep learning would be that of a child who is learning a new language. The next subdomain of AI is natural language processing, or NLP as it's commonly called. NLP deals with communication between humans and machines by natural language. The technique involves processing of human languages and it enables the computers to read and understand data, mainly by imitating human natural language. In layman words, NLP algorithms try to break down the language into shorter, simple pieces, understand the correlations between those pieces, and determine how the pieces can be put together to create meaning. NLP is important as it makes it possible for computers to hear speech, read text, interpret it, and determine which parts of the text or speech are useful. Some of the applications of NLP include speech recognition, Twitter's sentiment analysis, which is used to filter hate language from various tweets, and spam detection. Lastly, we'll move on to robotics. As the name suggests, robotics involve the programming and designing of robots. Robots are often deployed to perform tasks which are laborious and difficult for humans to perform. Robotics is probably the only field where software, electronics, and mechanics are brought together. It has computer programs that tell the robot what, when, and how to perform a particular task. It consists of mechanical components for performing that task, and it has electrical elements for providing power and controlling the machinery. Some of the main applications of robotics are manufacturing, military applications, outer space applications, and health service. With the number of applications of AI increasing each day, people might only think of one question: will AI eat up jobs in the future? Not all the applications of AI are the same as factory automation or robotics. Industry sectors which involve manufacturing goods and products thrive on efficiency and low cost. They would save so much investing on AI when compared to investing in human labor. In fact, some factories in the world have already made their complete process automatic, and there are more factories which will follow the same feat in the future. But there is no need to panic because reports from various giant firms state that AI will create a plethora of new jobs. Experts also think that if anything AI will do in the future, it will be creating new jobs. The jobs we don't even know that they existed in the first place. In fact, PwC predicts that over the next 20 years, AI will create around 7.2 million jobs in the UK alone. That being said, yes, it will displace some jobs, but not all the jobs in the world. I hope this gave you some clear cut insights on what AI is, how it works, and the subdomains of AI. Please do subscribe to not miss out on more such content. Keep learning and good. According to Harvard Business Review, data scientist was named the sexiest job of the 21st century. Such is the impact for the newfound love of data in today's world. That being said, what does a data scientist do? What are the key skills one must possess to start a career in data science? What are the average base salary trends in the field of data science? We will be answering all of those questions in this video, but before moving further with what a data scientist does, like, share, and subscribe for more such amazing content. What work does a data scientist do? Firstly, let us understand data science in a simple manner. Data science is the idea of using algorithms, processes, and systems to uncover hidden patterns from the data, which is at hand. An example of this would be discovering customer shopping habits using their previous shopping experiences data. Now, to achieve data science, data scientists are a vital part of the process. A typical data scientist's role includes combining mathematics, statistics, and computer science knowledge. Data scientists extract the data which is available, interpret and analyze it, and share the insights with the respective groups. Working as a data scientist needs you to be equipped with technical skills such as programming, data visualization, machine learning methods, and social science skills like maths, statistics, communication, and business knowledge. Let us now discuss these skills in brief. Firstly, let us discuss about maths and statistics. This is no surprise, but every good data scientist has a strong building foundation on both maths and statistics. Statistical concepts like probability, mean, median, variance, distributions, and standard deviation play quite an important role in shaping yourself as a data scientist. And mathematical concepts like linear algebra and calculus are also key as they are used by most machine learning algorithms. With a strong background in statistics and maths, we can say that you're on the right track to become a data scientist. Programming concepts. To go from a drawing board to actually creating real-world applications require a data scientist to be strong in at least one of the programming languages. Two commonly used programming languages for data science are Python, which is a high-level language, and R, which is a low-level language. Apart from these languages, one has to have a basic understanding of programming concepts like databases, data structures, algorithms, object-oriented programming concepts, and functions. If you want to learn more about these programming languages such as Python and R, there are in-depth videos on those for which the links will be provided in the description box down below. Data visualization. can be referred to as one of the key components required to become a data scientist. And also, it includes the most fun part as well. Since the whole of data science revolves around data, it is important to transform that data into a format that is easy to interpret and understand. As a data scientist, you must be able to achieve this with the help of data visualization tools such as Power BI, Tableau, and the simplest of them all, Excel. With the help of these tools, one can create interactive visualizations or dashboards to convey the insights. Now that we've talked about data visualization, a data scientist also needs to have strong verbal communication skills, as most of the work includes communicating with stakeholders, company executives, and different departments. You want to be able to ask the right questions to the stakeholders and adapt to their needs. Emphasize more on the 5 W's: the what's, the why's, the when's, the where's, and who's, and one H, which is the how. Keep in mind that communication is also one of the most important skills required to become a successful data scientist. Machine learning concepts. We can say that data science can also be achieved without machine learning, but a basic knowledge of some of the most commonly used algorithms can take you a long way. Since a large number of data scientists are not proficient in this area, one can easily make a difference or stand out from the other data scientists with the knowledge of ML techniques such as regressions, decision trees, and neural networks. Each of these techniques can be used for various applications in the field of data science. Now, coming to business knowledge. It is true that data scientists require a level of business knowledge to effectively use the available data to derive meaningful conclusions. Firstly, one has to understand the objectives and goals of the business, connect with all the stakeholders to get a better understanding of the problem at hand, and be able to create solutions to reach certain expectations. There are a variety of roles that you can choose from in the field of data science. Each of these roles have a different job that needs to be done. A data scientist is someone who designs algorithms and predictive models to analyze the data. The average base salary for a data scientist in India is about 9 lakhs, and when it comes to US it is around 119,000 USD per annum. Data analysts usually deal with identifying the patterns and relationships from the large data sets to obtain meaningful insights. A mid-level data analyst earns somewhere between 6 lakhs to 8 lakhs per annum in India, and this amount in the US is about 67,000 USD, according to Indeed.com. Business analyst's job involves prediction of a particular business's performance in the future with the help of the available knowledge and the past performances. Average base salary in India is 6 lakhs, and in the US it's 74,000 USD per annum. Data engineers take care of the data preparation part, which involves data cleaning and data organizing from various sources and make it available all at a single storage called the data warehouses. In a year, the mean base salary for a data engineer in India is about 10 lakhs and 125,000 USD in the US. Note, since this is just the basic salary, the actual sum is even more. Like we discussed earlier, each of these job roles are different and they involve different responsibilities to be taken care of. For example, data scientists develop algorithms for data modeling, where the data analysts identify patterns and trends by examining the datasets. Since data scientists require more technical knowledge when compared to that of a data analyst, it is considered to be more of a senior role. Additionally, data scientists often move to senior roles, which means more pay as and when they get experience. So there is definitely a better chance for career growth in this vast field.
Now, before I start off, just give me a quick confirmation if you can hear me properly and see me properly. Let me also verify it from my side as well. Let me check if everything is proper. If you can hear me properly. So I see that the sound is proper, the video is also proper, and also if you guys can give me a quick confirmation, you can just give me a quick thumbs up or just write down yes in the chat window, whatever works. So there are 6 people right now. Can I get a thumbs up from everyone or yes from everyone? And also, I want this session to be quite interactive. So if you have any questions, any suggestions, please put them up in the chat window and we shall definitely take them up. Now, also, before I start off, I'd request you guys to also subscribe to our channel if you haven't yet subscribed to, because that would encourage us to keep putting up high quality content, high quality technical videos on a regular basis. And also, we'll be doing these live sessions on a regular basis as well. And also, please do like this video. This will help the YouTube algorithm to bring in more people onto this video. Great. So on that note, let me go ahead and share my screen over here. So folks, I've opened up Jupyter Notebook, and this is just an ID which we'll be using to perform all of our tasks today. And let me guide you through what we'll be doing. So we'll start off by working with some of the basic libraries in Python, which would be pandas and seaborn. So pandas is a library which is used for data manipulation. Seaborn is a library which is used for data visualization. And then we'll go ahead and perform certain exploratory data analysis tasks on top of the COVID dataset and also on top of the IPL dataset. So this is going to be really interesting. Now, if you have again any questions, if you haven't worked with Python before or any of the languages before, you can just put up your queries in the chat window. I'll parallelly take them up. Now, these two libraries which we'll be covering are really important. So I hope that your basics are properly covered. So the first and most important library for any of your data analysis tasks or data science tasks would be your pandas library. And pandas stands for panel data. Now, with the help of this particular library, you can go ahead and create single dimensional data structures as well as two-dimensional data structures. And we'll be mostly focusing on the two-dimensional data structures, which are known as data frames. Now, to give you a simple analogy, let's say if you have worked with an Excel sheet before, or if you work with SQL before, you will have something in a tabular format, isn't it? And you're storing data in that tabular format. So pandas provides you something on a similar lines, and that is known as a data frame. And this data frame has rows and columns, and you store your data over there. Now, my task would be import pandas. So this is a library and I'd have to import it. So I'll write down import pandas as PD. Now, PD is just an alias to import this library. Again, most of the coders are lazy. So every time if I want to invoke some functions inside this library, or maybe use some subroutines inside this library, instead of writing pandas every time, what I can do is I can just write down PD, because we are just lazy and we just need a shortcut for that. So I can use PD whenever I want. So now that I have imported this, let's go ahead and create the data frame. Now, to create a data frame, you shall write down pd.dataFrame, and here you'd have to keep in mind that D and F are capital. Now, if you give either of these are small or both of them as small, then this particular method will not work. I've written down pd.dataFrame, and what I want to do is, let's just say I want to create a simple marks data frame over here. And for this, I am creating a dictionary. And inside this dictionary, I'll have the key over here. Let me just have the key as, I'll call this as student name, and I'll have a list of values. So let's say the first student is Alex. The second student is, let's call him Ram. The third student is, let's say, Chan. So we have three students over here, or names of three students over here. Going ahead, I'd also want marks of these students. So I'll have the next key, and the next key I will give it as student marks. And for this, I would want to give in a list of values as well. So here, let's say Alex has scored around 45 marks. Ram has scored 67 marks. And then we have Chan, who has scored 78 marks. Now that this is set, all I have to do is go ahead and execute this. And what this gives us is a data frame. So this, what you see, is our simple two-dimensional tabular structure. So here, the keys which we gave, student name and student marks, those we have as the column names over here. And as you see, Alex, Ram, and Chan, these are basically your values. And these values, you have them stored as records. Similarly, you have these marks over here. These marks are also stored as records. So if you'd want to create a data frame from a dictionary, what you're doing is the keys become your column names and the values become your records. Now, if I'd want to give in a name for this data frame as well, let me go ahead and call this as student data. I'll execute this. And this time when I print out student data, you will see that I've successfully created this data frame. And this, folks, is the basic essence of a pandas data frame. Hopefully you're following till here. Let me just go ahead and see some more questions over here. Avijit is asking, good evening, is Python better than R when it comes to data science? That's a really good question, Avijit. So the answer is very simple. Both of them have their own applications. Now, when you only talk about R, so R, very simply put, it's a language which was developed by statisticians for statisticians. So if you'd want to do any sort of statistical analysis or exploratory data analysis or maybe even visualization, then R should be a go-to language. But on the other hand, if you'd want to do heavy machine learning stuff or deep learning stuff, then Python needs to be a go-to language. And also a major distinguishing factor over here would be most of the people in academia or most of the people who are stats grads or mathematics grads who would prefer R over Python, and most people in the industry would prefer Python over R. So both of them have their own applications, and it would totally depend on what is it that you'd want to do. So hopefully that answers your question. Priya is asking, is Seaborn better than Matplotlib? So that's a very interesting question, Priya. The simple answer is yes, because Seaborn is a library which is built on top of Matplotlib. So you can consider that Matplotlib is version 0 and Seaborn is version 1. So the visualization which you create with Seaborn will obviously be better than Matplotlib. So I'll you guys can keep putting up your questions over here. I'll take them up parallelly. And also, folks who have joined in new, if you haven't yet liked the video, click the like button. And also, if you haven't yet subscribed to our channel, click the subscribe button. Great. So now that we've had a basic introduction to this, let's also see how can we load a CSV file. So what we've done over here is we've created a data frame, isn't it? But we would also have a lot of CSV files. CSV files are essentially your tabular data. And if we want to directly load those CSV files, that is also something which we can do. So here, I'll write down pd.read_CSV. Very simple function over here. And let me open up the home page over here. And here you will see, let me just use Command F and let me write down .csv. You will see that I have a lot of CSV files over here. Now, out of this, there's a CSV file called as iris.csv. Let me just go ahead and open that up or store it in a new object, and I'll call that object as iris. So using this read_CSV, I've loaded this file and I've stored it in a new object. Now you'll have to remember that I can give it any name. I've given it the name of iris because that is the name of the file. Now, if I want to have a glance at the first 5 records of any data frame, I have a method called as head. So when I write down iris.head, I will get the first 5 records of this data frame. Now, what is this iris file? Iris file represents a species of a flower or 3 different species of a flower called as iris. So you have a flower iris, and that iris flower has 3 different species, which would be Setusa, versicolor, and virginica. And for these 3 different species, you have the different attributes over here. And these different attributes would be sepal length, sepal width, petal length, and petal width. Now, if I want to do simple analysis on top of this, let me just go ahead and what I'll do is I'll cut all of this out so that this is much more clearer to you. I have this head method right in front of me. Now, let's say from this head method or from this iris data frame, if I want to extract only those records where the sepal length value is greater than 5. So right now, if you look at these 5 records, you will see that I have some values where the value is less than 5, isn't it? But if I want to extract all the records from this iris data frame where the sepal length value is greater than 5, let's see how can we do that. I'll write down iris. Inside this or inside the parenthesis, I need to give in the condition. So what is the condition? Sepal underscore length should be greater than 5. Now, when I enter, you will see that I have a bunch of true and false values. So what does this exactly mean? And now you get a true value wherever this condition is satisfied. So here for index 0, you have true because 5.1 is greater than 5. Next, you have 4 false because 1, 2, 3, and 4. 4.9 is less than 5. 4.7 is less than 5. 4.6 is less than 5. 5, it's not greater than 5. And it's also not, it's not greater than 5. And since it's not greater than 5, this is also evaluated to false. So basically, this condition will give you only trues wherever it is satisfied. Now, what I'd want to do is I'd want to select this entire thing over here. I'll cut this out and I will paste this in the iris data frame, which would give me only those records where this condition is satisfied. Now, if I go ahead and hit enter, here you shall see, if you look at the sepal length column, you shall see that all of the values which are present in this column, the value is greater than 5. So this is how we can do simple extracting from whatever data frame we have. Now, if I want to store it in a new object and give it a new name, let's say I don't want to store it as iris SL5. Let me hit enter. And now when I open this iris SL5, you will see that this is my new object over here and this has all of the values. Now analogous to the head method, I also have something called as the tail method. Again, let me just go ahead and erase all of the stuff from this. I'll write down iris.tail. So as the head method gave us the first 5 records in a data frame, similarly, the tail method would give us the last 5 records in a data frame. Right? So that is pretty much the only difference. And also by default, the head or the tail method will give you only 5 records. Now, instead of 5 records, let's say if I want the last 3 records, let me just write down 3 over here. And when I hit enter, you will see that I've got the last 3 records from this. Similarly, if I want the last 10 records, I'll put in 10. And when I hit enter, you will see that I've got the last 10 records from this. So simple stuff. This is how we can work with the head method and the tail method. Let me again have a glance at the head method over here. Let me change this to head and I'll only keep the 5 records over here. Now, from this, if I want to know what is the type of this, I can just use type. Inside this, I'll pass an iris. You will see that this is pandas.core.frame.data frame, which would mean that this is a data frame type. So now again, from this entire iris data frame, if I'd want to extract only 2 columns, so if I'd want to extract only the sepal length column and the petal length column, now for that, what I'll do is I'll give in the name of the data frame, I'll give in 2 parentheses, and I'll only give in the names of the columns which I would want to extract. So I'd want sepal length and I would also want petal length over here. So I've extracted sepal length, I've extracted petal length, and I will store this in, again, let's say iris length attributes. I'll execute this. Now when I run this, you shall see that from this original data frame, which was this entire thing, I've extracted only 2 columns over here, which are the sepal length and the petal length. So hopefully this is clear till now. Let me head back to chat and see if there are any more questions. Arjun is asking what is the difference between series and data frame. The answer is very simple. Series is a single dimensional data structure where you have data only arranged in a column. And when it comes to a data frame, you have rows and columns. So it's a 2-dimensional data structure. Rakesh is asking how long is the session? So this will be for 1 hour and probably this will end around 6 o'clock. So folks, if you have any more questions, put them up in the chat. I will be taking them up. So this is everything or the basic fundamentals of the pandas library. Now we'll go ahead and work with the visualization library, which is Seaborn. Now, as I said, Seaborn is built on top of matplotlib. So first, let me go ahead and import matplotlib. So for that, I'll have from matplotlib import pyplot as plt. And after this, I'll also import Seaborn. So I'll have import Seaborn as SNS. So these are the two libraries which I've imported. And now let's make a very simple line plot. And for that line plot, I'd actually, so SNS or the Seaborn library would also have certain built-in data sets. So that's a data set called as fMRI. So SNS dot data load data set. I'll give them the name of the data set, which is fMRI. Let me go ahead and store it in another object called as fMRI. And let me have a glance at this fMRI dot head. What I've done over here is there's an inbuilt dataset called as fMRI in the Seaborn library. I've imported this. Now this has all of these different columns over here: subject, time point, event, region, and signal. Now I'd want to make a line plot. And for this line plot, what I'll do is I'll probably have the time point at the bottom and the signal at the top or on the y-axis. So time point will be on the x-axis, signal would be on the y-axis. So to make the line plot, I'll also add a comment over here. Let me put in as line plot. Here I'll write down SNS dot line plot. Now I want to give something onto the x-axis and something onto the y-axis. So here I'll have x is equal to, I'll have time point, and onto the y-axis I'll pass in signal. Then going ahead, both of these columns are coming from a data set called as fMRI or from a data frame called as fMRI, and this is what we get. Now, after this, if I do not want this metadata, I'll just have plt.show. And this is our result. Hopefully, all of you can see this properly. So on the x-axis, what you can see is the time point, and that starts from 0, goes on till 17.5. So let's say this is the time unit, or the time metric is seconds. So this starts at 0.0 seconds, goes on till 17.5 seconds, and you have the value of the signal over here. So this starts at 0, has its peak at 0.15, then it goes beneath 0, and then it sort of stabilizes or stagnates at the value 0 again. So this is sort of interesting, isn't it? And now, if you look at this properly, if you look at this data, we have something called as an event, and there would be two different events over here. And if I want to have a glance, or if I want to make a line plot for both of these different events in the same graph, that is something which I can do. So here I have an attribute called as hue, and onto the hue attribute, I'll be mapping the event column. And now when I run this, you will see that I'll have two lines. So here the blue colored line represents the stem event. The orange or the crimson color line represents your hue event. So this is how we are creating a simple line plot. So folks, again, if you have any questions, put them up in the chat. Right, so this is how you can create a line plot. Now let's also see how can we create a scatter plot. Again, let me delete this entire thing over here. Let me also remove this. And for the scatter plot, we'll be using the iris data frame. So now let me write down pd.read_csv. I'll have iris.csv. Again, let me go ahead and store it in iris over here. I'll hit enter. Let me have a glance at the first file record. So I'll have iris.head. So now that I have this, I'd want to make a scatter plot between the sepal length column and the petal length column. So I'd want to understand if the sepal length varies, how does the petal length vary according to it? For this, I'll write down sns.scatterplot. Onto the x-axis, I'll be mapping sepal length. Onto the y-axis, I'll be mapping petal length. And then probably since both of these columns are coming from the iris data frame,
I'll set data is equal to iris, and I'll write down plt.show over here, and this is what you get. Let me also add in a title over here. So I'll have plt.title, and the title I'll set as sepal length versus petal length. And now when I run this, you have the title sepal length versus petal length. On the x-axis, you have sepal length. On the y-axis, you have petal length. Well, this is interesting, isn't it? So this seems like there's a linear relationship between the sepal length and the petal length, which would mean that as the value of sepal length increases, the value of the petal length also increases. Now here, when earlier we loaded the iris data frame, I had mentioned that this iris flower has three species, which would be Setosa, versicolor, and virginica. And if I'd want to distinguish those three species using different colors, that is something which I can also do. So here what I'll do is I'll use the hue attribute again, and onto the hue attribute, I will be mapping the species column. And now when I run this, you will see that I have dots of three different colors. And if you look at the legend over here, you will see that the blue color dots represent your Setosa species, orange color dot represent your versicolor species, your green color dots represent your virginica species. Now, if we want to draw some inferences, it would seem that the Setosa species would have the lowest value of sepal length and petal length, and your virginica species would have the highest values of sepal length and petal length, and versicolor somewhere lies in the middle. So hopefully this is clear till here. So we've looked at the basics of pandas, we've looked at the basics of seaborn as well. Now what I'd want to do is I'd want to sort of do a mini exploratory data analysis or a mini project on top of the COVID data set. And we'll be using both the pandas data frames as well as the seaborn data frames for this. So let's start off with this. I'll write down import pandas as PD. Then I'll import matplotlib and seaborn, both of them. I'll have from matplotlib import pyplot as plt. Then I'll write down import seaborn as SNS. So these are the three libraries which I'm importing, and these are the only three libraries which I'll be needing for this project. Now I need to load the data set. So I'll have pd.read_csv. I have a file called as covidindia.csv. So I'll have covidindia.csv. Let me store this in an object called as COVID. Let me show it to you guys. So I'll have covid.head, and you shall see that these are all of the different records which are present. So we have S number, which is essentially the row number. That's pretty much it. You have the date. Now, this is the date on which the number of confirmed cases were recorded, or the cured cases were recorded, or the number of deaths were recorded. So it would seem that on this seems to be 30th of Jan or 2020. So on 30th of Jan 2020 in Kerala, there was one confirmed case. On 31st Jan, there was again one confirmed case. On 3rd February, it seems that there were 3 confirmed cases in Kerala. Now, this is whether this person was an Indian national or a foreign national. And you have the number of cured cases, the number of deaths, and so on. This just tells you from which state or which union territory was this person from. So hopefully this is clear about the data set. Arjun has some state as well. Sure, we'll definitely do that. Probably will cover 2 to 3 states, right? So folks, just give me a quick yes if you understand what this data set is about. What are we going to do on this? Right. Also, if you have any more recommendations, let's say if you're from Bihar and you'd want me to analyze the Bihar state, I'll do that, right? Or let's say if you're from maybe Andhra Pradesh, if you want me to analyze how is the COVID situation in Andhra Pradesh, let's also do that. Okay. So now that we've looked at the head, what I'd want to do is I'd want to clean this up a bit. Now, out of all of this, I wouldn't require some of the columns. I wouldn't require S number. I wouldn't require the time. I wouldn't require whether this person is Indian national or foreign national, because I have this final column over here, which just tells me the total number of confirmed candidates. So what I'll do is I'll write down COVID, and from this, I'll only select the columns which I need. So I'd want the date column. I'd want state slash union territory column. Then I'll have the cured column. Going ahead, I'll have the deaths column, and then I'll also have the confirmed column. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So out of the 9 columns, I'm selecting only the 5 columns because these are the ones which are important to us. I'll select this entire thing and I will store this back into COVID. Let me run this. Now, when I have COVID.head, you will see that from this entire data frame, I've extracted only these. Now, let me make it even more simpler. What I'd want is, so you'll see that this seems to be a really long name. Now, instead of state slash union territory, I just want the name of the column as state. Similarly, all of these are in capital letters. Let me just go ahead and convert the column names into small letters, because that's more easier for me when I'm analyzing. So again, let me just go ahead and cut these out from here so that we have more space. So this is our head. From this, what I'd want is I'd want to rename some of the columns, or all of the columns. I'd write down COVID.rename. I have an attribute called as columns, and I'll use a dictionary to change the original names. Let's say the actual name is date, and here what I want to do is I just want to change this D from capital to small. Similarly, next up I have state slash union territory. So state slash union territory, and this I'd only want to keep it as state. So the key, inside the key you'll give in the original name. For the value you will give in the name to which you'd want it to be changed. Now, let me actually run this and show you the results. So if you look at this is the original data frame. If you look at this particular result, you will see that date has been changed like this, where D is small. Again, state slash union territory has been changed like this. Let me store it back into COVID over here, and I'll run this. Now, when I show you guys COVID.head, this is what I have. Again, I have cured, deaths, and confirmed. In here as well, I have the first letters to be capital. I'd want to make them to be small. So I'll write down COVID.rename, and here I'll use the attribute columns. Again, I'll give in a dictionary over here. What I'll do is I want to change the name of the column cured. I'll give in this. I'll write down cured. Then I have deaths. Probably I'll just make it even more simple. I'll just keep it as death. Then I have confirmed, and I'll keep it as confirm, just confirm over here. And again, I'll go ahead and store it back into COVID. Now that this is done, let me again delete this entire thing from this, and I'll do COVID.head. And when I perform COVID.head, this is what I have, right? So initially we started off the really huge data frame where we had 9 columns. Now we have truncated it into this very simple, nice looking data frame which we have. Let me go back to the chat and see if there are any more questions. So Pooja is asking, can you give a real life example of a data frame? So Pooja, right now what you're seeing is a real life example of a data frame. So this data frame has been, so this is an open source data set available on Kaggle, and you will find numerous such data sets on Kaggle or many other platforms, right? So this probably some agency would have collated the data, probably some agency in India itself, or probably they did a survey and they understood on a day-to-day basis what was the what was the change. So on 30th January, how many confirmed cases were there? On 2nd February, how many confirmed cases were there? On 3rd February, how many confirmed cases were there? right? So there's day-to-day analysis. Whatever was being recorded was turned into a CSV file, and this CSV file we've converted into a data frame. Now, most of your real life data frames would pretty much look the same, but this is also structured data. Now, you will also have a lot of data sets which are not really structured, right? Because when you're collecting data, there could be a lot of unnecessary information, there could be a lot of noise. So, as a data scientist, you would have to declutter the noise as well. So, that would also be your task when you're working on the pre processing of your data set. Rakesh is asking, is it mandatory to import matplotlib to use Seaborn? So let's just actually verify that. What I'll do is, let me open up a new notebook over here, and let's see if we can run Seaborn, import Seaborn as SNS. Now let's see if we can use Seaborn without importing matplotlib. So I'll just have SNS dot load dataset. I'll have fMRI, and this I'll go ahead and store it in fMRI. So you have loaded it. So it seems like Seaborn does work without using your matplotlib. So hopefully that answers your question, Rakesh. So let me actually cancel this. Let me go back to over here. So what we've done over here is we have just created a smaller version or a sub data frame of our original data frame. Now that we have this, what I do want to do is probably explore different states or analyze how is the growth of the confirmed cases in different states. Let's start with Kerala because that is what we see over here. What I want to do is I'd want to extract only this. So I'll write down COVID, and here I need to extract all those records where the state is equal to Kerala. So I'll write down Kerala over here. Now, when I run this, again, you will see that I have a bunch of true and false values. I have a true value wherever this condition is satisfied. I have a false value wherever this condition is not satisfied. Now that this is there, what I'd want to do is I'd want to extract all the records where this condition is true. I'll cut this out and I'll paste it inside this parenthesis, and I shall store this in a new object called as Kerala. I've done this. Let me open up Kerala over here. I'll have Kerala.head, and as you see, now let me actually remove head probably because let me actually print this entire thing. So if you look at this, if you look at the state column, you will see that all of the values are Kerala. Now that is because from this entire data frame, we have extracted only those records or only the records pertaining to the Kerala state. And if you look at the first row as well as the last row, you will see that on or as of 30th January 2020, there was only one confirmed case. If you look at the bottom one over here, so the bottom one is 24th of June 2021. So as of 24th June, let me actually count this. So this is probably you'll have around 28 lakh cases. You have 28 lakh cases, 42,247. So you see in a span of 1.5 year, Kerala has had 28 lakh cases. So that's pretty interesting, isn't it? And if I actually want to make a graph for the growth of this, I can go ahead and do that. So for this, let me use SNS, which is Seaborn. So SNS, as you see over here, is just the alias or the short form for the Seaborn library. Now, again, let me cut this entire thing out from here. So again, before this, let me add a new cell. I'll actually have a cell below this, insert cell below. Let me cut this out over here. I'll write down Kerala.head. Kerala is not defined. I'll have it as capital. Now let me run this, and this is what we have. Now from this, I'd want to make a line plot. Since I want to make a line plot, I'll have SNS.line plot, and I'd have to map something on the x-axis, something on the y-axis. So on the x-axis, I'll map the date. On the y-axis, I'll map the confirmed column, which basically means the number of confirmed cases. On x, I will have x is equal to date, and on y I shall have confirm. Then both of these columns are obviously coming from the data frame Kerala. Now at the bottom, I'll just have plt.show. Let's wait for probably a couple of seconds for the result. Right, so this, if you look at this, right, so this probably around for the first 3-4 months, or maybe even the 6 odd months, the growth wasn't really exponential, right? And this probably would have been the would have been around the end of 2020. That is when these cases started to increase exponentially. Again, over here, this probably would be the second wave, where again this is almost like you have a straight line, where again cases are increasing exponentially over here. Right, so this is sort of interesting over here. This helps you to analyze how is the growth of cases in a particular state. Now, if I want to do some fancy stuff, let's say if just I want to change the color of this particular line, I'll have an attribute called as color, and for this I'll give an R. Now when I run this, again, let's just wait for a couple of seconds. So here you shall see that the blue colored line has been turned into red. Right. So this is how we were able to analyze what was happening with respect to the Kerala state. So someone had asked me to analyze Assam state as well. Let's go ahead and do that. Let me remove this one over here. Let's cut it out. Let's keep the Kerala graph over here for reference. Let me reduce the zoom over here. Now what I'd want to do is I'd want to extract all of the records where the state is equal to Assam. I'll increase the size of this. COVID state is double equal to Assam. Now when I run this, you have a bunch of false values. So in these indices, basically you don't really have a record for the Assam state. And now I'd want to extract this entire thing, and I'll have it over here. I'll store the result in a new object. I'll call that object as Assam. Now I would just want to have a glance at the head of this. So I'll have Assam.head. And now when you have a glance at this, you will see that in the second column, which is the state column, all of the values are equal to Assam, right? So that's pretty simple over there. Again, let me just head to the chat and see if there are any more questions. Exxon is asking, do you have a full course video on Python? So Exxon, yes, we actually have 2 to 3 full courses on Python. So you can just go to our YouTube channel, explore it. You'll find a couple of full courses on Python. So you'll have one full course which would help you to use Python and Django to create website. Then you have a full course with Python plus interview questions, and that will also help you to learn Python from the data science side of things. So now that we've done this, what I'd want to do is, again, I'd want to make a similar graph for the state of Assam as well. I'll copy this code, I'll paste it over here, and instead of Kerala, all I have to do is I'd have to change the name of the data set to Assam. Let's give this a green color over here. And now when I run this, let's see how does the graph look like. So here, again, you sort of have a similar sort of thing over here, right? So initially the cases aren't increasing. Then you sort of have an exponential increase. Then it stagnates. After stagnation, this probably is your second wave, where again, there is an exponential increase in Assam. So this is your analysis of 2 particular states. Now, what I'd want to do is I'd want to understand which were the top 5 states where the cases were badly affected, or basically the top 5 states with most number of cases until 6 Jan 2021, because that is the last date which we have. So let me again cut this entire thing over here. Let me remove the stuff from here. I'll add in a new cell below this. Let me insert a cell below. Now that this is clear, I'll have COVID.head. So this is what I have. let me also, what I want is basically maximum 5 states with the maximum cases. So I'll write down COVID dot, I have something called as sort values, and I would want to sort this data frame with respect to a particular column. For this, I have an attribute called as by. I'll be sorting this data frame with respect to the, I'd want to sort this with respect to the confirmed column, or maybe I'd want to sort this with respect to the state column. I'll keep it with respect to state. Then I will set ascending is equal to false because I'd want the state with the most number of cases at the top and the state with the least number of cases at the bottom. Now, when I run this, this is what I have. So I have, or before this, what I'd actually do is, let me actually extract all those records where the date is the last date. Let me again cut this out from this. Before this, there would be an intermediary step. So instead of COVID dot head, let me show you COVID dot tail. And when you look at COVID dot tail, you would see that for this particular data frame. So in this data frame, the last date for this, for which all of this information was collected, was 24th June 2021. What I'd want to do is I'd want to extract this information for all of the states. So I'll write down COVID, and this time the condition will be with respect to the date column. I'll set the date as 202106. After 06, it would be 24. So this is the date, and this is what the condition needs to be. Now, before this, again, I'll write COVID. I'll put in the parentheses. I'll cut this. Let me write this properly over here. Right. I'll cut this from here and I shall paste it inside the parentheses. Now, when I run this, and if you look at this date, you shall see that the date is equal to 24th June 2021. So if you scroll down the entire thing, you will see that all of the dates are equal to 24th June 2021. And you have the information about the number of cured cases, the number of death cases, the number of confirmed cases with respect to all of the different states over here. Now from this, I would, or before that, I will go ahead and store this in something called as, let's say, last date. Now let me print out last date dot head. So when I print out last date dot head, this is what I have. Now I'd want to sort this with respect to the states. So if I want to sort this with respect to states, or probably I'll sort this with respect to the confirmed cases, not the states. So I'll have the state with maximum number of confirmed cases at the top, the state with least number of confirmed cases at the bottom. So for that, I'll have last date dot sort values, and I am sorting this with respect to confirm, and I shall set ascending is equal to false. Now, when I run this, here you shall see that the state with the most number of confirmed cases, or the state with most number of cases as of 24th June 2021 was Maharashtra. So you see that as of 24th June 2021, there were 59,97,000 cases. Then in Kerala, you had 28,42,000. So you see this huge difference between the number of confirmed cases between the first state and the second state. This is almost double, right? Or like double the number of cases you have in Maharashtra. Then you have Karnataka closely following behind at the third spot. You have 28 lakhs confirmed cases as of 24 June. Then you have 24 lakh confirmed cases as of 24 June. Then in Andhra Pradesh, you have 18 lakh confirmed cases as of 24th June. Now, isn't this amazing, folks, right? All of this analysis we are able to do with this simple Python language. All I'm doing is running these simple commands, and with the help of these simple commands, I'm able to obtain information or dig in information from the raw data. And this is the essence of data science. So data science is nothing but where you have this huge amount of raw data, and from that raw data, you either find patterns or you find some useful information. So when this blank Excel sheet was given to me, from that blank Excel sheet, we are able to find out all of this information, right? So we've taken this and we found out that as of 24 June, the most number of cases were in Maharashtra, and the value of that is 59 lakhs 97,587. Now, let's say if I'd want to show this to a client and I'd want to show the top 5 states with maximum number of confirmed cases, I'd have to make a bar plot for that. So let's go ahead and make a bar plot. And now here again, I'll have head, and this I'll go ahead and store. And since we have only 5 states over here, I'll store this in something called as state by top. Let me run this. Now, when I again print out state phi top, this is what we have. Now, from this, I'd want to make a bar plot. Now, if I'd want to make a bar plot, I would need to use Cbond. So here I'll have SNS dot bar plot, and on the x-axis, I need to map something. So on the x-axis, I will map the state column. On the y-axis, I will map in the confirm column, and both of these columns are coming from state phi top. And let me execute this. This is what we have. So you see this beautiful plot over here. Let me add plt dot show over here as well. Let me also give in a title for this. I'll have plt dot title. I'll write down top 5 states with maximum number of COVID cases. And when I run this, you shall see that I've written this title, or I've added this title at the top. At the bottom, probably I'll have something called as plt dot x label, and in the x label, I'll set this as names of states. And I'll also have plt dot y label. Here I'll write down number of confirmed cases, just making it more descriptive. And as you see, here on the x-axis, the label becomes names of states. On the y-axis, the label becomes number of confirmed cases, and the title, you have it as top 5 states with maximum number of COVID cases. Again, if I want to increase the size of this graph, what I can do is I'll have something called as plt dot figure, and inside this I can adjust the figure size. So I'll set the figure size is equal to 10,10, and let's see if there is any sort of change. And right now you see this beautiful graph in front of you. So with the help of plt.figure, we have been able to adjust the size. So on the bottom, you have the states, and this basically gives you the top 5 states with maximum number of cases. Interesting analysis, isn't it? Karthik says data structures and algorithms, please. Yes, Karthik. We are actually uploading a lot of videos on data structures, algorithms. So I believe just yesterday we had uploaded one video on recursion. So if you haven't checked it, please check it out. And we shall be uploading a lot of videos soon. So if you have any more requests, put them up and we'll do it. Healthific team says C++. Yes, we are working on a C++ video as well. And that is also something which we'll upload. Karthik is asking, do I need to know all about the built-in functions of Python to ace most of the interviews? The answer is no, Karthik. So in the interviews, what you'll be grilled on is how are you going to analyze it, not really on the inbuilt functions, because this is something which you can just Google it, right? And also when you're working in a real industry, all of this, you can just get it from Stack Overflow or Google, and you can just pick it up at any point of time. What matters is if your fundamentals are strong. And when I say fundamentals, so again, most people think that you can become a data scientist without proper math skills or statistics skills. So that is something which you'd have to properly work on. And after that, you So again, people think that you wouldn't need the DS algo stuff when when you'd want to become a data scientist. That is sort of incorrect because let's say if you'd right now what we are doing is we are just invoking the functions or libraries which are already there. But there would come a scenario where you'd have to create your own library from scratch or create your own method from scratch. And these methods or libraries should be time efficient and space efficient. And that is when your knowledge of data structures and algorithms will also come in really handy. Great. So, folks, I guess this would be it for today's session. We've covered enough stuff. We've understood about. We started off with pandas, then we had a bit of visualization with Seaborn, then we opened up this COVID India dataset and performed a proper analysis on top of this dataset. And if you have any more suggestions, you can put them up in the comment section. Once this video is done, we'll go through it and we'll definitely address them. So for all of you data science enthusiasts, there is a site called as Kaggle, which is sort of a data science repository. So on Kaggle, you'll find multiple data sets with respect to data science. Over there, you also have a huge community for data science, and also you have multiple contests over there. So I've just taken one such data set from that particular website. Now, after taking that data set, what I'd want to do is I'd want to do basic exploratory data analysis on top of that data set. And I shall be using two languages for that. I shall be using Python as well as R. Since Python and R, both of them are widely used in the field of data science, I shall be using both of them. So on that note, what I'll do is I will share my screen and let me start off with the coding side of things. So hopefully you can see the Jupyter notebook as well. Aritra Nandi is saying no audio. Seems like I can hear it. So Aritra, probably you have to check your system once again. So please check at your end. There might be an issue at your end. So I've opened up Jupyter Notebook over here, and what I'd want to do is the first task for me to load the data set. And since this is a CSV file, to load any CSV file, I would require the pandas library. And pandas is a library which is mostly used for data wrangling and data manipulation. So let me just go ahead and import that library. So here I shall write down import pandas as PD. And now that I have imported this pandas library, let me just go ahead and load the file. I shall write down pd.read_csv, and inside this I shall give in the name of the file. So I have a file called as COVID-19, or let me just verify the name of the file. So it is actually covidindia.csv. So I have a file called as covidindia.csv, and with the help of pd.read_csv, I am loading this, and I shall store this in a new object, and I shall call that object as COVID. So now that I've created this object, let me just go ahead and have a glance at the first few records of this. So what I shall do is I shall write down COVID.head. And these are the few records which are present in this particular data frame. So we've got the date column. So here, as you see in Kerala, as of 30th January 2020, there was one confirmed case. So you have all of these different columns over here. The date when these things happened, whether it's a confirmed case, whether that person was cured of COVID, or whether that person deceased because of this particular virus. Then you have which particular state and how many cases. You have confirmed Indian national, you have confirmed foreign national. So these are all the different columns which are present. Now, out of these, I wouldn't want all of these columns. So I'll just take a subset of this entire data frame. So if I'd want a subset of this entire data frame, what I shall do is I shall again write down COVID. Then I shall give in two parentheses, which is basically meaning that I shall take a subset of data frame from this original data frame.
And then I shall list down all of the columns which I would require from this main data frame. So I would definitely need the date column. So I shall give in single quotes. Inside that, I shall give in date. Then after that, I shall also need the state union territory column. So here I shall write state / union. Let me write this down properly. State / union territory. And also here you'd have to keep in mind that you're writing this spelling properly. And after these two, I shall ignore confirmed Indian national, I shall ignore confirmed foreign national, and I shall take the rest of the three columns. So I have cured, deaths, and confirmed. So here I shall write cured. Then going ahead, I shall take the next column, which is deaths, and then finally I shall take a column called as confirmed. Then I shall go ahead and store this in the same object and also call this as COVID. So what I'm basically doing is from this original data frame or main data frame, I am taking a subset of columns and I am storing back into the original data set. So I've executed this command. Now again, let me write down COVID.head and let me see the resultant data set. And as you see from this main data frame, I've been able to extract only the date column, state union territory column, the cured column, deaths column, and confirmed column. So hopefully this is clear for all of you folks. So Nishad is asking, is that cumulative or per day? So this is cumulative. So all of these which you see, this is cumulative. So as of 30th Jan 2020, there was one confirmed case. As of 1st Jan 2020, there's actually 1st February 2020, Kerala had 2 confirmed cases. As of 3rd February 2020, Kerala had 3 confirmed cases. So all of these are cumulative values over here. Now that I've taken this subset over here, what I'd want to do is, I'd want to, since all of these have these are in title case, what I'd want to do is I'd want to convert the names of the columns into small case. And also this is this column name seems really lengthy. So I just want to cut it down. I'd want to shorten it and just keep it as state. So let me go ahead and rename all of the columns which are present over here. So for that purpose, I shall write, first I again need to give in the name of the data frame, which is COVID. And I have this method called as rename. And here I shall have a parameter called as column. So I'll set columns is equal to, and I'll take in a dictionary, and inside this dictionary, so if you have worked with Python before, you shall know that a dictionary has key value pairs. And in this particular key value pair, what I shall do is I will give in the original name of the column as the key and the new name of the column as the value. So first I have this column called as date, and here you see that D is capital. I do want to change that to small d. So I shall write down date. Similarly, I have the next column, which is this. So let me copy this entire thing and let me paste it out over here. After this, what I'd want to do is I'd want to change this to just state. Going ahead, I have the next column, which is cured. So here C is capital. And what I'd want to do is I'd want to change that to small. I shall write it as cured. And then I have the next column, which is deaths. So again, over here, D is capital. And I'd want to convert that into small. So here I shall write down deaths. And then I have one final column, which is confirmed, which would tell me the number of confirmed cases. So here I shall write down confirmed. And again, let me make it smaller. So here I've changed C to be small. So now that I've done this entire thing, I will again go back and store this in the same COVID data set. Now I've executed this and let me run COVID.head. And as you see, I've been able to successfully rename these columns. So initially all of these columns were in title case or capital case. I've converted them into small cases. And also the name of this particular column, it was state / union territory. I've just cut it down. I've made it state. And again, hopefully this is clear for all of you folks. Nishad says cool. That's great. And also folks, if you have any doubts, any queries, any suggestions, please keep putting them up in the chat window. I shall parallelly go through the chat and see if there are any questions. I shall take them up as well. And I want this session to be quite interactive. So now that I have made the necessary changes in this particular data set, what I'd want to do is So here, let me show you so right now when I use this head method, you can see the first 5 records in this. Similarly, if I want to look only at the bottom 5 records, I have a method called as tail. So let me just write down covid.tail over here. And as you see, these are the last few records which are present in this data frame. And if you look at these index values, so here, when you use the head method, you see that you have the record starting from index number 0 going on till index number 4. Similarly, when I use this tail method over here, I have the record starting from index number 377 going on till 16,381. And this would basically mean that this data frame has 16,382 records. I'm saying 382 records because the first index value starts from 0. And just to confirm that, let me go ahead and write down covid.shape, which shall tell me the number of columns and number of records in this data frame. So when I use covid.shape, you shall see that there are 16,382 records and 5 columns in this particular data frame. So this is also clear. Now what I'd want to do is I'd want to extract the latest cases. So this particular data frame has details till 24th June 2021. Now today is 29th June 2021. So we've got the latest cases till 5 days back, isn't it? So this is the most updated data set which I was able to find on Kaggle. And I've got all of the latest cases till 24th June 2021, which is just 5 days back. So what I'd want to do is I'd want to extract all of the records from this data frame where date is equal to 24 June 2021, and I'd want to analyze that particular set properly. So here, let me just go ahead and write down, I'll write COVID. Inside this, again, I'll write COVID. So what I'm doing is I'm writing down the name of the data frame. And from this COVID data frame, I'd want to extract all the records where the value of date is equal to this. So let me write in the name of the column. So the name of the column is date, and the date value needs to be equal to 2021-06-24. Let me copy this and I shall paste it over here. And now that I have this, I shall go ahead and store this in a new object, and I shall call that as latest cases. Now I'll just show you this latest cases object. So I shall write down latest cases dot head, and as you see, all of these, if you look at the date column over here, all of the dates are corresponding to 24th June 2021, and these are with respect to all of the different states. So if you look at Andaman and Nicobar Islands, so as of 24th June 2021, in Andaman and Nicobar Islands, there are 7,438 confirmed cases. Out of these 7,438 confirmed cases, 7,210 have been cured. So it seems like the number of people who've been cured, that percentage is extremely high when it comes to Andaman and Nicobar Islands. Similarly, the deaths are 127 when it comes to A&N Islands. Similarly, if we talk about Andhra Pradesh, so let me calculate this properly. So hundreds, 10,000, this is 18 lakhs. So seems like till 24th June 2021, there have been 18,62,000 cases in Andhra Pradesh, which is a huge number. And out of these 18 lakh cases, it would seem that 17,98,000 cases have been cured, or these number of people have been cured, and there have been 12,452 deaths, unfortunately. Similarly, if we talk about Bihar over here, so there have been 7,20,000 confirmed cases, out of which 7,08,000 cases, or 7,08,000 people have been successfully cured, and there have been 9,500 deaths, unfortunately. So this is how I can look at the latest cases. Now what I'd want to do is I'd want to sort this data frame with respect to the maximum number of cases in a particular state. which would mean that whichever state has the maximum number of confirmed cases shall be at the top, and whichever state has the lowest number of confirmed cases shall be at the bottom. So for this, I shall write down latest cases dot sort values, and inside this I shall write by, and I'd want to sort this with respect to the confirmed column. And let me just run this over here and let's see what is the result which I'll get. So seems like I get an error over here. Let me put these in double quotes and let me run this again. So as you see, so here what I've done is I have the lowest number of confirmed cases at the top. So right now this is arranged in ascending order, but I'd actually want to arrange this in descending order. So let me just go back and I shall set, so I have an attribute called as ascending, and I shall set ascending is equal to false. Now, if I run this, you shall see that I have Maharashtra at the top. So as of 24th June 2021, there have been 59,97,587 cases in Maharashtra. And that's a huge number, isn't it? Almost 60 lakh confirmed cases in only the state of Maharashtra. So that's a huge number. And out of these 59 lakh confirmed cases, 57 lakh people have been cured, and there also have been 1,19,000 deaths. So the number of deaths is also above the 6-figure mark when it comes to Maharashtra, and that is sort of disappointing for us as a country. So we need to and that is why the second wave had come up, and we need to properly maintain the social distancing protocols. So I hope also in this particular situation, all of you are maintaining proper social distancing protocols and maintaining and also making sure that if there are elders at your home, they are safe. So let me just go ahead and I shall see if there are any more questions. Ravindra Lakal is asking, are you covering EDA today? Yes, I shall cover EDA today. Harvey Spector is saying recorded. No, this is not recorded. This is a live session. So if you have any questions, Harvey, you can put them up in the chat and I shall take them up. And also, as I said, I want this to be quite interactive. If you have any questions, any doubts, you can just put them up in the chat. I shall take them up. So what I've done over here is I have sorted this entire data frame like this, and I just want to look at the top 5 states with maximum number of confirmed cases. So as of 24th June 2021, the top 5 states with maximum number of confirmed cases are Maharashtra, Kerala, Karnataka, Tamil Nadu, and Andhra Pradesh. Now, what I'd want to do is I'd want to represent this pictorially using bar graphs or bar plots. So I shall just go ahead and store this in a new object, and I shall call that new object as top 5 states. Again, let me just print out top 5 states, you guys, and this is what we get. Now, out of this, what I'd want to do is, as I said, I'd want to create a bar plot. And to create a bar plot, if I go ahead, I actually haven't imported Seaborn over here. So what I'd want to do is, there are visualization libraries in Python. So there is a visualization library called as matplotlib, and there is also a visualization library called as Seaborn. So I shall be importing both of these visualization libraries. So let me just write down from matplotlib import plot as plt. And I shall also write down import Seaborn as SNS. So now that I have imported these two libraries, what I'd want to do is, as I said, I'd want to create a bar plot. So I shall write down SNS.bar plot, and on the x-axis I need to map something, and also on the y-axis I need to map something. So onto the x-axis I shall map the state column, because I basically want to see the state-wise distribution of these confirmed cases. So onto the x-axis, I'm mapping the state column, and onto the y-axis, I am mapping this confirmed cases column. And both of these columns are basically coming from this object or this data set called as top 5 states. And also here I need to put these in double quotes again, else I'll get an error. So state confirmed, let me also put double quotes. And after this, let me just write down plt.show. And as you see, I've got this very beautiful bar plot over here, where we also very obviously, very clearly see that the maximum number of confirmed cases are in Maharashtra. And as you see, this is touching the 6-figure mark over here, which is basically the 60 lakh confirmed cases, almost 60 lakh confirmed cases. So that was of 24th June 2021. So I guess by today, this bar would definitely have been above that 60-figure mark. So what I'd want to do is let's say if I'd want to increase the size of it, let me use this new parameter called as plt.figure. And inside this, I have something called as fig size. And let me set the figure size to be equal to 15, let me just put it to be equal to 10. And let me run this. Now this is a huge plot, isn't this? Let me actually reduce the size of it. Let me probably make it 15,7. And let's see how does this look like. So guys, this is how our bar plot looks like over here. And this again is a very pretty plot. So the maximum number of confirmed cases, the top state with most number of confirmed cases is Maharashtra over here, then followed by Kerala, then followed by Karnataka, then we have Tamil Nadu, then we have Andhra Pradesh. Let me just go back to the chat and see if there are any questions. Swati Agarwal is asking, can the COVID India dataset file be shared so that we can do a hands-on and follow along? Swati, what I shall do is once this live session is done, I shall add the link of this in the description box, and also I shall pin it in the comment section. Then you can get get this particular data set. And in the meanwhile, if you'd want to search for it, you can just go to the site called as Kaggle. Open that site up, and over there you can just type in COVID-19 or coronavirus or COVID-19 India. I'm pretty sure you shall be able to get this particular data set over there. So I hope that helps you, Swati. So now that this is clear, what I'd want to do is I'd want to make a similar bar plot for also the top 5 states with minimum number of cases. So here what I've done is I've set ascending is equal to false. So similarly, I have my latest cases object, and I shall use sort values, and here I shall set by confirmed. Let me put this in double quotes again. By confirmed, again I shall set ascending. Now this time I shall actually set ascending is equal to true, and let me run this. So here I have the top 5 states. So basically I have all the states with the confirmed cases. Now, since I want only the head of this, let me run this. So these are the top 5 states with the least number of cases. So we have Andaman and Nicobar Islands, where the number of cases as of 24th June are 7,438. Followed by Lakshadweep, where the number of cases are 9,559. Then we have Dadra and Nagar Haveli, where the number of cases are 10,000. Followed by Mizoram, where it's 18,000. Followed by Sikkim, where it's 19,000 cases. Now, again, let me just go ahead and store this in a new object. Let me call it bottom 5 states. Now that I have saved this, let me also print out bottom 5 states for you guys, and I shall go ahead and create a bar plot for the same. So here I shall write sns.barplot, and on the x-axis I shall again be mapping the state column, and let me not forget to put these in double quotes. After this, onto the y-axis I need to map the confirmed cases. Again, it seems that I keep forgetting to put these names of columns in double quotes. And then going ahead, when it comes to data, I will not put this in double quotes. So the name of this data set is bottom 5 states, and after this I shall just write down plt.show, and this is what we get. Again, you see that this text on the x-axis, it's a bit jumbled up, so let me just increase the size of this plot. So here I shall again write plt.figure, and I'll write figure size. Let me set the figure size to be equal to 15,6. Let me see if that works for you guys. Right. So this is the states with the least number of cases. Andaman and Nicobar at the first position over here with close to 7,500 cases. Then we have Sikkim over here with close to 20,000 cases. So interesting plot again. Now that we have done this, what I'd want to do is I'd want to also do a state-wise analysis. So let me just print out the original data frame for you guys, which would be COVID. I shall actually print out COVID.head. Let me write down COVID.head over here, and this is what we get. So we have the date, state, cure, deaths, and confirmed. Now, out of this data frame, what I'd want to do is I'd want to analyze some individual states. So let me also see all of the states over here which are present. So I shall write COVID. Inside this, I shall take the name of the column with the state, and this is, since this is a categorical column, I have a method called as value count. So let me just write down value count and print out over here. Now these values which you see, so can you tell me, can someone in the chat tell me what are these values exactly? Are these the cases? Are these the confirmed cases, or are these something else? What exactly are these? What exactly does this value counts method do? Ravindra Lakal is asking, how can we see the number if we hover over a particular bar? So Ravindra, to answer your question, that is unfortunately not possible with just the basic graphing or basic plotting which we are doing. So that would probably involve, we will need to go into the depths of Seaborn and Matplotlib, and we shall cover that in some other session. So right now, if we hover this is not possible, as directly Seaborn or Matplotlib is not an interactive plotting library. You only get static images. You shall not get interactive images over here. Satyam Kumar is asking, can you show this project in your resume? Absolutely. So if you do this by yourself, probably tweak it a bit, add new things, and you can definitely add it in your resume. Swati Agarwal is saying number of rows for a state, number of occurrences for each. Yes. So Swati and Ankit, you are absolutely right. So Kerala is basically present 512 times in this data frame. Similarly, Delhi is present 480 times in this data frame. And if I come to the bottom over here, there is only one record for Daman and Diu, which would mean that there has been only one instance taken in this data set about the confirmed cases or probably any other cases in this particular state. So similarly, it seems like probably we'll have two over here when it comes to Bihar, and also we have unassigned Telangana, we have Lakshadweep, Sikkim, and so on, right? So seems that the most number of recordings which are there, those are present for the Kerala state. Now, what I'd want to do is, let me start off with, let's say I'd want to take something related to, let's start off by analyzing the state of Delhi. So what I shall do is, from my latest, actually not the latest cases, I shall take this COVID data frame. So from this COVID data frame, I'd want to select only those records where the state is equal to Delhi. And I shall again store this in a new object, and I shall call that object as Delhi. And let me print out the head of this for you folks, Delhi.head. And as you see, this is what I get. So it would seem that the first instance or the first confirmed case in Delhi was recorded on 2nd of March 2020. So First confirmed case in Delhi was found on 2nd March 2020. Similarly, let me use the tail method over here, delhi.tail, and this is the latest date, which is 24th June 2021. And as of 24th June 2021, I have 14 lakh cases. So as you see, in this span of probably 1 year, 3 months, there have been 14 lakh confirmed cases across Delhi, and that is a huge, huge number, my friends. Now, what I'd want to do is I'd also want to analyze how these confirmed cases have increased across all of this time period. So for this, I can make a line plot. So let me just go ahead and make this line plot. I shall write down SNS dot line plot, and on the x-axis I shall be mapping the date column, and on the y-axis I shall be mapping. I need to map, what do I need to map? I need to map the confirmed cases column, and both of these columns are coming from this object called as Delhi. Let me just go ahead and show this out for you guys. Now, let's wait for this to come up over here, and this is what we get. So here, since we have all of these instances of dates, that is why this is not really clear over here. And even if I increase the plot size, that probably wouldn't be so clear. So what I shall do over here is, let me again put in plt dot figure, and I shall write down plt. I do not need to write plt, I shall just write figure size, and let me put in the figure size as 10,5, and let me run this. And this is what we get over here. So this is the trajectory of how the cases have been increasing from 2nd of March 2020 till 24th of June 2021. Again, this is not clear because you probably have how many instances over here? You have 480 dates written side by side, and that is why it is not clear. So after this, what I would want to do is I would probably take another state and also plot that along with this. So similarly, let me probably take in another state, which would be, let's say, Kerala. So here, what I shall do is I shall write down COVID, and here I shall give in the name of the column, which is state, and the state will be Goa, and I shall go ahead and store this again in a new object and call it as Goa. Here, let me just write down Goa.head, and let's see what do we get. So here, the first case in Goa was found on 26th March 2020. Actually, we had 3 confirmed cases as of 26th March 2020. Similarly, let me just write down Goa.tail over here. So here, when I write down Goa.tail, I have, so as of 24th June 2021, I have 1,65,000 cases. So let me just go ahead and also add this into the same plot. So I shall select this entire thing and I shall paste over here. Now after this, I shall make another line plot, and now again on the x-axis, I would want the date column. On the y-axis, I would want the confirmed column, and the data is actually coming from this object called as Goa. And let me run this and show you guys how the result looks like. So here, as you see, if you compare these two graphs, the number of cases in Delhi have been increasing exponentially, right? And in Goa, it's sort of like a, it's sort of like a linear line, and it's not increasing so much when you compare it to the increase in Delhi. So this is an interesting analysis which we have found out over here. And now let me also take up another state. So probably I will take in Maharashtra over here. So let me just check the how it is written. Let me just copy this entire thing from over here, and I shall write down COVID. Again, I shall write down COVID. Here the state has to be equal to Maharashtra, and I shall go ahead and store this in a new object and also call that object as Maha. Now, let me copy this entire thing from over here. Let me paste it over here, and let me add in a new line plot again. So here onto the x-axis, I shall add a date. Onto the y-axis, again, I shall add the confirmed cases. And this time the data is coming from this object called as Maha. Let me just show this out for you guys, and let's see how the result looks like. So here, the third one which you see, this is of Maharashtra. So this is Goa, this is Delhi, this is Maharashtra, and as you clearly see, the growth in the number of cases is, so there is absolutely no comparison over here, isn't it? So there's a huge difference between these three. And if I would want to add a legend over here, let me just write down plt.legend, and here I shall just write. So the first state is Delhi, then I have Goa, then I have Maharashtra. Let me write down the spelling properly over here, and let's just run this again and let's wait for the result. And as you see, I have also added a legend. So in this legend, we clearly see that this blue color line is for the state of Delhi, this green color line is for the state of Maharashtra, and this orange color line is for the state of Goa. So a very interesting graph where we can see the trajectory of how the cases have been increasing across all of these different states. So hope this is clear for all of you guys as well. So again, if you guys have been able to follow this, just give me a confirmation in the chat window. You can just write down yes if you have been able to follow this properly. So after this, what I would want to do is I shall also do a similar sort of analysis in RStudio as well. So let me just go back, and what I shall do is, instead of sharing the Jupyter notebook, I shall actually share RStudio. Just give me a second for that. So share screen. I would want to share entire screen here. And what I've done over here is I've opened up RStudio. Also give me a confirmation if you can see RStudio onto my screen. Right. So seems like we have been able to open up RStudio as well. So for all of the folks who are new to the R language or new to RStudio, this is how RStudio looks like. And just give me, and I shall start off by giving you guys a brief of this. So this, what you see, is known as the script window. This is where you can write all of your script or R script. This is known as the console window, and this is where you can execute all of your R commands. So let me just give you guys an example. Let me write 10 plus 5. As you see, this has been executed over here. Then we've got this environment pane where you have, you probably can see all of the history of the commands which you've done. If you want to import a data set, that is something which you can do. And also you have multiple options over here. And this, again, you have multiple options. So here you have the packages tab. So let's say if you'd want to install a particular library, you just click on install. So let's say there is a library called as deployer. And when I click on install, the package will be installed. Similarly, let's say if I want to install this package called as ggplot2, I shall select this. When I click on install, again, that would be installed over here. Then we have plots. So whatever plots we are making, all of those would be visible over here. So on that note, what I want to do is, again, we'll do a similar sort of analysis in R as well. So this is just to show you guys that R and Python, both of them are equally used when it comes to data science. And we are going to do a similar analysis with the R language. So let me just go ahead and read the CSV file. So when it came to Python, the command was read_CSV. When it comes to R, the command is read.csv. And here, let me just give in the path. So this is stored in my downloads folder, and the name of the file is COVID-19 india.csv, and let me just go ahead and store this in an object called as COVID final. So now that I've stored this, if I would want to show this data frame to you guys, I have this method called as view, and inside this I shall just pass in this data frame. So I shall write down COVID final, and this is the same data frame which we had seen in Jupyter Notebook as well. So we've got date, time, state, confirmed national, confirmed foreign national, cured, deaths, and confirmed. Now again, out of all of these different columns over here, what I'd want to do is I'd want to select only a particular set of columns. So for that purpose, I would need to use a library called as deployer. So here, let me write down library of deployer. And deployer is a library which is mostly used for data wrangling and data manipulation. And inside this deployer library, I'll have a method called as select. And with the help of that select method, I can select only some individual columns from this entire data frame. So I shall write down COVID final, which is the name of this data frame. Now this, what I've given over here, is known as the pipe operator. So with the help of the pipe operator, I can connect one object with different objects or one object with another function. So COVID final, and after this, what I'd want to do is I would want to give the select method. Just give me a second, guys. I am just opening the same stream in my phone as well so that I can look at the comments as well. Just give me a second. So Swati is asking, which language would you prefer for data analytics, Python or R? I have a background in Python. Should I still learn R for data science? Well, the answer is pretty simple. So in the industry, both of these languages are used. And also, since you know Python, I would also suggest you to learn R as well, as it is not really that difficult. The script or the syntax of both of these languages is quite similar. And if you already know Python, then I can assure you that you can learn R probably in a span of 2 to 3 weeks. So at max, it needs to take you 3 weeks to learn the basic syntax of R, and you can start, doing all of these basic data science applications with R. Because when it comes to the industry, both of these languages are equally used, and it would be better if you know 2 languages. So 2 is always better than 1. So I'd suggest if you know this, then it's obviously better. So COVID-19 select, and over here, I just need to give in all of the columns which I'd want to select. So I'd want the date column. I'd want the state union territory column. So let me just write that down properly. After this, I would need the cured column over here. Then I would need the deaths column. After that, I would need the confirmed column. So now that I have selected all of these columns, let me just go ahead and store it back to COVID final. And as you see from the original data frame, I've been able to select only these particular columns. Again, what I'd want to do is from all of these columns, I'd want to rename them. Basically, I'd want to convert them to lowercase. So again, for this, I have a method called as rename. So here, let me write down COVID final. I shall give in the pipe operator, and I have the rename method. And this is also very simple. So here, what I'd want to do is, first I need to give in the name to which I'd want to change it, which is the new name, and I need to give in equal to. After that, I need to give in the old name. So for this date column, the original name is date with D capital. So I'd want to change that to date with D small. So I shall just write down date is equal to date. Similarly, I've got state.union territory. I just want to change that to state. So I shall just write down state is equal to, then I shall give in the original name of the column, which is state.union territory. Similarly, I've got cured, where C is capital. I'd want to convert that to small case. So cured is equal to cured. Then I've got the debts column. Again, D, I will make it small. Then I shall select debts from over here. And then finally, I've got this confirmed column where again, I need to make C to be small. I shall write confirmed and I shall give in the original column name over here. Let me just go ahead and store it back into COVID final. Can't rename columns that don't exist. So here, what I've done is I have written this to be small as well. Let me make it capital. Now let me run this, and as you see, the changes have been effected. So date, initially D was capital, that has been changed to small. This was state.union territory, which has been changed to state. And the rest of the three columns also, they've been converted from title case to small case. Now, after this, similarly, what I'd want to do is I'd want to extract all of the records where the date is equal to 24th June 2021. Now, before that, let me also show you the head method and the tail method in RStudio as well. So the head method here, you shall just write down head and you shall give in the name of the object. So the name of the object is COVID final over here. And this is how the result looks like. So when it came to Python, by default, when you use the head method, you got the first 5 records. And when it comes to R, when you use the head method, by default, you shall get the first 6 records. Now, let's say if I don't want the first 6 records, if I actually want the first 10 records, here I shall just put in a comma, I shall write down 10, I'll hit enter. And as you see, I have the first 10 records from this. Similarly, let's say if I want only the first 3 records, let me just change this to 3. I'll hit enter, and as you see, I have only the first 3 records from this. So this is how the head method works. Now, let me also use the tail method. Inside this, I shall pass in COVID final. When I run this is the result which I get. Also, by default, I have the last 6 records from this data frame. So this is also clear. After this, what I want to do is, since the last date, let me run this again. So let me show you the date over here. As you see, the last date is this, or the latest date is this, which is 24th of June, 2021. Let me select this. And what I'd want to do from this entire data frame is, I'd want to extract only those records where the date is equal to 24 June, 2021. So for that purpose, let me again write down COVID final. Then I shall give in the pipe operator. After the pipe operator, I would want to give in the filter function. Again, this filter function is part of the deployer library. So if you haven't loaded the deployer library, you will not be able to work with this filter function. And with the help of the filter function, I'll be able to probably extract records from my original data frame on the basis of a condition. So here, let me just give in the condition filter where date is equal to this. And again, I shall go ahead and store this in a new object. I shall store this in something called as latest cases. Let me show you guys this object of latest cases. And as you see, I've got 36 entries, which would basically mean that I've got different combination of all of the states and union territories over here. And the date, if you look at this particular column, you would see that this is 24 June 2021. So across all the rows, you shall see that this is constant, and the constant value is equal to 24 June 2021. So hope this is clear as well. Now, now that we have this, what again I'd want to do is I'd probably want to extract only the top 5 records with the maximum number of cases. So for this, I shall write down latest cases. And here, when it came to Python, we had something called as sort values. When it comes to R, we have something called as the arrange method. So again, arrange method is part of deployer. So here I shall write down latest cases. I shall write down arrange, and I want to arrange this in descending order. So I shall write down DESC, and I want to arrange this with respect to the confirmed column. So when I hit enter, this is what I get. So let me actually store this back into latest cases descending. So view of latest cases descending, and this is what I shall have over here. And as you see, the first record which you see is Maharashtra, and the maximum number of confirmed cases, this is what I have over here. Again, from this entire data frame, let's say if I want only the top 5 records, what I can do is I shall take in latest cases descending, and here I shall just put in 0,5, which would basically mean that I'm selecting all of the columns, but only the first 5 records from this data frame. I shall hit enter. Now this is a bit chaotic, so let me just go ahead and store this in a new object, call it as top 5 max cases, and I shall show you how does top 5 max cases look like. So these are the top 5 states with the maximum number of confirmed cases. So this again is interesting, isn't it? So again, let me just go ahead and make a bar plot for this. So when it comes to R, we have this plotting library called as ggplot2. So let me just go ahead and load that. So here I shall write down library of ggplot2. Now after this, I shall write data is equal to, so this data is basically the data frame. So I'd want to make a plot for this data frame, which is top 5 maximum cases. Then I shall use aesthetic, where I'd have to map something onto the x-axis and I'd have to map something onto the y-axis. So onto the x-axis, I am obviously mapping the state column. Onto the y-axis, I am mapping the confirmed column. Then I'd have to make a plot, isn't it? So to make a plot, I'd have to choose a geometry. So in ggplot, you have different geometries. So if you want to make a area plot, you have geom area. If you want to make a bar plot, you have geom bar. Similarly, if you want to make a box plot, you have geom box plot. And since I don't want to make a bar plot, I shall select the geom bar over here. And inside this, I shall just write down stat is equal to identity. Now, when I run this, this is what I get. So you would see that this is actually arranged in alphabetical order and not really in the order of the sizes of these bars. And also, I do not really have any color by default. So let me just go ahead and add in color for all of these different bars. So here I have the same command. Now I'll go inside this aesthetic function, and here let me just put in a comma. I shall use this attribute called as fill, and inside this I shall actually I want all of the colors of these bars to be determined by this state column. So here I am mapping the state column onto the fill aesthetic. Now when I hit enter, you shall see that I have different colors for all of these. Let me actually zoom this so that this is even more properly visible to you guys. Right, so I have all of these different colors over here. Let me just close this over. And now what I'd want to do is I'd want to arrange this in probably ascending or descending order. So here, what I shall do is I have a method called as reorder. So I shall use reorder, and in reorder I shall pass state. Let me remove this from over here, and also let me give in confirmed. And now when I run this, I shall get something like this. So this over here is arranged in ascending order. If I want this in descending order, what I can do is I have confirmed over here. Let me just run this again. So here I shall put in a minus symbol so that this is arranged in descending order. And this is the final result to which we get. So we have properly arranged these bars in descending order, where we have Maharashtra at the first position. So the most number of cases have been found in Maharashtra, then Kerala, then Karnataka, then Tamil Nadu, and then Andhra Pradesh. So hopefully this is clear to all of you folks. So, guys, what we've done over here is we've done proper data analysis, exploratory data analysis with respect to Python as well as R, and hopefully this is helpful to you folks. Just let me know in the chat window if this is helpful to you guys. Let me stop sharing my screen over here. Let me stop this. So folks, if you have any more questions, just put them up in the chat. I'll probably take one or two questions and I can just end this over here. So Jyotsna is asking, does Scholar have any course for data science? So as of now, we do not have any course for data science. But then again, if you want us to keep doing these sessions on data science or AI or probably any other technology, we shall gladly do it.
This is a term which you might have heard quite a lot of time, maybe in news related to marketing or news related to websites and so on. So today you will be getting a simplified overview of what is this topic and a practical example walkthrough for the same so that you understand how to use it in the future if required. Before I move on, I would request you to subscribe to this channel if you are interested in getting such videos or watching such videos in the future. A bit about me before we proceed. So my name is Nitish and I work as a senior data analyst at Google in the Singapore office. Coming to the topic at hand, what is A/B testing? If you would have read about this topic or maybe heard it, and been through the different definitions around the same, you would find different books or different articles of different definitions, and often they are loaded with a lot of jargon. So I will try to simplify it to the best of my ability. A/B testing is a statistically reliable framework to compare the effect of any kind of change in user experience on a website or a web page. So the important parts are highlighted here, which you should really pay attention to. The first important part is change in user experience. So if you are making any kind of change in user experience on a website or a web page, and if you want to understand what effect will it have on the users, will it be a positive effect, a neutral effect, or a negative effect, and do so in a statistically reliable and robust manner, then A/B testing or A/B experimentation is the go-to tool for you. Okay? So with this definition in mind, let's go ahead. Rather than going through a lot of theory, let us try to understand the concept or the process of A/B testing and experimentation by using a practical situation or a case study. The background of the case study or the premise of the case study is as follows. Let's say you work in a company, an internet company which is named searchmyquery.com. The company has a landing page which has a white background, and you can enter a query into the search bar and get search results. So it's a search engine. Someone in the company claims that if we change the background to light blue, it will drive in higher engagement from the users and will be beneficial for the company in the long run. And they have come to you, the data scientist in the company, to help them verify this, whether it is true or not. And you will be using your A/B experimentation knowledge to verify this. Okay. Just we can take a simple assumption here that the weekly unique visitors to the website are around 1 million. Okay, so 1 million users visit this website on a weekly basis or an average right now. Okay, so that is an assumption we can take in this simplified scenario. So let's go through the different steps in the A/B testing process. The first step for any analytical problem that we generally solve is the definition of the problem. So here we need to define the problem. As we have already mentioned multiple times, this is an experiment. An experiment generally starts with some sort of an assumption. we need an assumption, or we need to test an assumption while performing an experiment. Such a formalized assumption in the field of statistics is often termed as a hypothesis. That is why we have something called a hypothesis testing in A/B testing experimentation, right? So it is a part of A/B testing. A hypothesis is nothing but a formalized assumption. Okay. So our hypothesis here is that changing the background from white to blue will drive up engagement. But we still don't know what exactly do we mean when we say engagement. What is exactly engagement? We need to determine that. That's really important. In this scenario, we can define engagement as number of queries divided by the number of visitors to the website. That is a metric that we can define as engagement. Again, different people might propose different metrics, but let us assume that within the company, this is the accepted metric that everybody tracks. Okay, so let us assume for that. And this is an agreed upon metric for this experiment. So now we have a metric which we can test on and check whether we get more engagement with a white background or the blue background. So if the assumption is correct, if the person's assumption is correct, then engagement from blue background or engagement after putting a blue background must be much higher or significantly higher than engagement with a white background. Okay. So this is the definition of the problem, a formalized definition of the problem. The next step is setting the parameters or the value of parameters for the experiment. So what are the parameters for the experiment? I've already mentioned that this particular website has 1 million weekly users. Per week, around 1 million unique visitors visit this website. In the area of statistics, such a universe of users is often termed as a population. So population is the total number of users in a particular study, in this case coming to the website or coming to the landing page. Of course, we cannot run this experiment on the complete population of 1 million users. Why? Because we don't know it will work or not. So there might be a lot of harm that might be caused if our assumption was wrong. So we take a subset of this population, which we call as the sample. We randomly select some percentage of the population, which we call as the sample, and we conduct our experiment on that. We try to make sure that the sample is large enough to yield us significant results, but at the same time, not very large, so as to affect the user experience significantly for a lot of users. Okay, so the sample size is something you will have to determine using this. So let's say we consider a sample size of 2% of the population to be reasonable, because 2% boils down to 20,000 users, which is a very decent amount of people. So this is the sample size. This is the first parameter that you need to set. The second parameter that is important to consider is called the confidence. The confidence level. Going back to the concept of sample, let's say today you are pulling in 2% of people from this 1 million population at random using some random algorithm. Tomorrow you perform the same exercise, you are more probable to get a different set of people, right? There might be some people overlapping between the two, but a lot of people might be different because your sampling percentage is small. So how do you make sure that you overcome this problem due to this sampling error, right? This sampling might introduce an error, which is called the sampling error, which might affect your experiment. So that is where the concept of confidence comes into the picture. if we set up, let's say, a confidence level of 95%, what we mean to say is, let's say this experiment took place a lot of times. I have a 95% confidence that the results that I get from this particular experiment would hold true. Now, there are a few cases wherein it will still might not hold, but they are very less in number. So this is the confidence level that you will have to set. Typically, we set it to 95%. In some cases, even 99% or 99.5% is also acceptable. It depends on the person conducting the experiment, and they analyze the data to see what is acceptable and how much risk is involved in the whole process. So the sample size and confidence level are the parameters that we need to decide upon and set for the experiment. So from the previous section, we understand that we need to conduct an experiment on 20k users with a 95% confidence level. Right? Confidence level. Okay. Now, what will be the next step in the experiment? We need to show the users the new or the changed background, right? And that is how we will know how they react or what is the effect of that background on them. But we can't show all the users the new background because we won't know how the users under the same conditions having or seen the original background would have reacted, right? Herein you can claim that if, let's say, the rest of the 98% users are still seeing the original background, why aren't we considering that? The reason behind that is, generally in such websites there are a lot of optimizations that keep on taking place and a lot of external interventions that keep on taking place, right? So let's say if somebody is running some kind of a campaign, some other team is doing some kind of a test, it might interfere with your test. So you have to make sure that this 20k or this 20,000 users are not a part of any other change or study, otherwise your results might get contaminated. Okay, and within this users, we split it into two populations, or rather the two parts. The first is called test and the second is called control. The test population is the population on which we show the new or the intervention, right? The new web page or the intervention in general that we are putting in. So let's say even if you were changing some kind of algorithm or changing the layout, the new change would be shown to the test population, and the old one or the status quo, the white page, would be shown to the control population. Okay? So the split is done randomly, and generally we do a 50-50 split, so 50% 50% split. So in this case you will have 10k each users shown test versus control. Okay, and you let this experiment run for some time. Maybe you can let it run for a week or a month, depending on how much data you want to collect and how much time do you have to conduct the experiment for, right? So these things you have to balance, and you let the experiment run for some time and collect the data. The next step after collecting the data is analyzing the results. So you have the parameters, I will just write params, that we have already defined in step 2, and in step 3 we implemented all the experiments, the experiment framework, and collected the data. So now it's the time for analyzing the results. To analyze the results, you would have to first calculate, of course you will have to calculate the engagement metrics for the test population and control population, or the test sample and the control sample, right? I'm writing that as ET and EC respectively, right? So you will be calculating these two metrics by using the queries and the visitor data from these two tests, or these two samples. And as we had discussed, common sense dictates that ET should be much more than easy. But the problem is that we have just conducted a test on taking one random sample. How do we know that for different samples this result would hold? That is where the concept of statistical significance comes into the picture, and the theory of statistics comes to our rescue. Armed with all this knowledge, let's go towards getting some conclusions. Right? So we already have the engagement metric for the test and the control samples. So the first thing that we might want to do is to see or maybe obtain the difference between the two, right? Because from the beginning we have been trying to say that this should be much more than 0, at least significantly more than 0, and that is something that we have been pursuing, right? We have been trying to pursue the same. But this is a difference between two numbers, so we need to standardize it, right? In statistics we need to standardize. So that standardization is done by standard deviation. So it might be provided to you or you might have to estimate it, but we won't go into the details of that, but you need to divide it by the standard deviation. Okay? And using this final number or this final value and maybe using some tables, etc., you get what is called the p-value. The p-value for this experiment. Okay? So you get the p-value. P-value stands for probability value, and it is the probability under the assumption that what we call as the null hypothesis. Null hypothesis in this case would be that there won't be any change in engagement with the intervention of a blue background. There won't be any change in the engagement with the blue background change at all. So that is the null hypothesis. Assuming this null hypothesis is true, what's the probability of getting this number that we are getting or observing this difference that we are getting? So using this definition, it's very intuitive to understand that the p-value is lesser the better, right? Because you want that probability of getting this number under the assumption that this is true should be very less, right? Because you want to avoid that false positive. Okay, so the p-value in practice should be lesser than 1 minus the confidence level that we have defined, right? So this should be lesser than 0.05. So if your p-value turns out to be, let's say, something like a 0.03, maybe a 0.01 or so on, then in this experiment you can go back to your stakeholder or maybe your colleague and say that it does seem like the change in the color of the background to blue will drive an upward lift in the engagement metric. That's all you can say. You cannot say how much it will drive, right? But you can say it will drive an upward lift in the metric for engagement. That's all you can say. If it is lesser, let's say if it is more than 0.05, let's say if we get something like 0.09 or maybe 0.1, then that is a red flag, and in that you will go back and say that I don't think I have enough evidence to support your claim that changing the color of the background will make a difference to the engagement metric. So that would be your conclusion in that case. Okay, so now I think we are able to understand how do we start with a problem, then define it and go through all the steps and conclude whether that intervention or the change that we are making to the user experience is having a positive effect on the user experience or not. And different companies, big and small, use this framework for solving different problems. So let's say if a company like Amazon or YouTube, they would have a recommendation algorithm for their products or videos respectively, and they might use A/B testing to check if they make a change to that recommendation algorithm, how would it affect the users and how would it affect the engagement, and they might define their own metrics for the same. And like that, there are different applications in the industry where A/B testing is widely used and is very useful. So with this, we come to the end of today's video. I hope that you have a reasonable knowledge about A/B testing and experimentation right now, and these are not just buzzwords to you, but you understand them as well.
Although this term confusion matrix has this word confusion, but it's not confusing at all. Alright, so let's get started and let's first understand the problem statement, why we use confusion matrix, and where we can use confusion matrix in practice or in real world. Alright, so the problem statement is as follows. The employee attrition has always been a major problem for companies. Now, what exactly employee attrition is? When an employee decides to leave the company, okay, maybe because of XYZ reason, because of maybe another company is giving a higher salary, higher package, maybe the employee thinks that the learnability curve in that other company would be higher, or maybe the workplace or the office is near to the new office that he is looking. Because of XYZ reason, if an employee decides that he wants to leave company, so that would be a big problem for the current company because they would have to interview 10 different candidates for that one place. There would be a loss of some information as well, right? So they would have to interview more candidates. All right. Now, as a data scientist, you have to solve this problem. Now, what you have done as a data scientist, you have built a classification model, okay, that can predict if an employee is leaving, it will predict 1. And if the employee is not leaving, it will predict 0. Okay. Why do we call it as a classification model? Because it is categorizing. It is categorizing into 2 categories. For example, if employee is leaving, it will say 1, yes, employee is going to leave. It will predict employee is going to leave, and 0 if the employee is not going to leave, right? That's why it's called the classification model. So in this video, we will not be talking about how to build this classification model. You can check out other videos on the intuition of logistic regression, intuition on decision tree. So there can be multiple classification models that you can use. For example, logistic regression is one model, one such model that you can use. Decision trees can be another model that you can use. Okay, so in this video, we will be talking about how to evaluate your machine learning model. You have built the machine learning model and it's working fine. It is predicting for an employee. If you provide an input to the model, it can predict the employee is going to leave or not, right? Not leaving. So it will just predict 1 and 0. Now the important question is that we have to solve, we are solving in this video, is how would you evaluate that the model that you have created is sensible? This would be an important question to ask. Why it's an important question? Because, hey, I can create a model that can predict all 1, 1, 1, 1, 1 for all the employees. It means that I'm saying, hey, this employee is leaving, second employee is also leaving, third employee is also leaving, and all the employees are leaving. This is not a sensible model, right? Or in other case, I can just say, hey, no one is going to leave. Just predict 0, 0, 0, 0, 0 for everyone. Again, this is not a sensible model. So to put any model in the production, before putting any model into production, I need to evaluate how good the model is, how sensible the model is, how sensible these predictions are from this particular model. Or even sometime if you have 5 different models, let's say in a data science team, we have created 5 different models. Now, which model to put in production? We can evaluate all the 5 models using confusion matrix, and then the best model we can put it in production. All right. So what we have is something like this. We have a model, machine learning model. Okay. It can be logistic regression. It can be decision tree. It can be SVM, any model. What I'm concerned about, okay, this, I'll provide the employee features. I'll provide this as input. What are the features? Features can be what is the current salary of the employee, how many years this employee is working, maybe the work experience, okay, and what is the team he works for, and so on and so forth. The other features that you have for an employee, how you represent an employee, right? So if you put all these features as input, this is for one employee. Okay. Similarly, if you input another employee, features of another employee, right? This model will give you the prediction. It can give you whether the employee is going to leave or not leaving. So this is what we have. Okay. Now let's understand. Let's say there are 100,000 employees in a company, and the actual data says that 770 people did not leave the company in the next month, and out of 1000 people, 230 people left the company. Okay, but if you input these 1000 employees to your machine learning model, the machine learning model says that 800 people will not leave the company in the next month. Let's say, since we are predicting for the next month only, let's say 800 people did not leave, so it is predicting zero. It is predicting zero for 810 people, and for 190 people it is predicting category 1. Okay, this is the predictions you have from your machine learning model, and in actual what we have observed is 770 people did not leave, whereas 230 people left the company. Now I need to understand, is this model, the model that we have used here, is a sensible model or not? Is it a sensible model? Because you can see that there are some misclassification, right? But I want to understand in more depth, and that's why we will understand the confusion matrix and we will plot the confusion matrix. So the confusion matrix is actually a matrix. So for example, if you have two categories, right now we have employee will leave or will not leave. I have two categories. So the matrix that I will plot will be 2 cross 2. If you have three categories, maybe in any different situation or a different challenge, you can have 3 different categories. In that case, the confusion matrix would be 3 cross 3. If you have 4 categories, 4 cross 4. If you have k categories, k is a general term, then the matrix that you will plot would be k cross k. Okay. Now, since in this problem that we are tackling right now, there are 2 different classes, let's stick to only 2 cross 2 matrix. So this is how the confusion matrix look like. On the column side, we plot or we put the actual labels, actual categories. What are the actual categories? The actual categories were employee will leave 1, employee will not leave 0. So employee will leave, it's 1, employee will not leave, it's 0. On the row side, on rows, we will put predictions. Now predictions can also be 0 if the model says that employee is not going to leave, and 1 if model says that employee is going to leave. Okay, and hence this look like a grid. Okay, this look like a grid. So what we observed from the data is for 1000 people, we had 1000 people. Model said that okay, few people will leave, few people will not leave, but in actual we saw that okay, these number of people left the company and these number of people did not leave the company. Okay, so let's understand and let's plot that data in the confusion matrix. So it looks something like this. So this number 730, it says that hey, your model is saying that these number of people will not leave the company. That's why it's 0. 0 means will not leave. In actual, what we observed that they didn't leave the company, and this is the 730. So these 730 people or employees, model said that they will not leave the company in the next month, and in actual they didn't leave, right? So it means the model is correct about these 730 people. So out of 1000, at least model is correct about these 730 people or employee. Look at these 150, what exactly this 150 is saying. So this 150 is saying that the prediction is 1. Prediction is 1 means model is saying they will leave, right? Model is saying that these people will leave, and in actual we observed that the next month they leave or they left the company. So it means again model is correct about these 150 people. Model is correct about 150 people, right? So out of 1000 people, I can see that okay, these 730 people plus 150 people, model is correct about these number of employees. But what about this 40 and 80? What about this 40 and 80? Let's understand this term 40, right? What exactly this number representing? The model is saying that these employees are going to leave. But in actual, what we observed is they are not leaving. So for example, if someone who is happy with his job, well settled, and so he's happy with the job, right? he will not leave the company. Why would he leave the company? But your model is saying that, hey, this person is going to leave in the next month, which is wrong. Which is wrong, right? Similarly, look at this one, 80. Model is saying that these 80 people are not going to leave. Whereas in actual, what we observed is they left the company in the next month, which is again, model is wrong about these 80 people. So 40 plus 80. The model is giving wrong prediction for 120 employees. And for 880 people or 880 employees, 730 plus 150, for 880 people, employees, model is giving the right prediction, correct prediction. And hence we can say the accuracy of a model is 880 divided by 1000. That will become 88%. Okay, so it means that 88% accurate. We have the accuracy of a model 88%, and the error would be 12%. Okay, let's give the terminology to the confusion matrix. So this thing, so we can see that over here we have TN, then FN, FP, TP. Let's understand what exactly this TN, TP, FP is. So in the machine learning terminology, when we have two categories, 0 and 1, generally 0 category is termed as negative category or negative class. Okay, or negative category or label, you can say. 1 is generally called as positive category or positive class. So if you sum across this column, you will get 730 plus 40, that will become 770. Okay, and if you sum across this column, this will become 80 plus 150, 230. So it means in actual there were 770 negative people. Negative people as in they did not leave in actual. And in actual there were 230 positive people. So this is the total negative in actual data, and this is total positive in the actual data. 230 people actually left. If you sum across rows, this will be the prediction of 0, right? So this is 730 plus 80. This will be 810. Model said that 810 people will not leave the company. And if you sum across this row, this would be 40 plus 150. This would be 190. Model is saying that 190 employee will leave the company. Okay, so this is NP negative, positive, and this is the prediction of the negative class. This is the prediction of the positive class. Now let's understand about this terminology. What is this TN? So this TN, there are two terms. There are two terms over here. The first is what your prediction is from the model. What the model is predicting. Now in this case, model is predicting class 0, and class 0 is termed as negative. So I will write N. So by the way, negative and positive. So positive, the term positive is not coming from a positive news. So here in this case, when the model is saying 1 means positive, right? But this is not a positive news for the company if employee is leaving. But this is general terminology, and don't relate this positive with a positive news. Positive is just because 1, and negative would be because it is 0. Okay, because this is 0. All right, so this first I need to put N. Why? Because model is predicting 0, and 0 means negative. Now this second term would be, is my model correct? Is model correct in the prediction? Whatever the model has predicted, is model correct in that prediction? So if the model is correct, then it means I need to put true. And yes, in actual it is 0. Model also predicted 0. It means this is true. Model is saying true, right? So that's why it's called true negative. Let's look at this term. It's TP, right? TP. So first, what model is predicting? Model is predicting class 1, category 1, which is positive. This is the prediction, right? This is the prediction from the model. Now, is my model correct? Yes, because model predicted class 1, and in actual, it's also class 1. It means model predicted that these people are going to leave, and in actual, these employees left the company. That's why it's true positive. Look at this one, right? Look at this FP, right? What your model is predicting? Model is predicting that these people are going to leave. That's why positive. Class 1, right? Class 1. But Is this model correct? No. In actual, they did not leave. These employees did not leave. And that's why it's false. It is kind of, we call it as false positive. It is kind of false alarm. You're saying that, hey, these 40 employees are going to leave, right? These people are going to leave. But in actual, they're not leaving. They're happy with the job. So you will be putting a lot of extra resources for retaining these employees, right? And that's why it's called false alarm. You're generating an alarm that, hey, make sure that these employees will not leave, but they're not leaving. They're not leaving, right? They're happy with the job. That's why they're called as false positive. Look at this one. This is false negative. What you are predicting? Class 0. They will not leave. You're saying employee will not leave. Negative. All right. But in actual, they left the company. It means you're telling wrong, right? The model is predicting wrong. So that's why it's false. And this is the most critical number. Why? Your model is saying that, hey, these employees are not going to leave. So be relaxed, right? But in actual, they left the company. And we wanted to retain these employees. That's what the purpose of the machine learning model is, right? That identify those employees who are going to leave and retain them so that we can put energy, resources in retaining them. But the model is not able to predict. Model is saying that, hey, these people are not going to leave, which is wrong. And hence, this would be very, very important number. I want this number to be very low. Ideally, it should be 0. That no employee is left. Like if the employee in actual is leaving, then the model is not predicting wrong. Model is not predicting that he's not leaving, right? So ideally, these two numbers, false predictions, false positive and false negative, ideally they should be very low. Ideally they should be 0. Ideally it should be 0, but we should have a model having false positive and false negative to be as low as possible. And these two numbers, TN and TP. So always remember the diagonal element should be very high. The diagonal element should be high and the off element, the rest of the element should be very low. Then I will say that my model is sensible. So if you want to compare two models, just plot the confusion matrix for these two models and observe these false positive, false negative, true positive. The diagonal element should be higher. And if you're concerned about these employees, for example, these are those employees, the model predicted that these are not leaving, but in actual, they left. So this is the most critical number. I want this number to be as low as possible, right? And that's how we can plot the confusion matrix. We can evaluate a machine learning model. And the accuracy of this model would be TN plus TP divided by all the numbers, divided by TN plus TP plus FP plus FN. And this would comes out to be 88% because we have already seen that 730 plus 150 would be 880, and hence the accuracy would be 88%.
Things start getting complex when you have 4 or more dimensions. Now, the human brain cannot comprehend these many dimensions at the same time. Now, think that you have 100,000 rows in your dataset and you have maybe thousands of columns in your dataset. How would you comprehend that sort of complexity? Now, this is where we start talking about dimensionality reduction techniques. Hello everyone. My name is Harshit Tyagi, and in this particular video, we are going to talk about one such dimensionality reduction technique, which is called principal component analysis. So I'll give you an intuitive understanding of how PCA works without talking about the mathematics behind it. So let's try to understand how PCA works using this very simple example. So here we talk about principal component analysis, or PCA. Now PCA is a dimensionality reduction technique. We can use PCA to transform a large set of variables into a smaller set whilst preserving as much information as possible. Or you can say that we try to capture the essence of data with fewer variables. Now, you must be wondering, why do we actually need to reduce the dimensions? So there are a couple of reasons for that. Now, the first thing is, with fewer dimensions, it makes your work easier. You cannot probably comprehend working with thousands of variables, but if you can reduce it to a couple of hundreds, then it makes your work easier. Second reason is that you reduce noise in the data. That is, dimensions which add little explanation to the underlying data, you can get rid of those sort of dimensions. Similarly, we have a third reason, which is it is easier to visualize the data. So you can plot 2D, 3D data sets, but let's say if you have more than a couple of hundreds, it becomes a very difficult task to visualize what the data actually looks like. So with fewer dimensions, it is easier to visualize as well. So now let's try to understand how PCA can help us in reducing the dimensionality of the data. So how does this work? So for this explanation, let me use a two-dimensional data, which is easier to understand, and then we can scale our understanding to more number of variables as well. So let's say we have data of a few people. We have their height and their weight. So HT here denotes height and WT denotes weight. So let's say we have a few data points, and if we plot them here on a 2D plot, a scatter plot basically, let's say on the x-axis we have weight, on the y we have height. This is what, let's say, our data set actually looks like. Now for this data set, we have this two-dimensional data. Now to reduce the dimensionality of a 2D data, where can we go? We can only make it one dimension. So the goal for PCA here would be that we want to reduce the dimensionality from 2 to 1. We are using this very simple example so that it becomes easier to understand, and then we can basically talk more about 3D, 4D, 5D, 100D, 1000D, so on and so forth. Alright, so one solution that comes to mind when I want to reduce the dimensionality of this dataset is I can, let's say, get rid of my weight variable. So if I get rid of this weight variable, I only have one dimension left, which is height. So what would that data look like? So converting a 2D data into 1D is basically going to give you a line of points. So if you get rid of weight and map all these values to, let's say, y-axis, so your data would actually become this line of point all on the y-axis. So all of this data, all of these points are going to be mapped on this particular line, and this is going to be your data, a simple line of points. Now this is one way. Another way could be that you get rid of this dimension height and you only keep weight. So if you only keep weight, then your points are going to be mapped to, let's say, this particular axis, and you would have data in this line of points as per the weight dimension, and you are getting rid of height. Now the problem with this particular solution, getting rid of one of the dimension or one of the variables, is that you have lost all the information from one dimension, but we want to keep as much information as possible. So how can we reduce dimension in the most efficient way? And this is where PCA comes into the picture. So let's see how PCA actually solves this problem. So again, I am plotting weight, height. This is our data. Now, first thing that PCA does is, first step is calculate the mean in the data, mean point in data. So this is the first step that PCA would do. So let's say your mean lies somewhere over here, denoted by X. Now PCA, what it would do is, the second step is, it will try to plot a line that passes through this particular mean point. Now there would be multiple lines passing through this point. So PCA essentially wants to find the line that best fits this data, or in other words, you can say, so let's say if this is one line, what you would do is you will calculate the distance. You will map all of these points to this particular line, and then you basically calculate the sum of all of these distances, and you want to minimize that distance from all the points to this particular line. Now this line is basically a combination of both height and weight, and this new dimension is called principal component 1. Now the best possible line is going to minimize the distance from all the points. So PCA essentially would find a line that passes through the main point and minimizes the distance from all points in the data set. So this is what PCA does. So this new dimension, the first principal component, is basically going to give you the best possible line that minimizes the distance. Now when you map all of your data points to this particular line, you would get a plot which looks something like this. And let's say this is the point, this is the line, all the points over here. So your data point would actually be lying on this particular principal component, which is your PC1. Now this line of points basically represents all the original points on a new dimension, which is principal component 1, and it represents not just weight or the height, but a combination of the two. And more than that, it is the combination that best represents the variance in the data. You can see the spread of the data, and it helps us preserve as much information as possible when we reduce the weight and height to one single dimension. And if you draw another line which is at the right angle to this principal component 1, you basically have a new dimension which is called principal component 2. Now you can only have as many new dimensions as the original number of variables in your data. So here we had 2D data, so we can only create 2 new dimensions, but the goal is to reduce the dimensionality. So here we would just stick with principal component 1 that best represents the data or the variance in the data. Now if we rotate these set of points, so here this is what the data is with weight on the x-axis and height on the y-axis. So now if we rotate these points to the horizontal, and we can compare the spread of points with the spread for just the weight and height. So here you can see that if I simply just keep weight, so the spread would be somewhat in this particular range. So here I would just map all of these values. So these would be values and the spread would be somewhere over here. So let's say this is my weight. So on the horizontal axis, this would be the spread of points for weight, and similarly for height as well, this is going to be the range and there would be points here. So if we rotate it horizontally, so this is going to be somewhat, narrower than weight because the range is small, so the spread of the data is less as compared to weight. But now if we compare it with our first principal component, the new dimension, now this is along the diagonal as we can see. So all of these points would actually map over here, and for PC1, if we rotate these points to the line and plot it horizontally, this would give us a spread somewhat like this, which is way more than the original variables weight or height. So principal component 1 is that axis that spans the most variation in the data. And then if you want to look at principal component 2, which is this orthogonal line to PC1, so this is the axis that spans the second most variation in the data. So this would be somewhere over here, and you can basically learn that because this is going to be the range. This is going to be the range of all the values. So all the values would map over here to this line. Let me just denote it with red. So yeah, you can see all of these points are going to be somewhere over here in this line, and if you turn it or rotate it horizontally, this would be the variation explained by principal component 2. So this is our PC2. So you can see that how PC1, the first principal component, explains or represents the most variation in the data. Now, one thing that we should try to understand over here is what PCA has done. So is it just that PCA has rotated our data point? So again, let's quickly plot the data. So this is my original data. Now PC1 and PC2, let's say these are these. So if I have PC1 and PC2, so let's create a plot. This is PC1, this is PC2. Now if we rotate this data set, our data set would actually look something like this for this particular plot. Some values above PC1, some values below PC1. So this is our rotated, the new data point. So looking at these two plots, you would see that it kind of looks like we have just rotated the data. Now comparing these two plots, you will feel that all we have actually done is find the optimal way to rotate our original data so that most of the variance or the spread is captured on the horizontal axis, which is principal component 1. And here in this particular image, here you can see it's just a rotation of the first image, which represents our original data. Now, this is not to say that PCA is to rotate the data, but by rotating it in this way, we can derive new variables which are called principal components. And in fact, because our aim is dimensionality reduction, we don't particularly want to keep all the principal components. We just want to choose the first few, the ones that preserve enough of the information in the data to proceed with our further analysis. So here we had 2D data. So we'll stick with 1D. So we'll probably just keep principal component 1 and discard principal component 2. If you had 3D, you might keep 2 or 1. So 4D, you might have 3, 2, 1. So similarly, you can scale it to 100D, to 1000D, to 10,000D. The math behind PCA would still work, although it would be very difficult for us to visualize it going above 4 or more dimensions. But we rely on mathematics, and that is why PCA works out really well when you have more than hundreds of variables that you want to reduce. So this is what the essence of PCA is. This is basically the benefit of using PCA is. So that was all about principal component analysis. And there is a lot of mathematics that actually drives this particular algorithm. If you want to study deeper, you can learn linear algebra, refresh all the basic concepts, and then you would want to dive into eigenvectors, eigenvalues, singular value decomposition. That actually is the crux of PCA. Now you would ask, where is PCA applied in the industry? Why are we even studying it? So PCA is being applied in biomedical industry for drug discovery programs, healthcare industry, fintech, customer profiling, image compression. So there are all sorts of areas of application where PCA is being used in these days.
Guys, this is an AMA session on data science. We have two guest speakers for today. Neelmani Gupta, who heads data at Driver Platform and Gojek, and Manish Khandelwal, who is senior data scientist at Sixth. I'll let both of them introduce themselves and maybe talk about your journey, that how and when you got started with machine learning.
Yeah, so I think Manish will go first, I guess, right?
Okay. Hi, everyone. I'm Manish. I work as a data scientist at Sixt right now. Previous to Sixt, I have worked at organizations like Media IQ, MoEngage, and Versa Innovation. So regarding my data science journey, it goes back to my post-graduation days. So basically, I was pursuing my master's in computer science during 2012 to 2014 from IISc Bangalore. And in third or fourth semester, I started reading a lot about machine learning. We had a lot of courses which were focused toward machine learning or artificial intelligence. So that's how I got interested in the field. And then I did a thesis, which let's say we have to do on machine learning itself. I picked a specific problem, and that's where it all started. And then after completing my post-graduation, I joined Media IQ as a junior data scientist. And since then, I have been working on a data science problem in the same domain. So yeah, over to Neil for his experience.
Yeah, thanks. I think this is really interesting. So Manish has a very bottoms up, I would say, approach to data science where he started learning it in academics and then followed it up with moving to the industry. But mine is kind of opposite. So I did start with I am an engineer and MBA, so it's like I belong to the herd in India. Too many of them, too many of us floating around. But the thing is, when I started my journey or my career, when I was doing engineering, that was a time when I used to write a little bit of code, and that was the first time I wrote something which was related to data science and machine learning. I didn't know at that time that it was some kind of mathematical model. I think that even the term data science had not been coined, or at least I didn't know at that time. This is about 15 years ago. Then I completely shifted gears, went to very different functions. I was doing agriculture policy research. I was doing credit ratings. I worked in finance, did my own business, did my own startup, which failed. And while doing all of this, somehow I was decent with data. I liked playing with data, and I was always interested to look at data before taking a decision, even when I was running a business and all of that. So even I could run regressions and some basic stuff which we do in data science these days. And then about 4 years ago, an opportunity came when I got an opportunity to completely delve into data science as core, and I started it. And I didn't know coding. I didn't know it had been a long time from doing mathematics. But I would say initial 3-4 months it was difficult, but then I was able to pick it up. So to all you guys who think data science is difficult or can only be learned through academics, that's not the case. I'm a live example. I would say if I can learn coding in 6 months, deploy code in 6 months after learning data science, from looking at solutions and then working backwards and see how data science is there and how it works, I think anybody can do it if I can do it. Yeah. So that's all about it. What did you got motivated from to become a data scientist?
So basically, during my post-graduation, when I started learning about this field, data science or machine learning, I was really amazed to see, let's say, how using few data points we were able to predict future. So till that time, I didn't have idea of I had only heard some of the buzzwords okay, people are building robots and blah blah stuff. But when I really did an experiment, I had some historical data, and then we were able to do some predictions. And then when I realized the scope of it, there was already so much on the internet. You could predict what movies you are going to like. You could predict which patient might have high probability of let's say a particular disease. All those things got me excited. So that's where I got my motivation. Okay, this is the field which I want to pursue. That feeling still keeps me motivated. You could actually predict things which have not happened. So that's my motivation, Sunil.
So there is a question. We hear a lot of terms like deep learning, machine learning, AI, data science. Data science itself is like a subject. We have subjects like mathematics, and then you have subjects which are combined. So for example, we had aerodynamics engineering. So you have engineering where you're learning something, but then you are including some other parts to it. So similarly, data science is, I would say, a field where multiple learnings are kind of combined, or multiple subjects, you can say, so to say, right? So yeah, I would say data science is that broad academic kind of field. So this is data science. So what is AI? AI is artificial intelligence. AI can very simply be put like, a calculator is an artificial intelligence. So where you press some buttons and it will give you some output. So basically you do 2 plus 2 on a calculator, it gives you 4. So there is some intelligence built in the calculator, which tells you, which calculates 2 plus 2 for you. So AI can be as simple as a calculator and as complex as autonomous cars. So what is machine learning? Now that is, I think, one of the core aspects which you should understand. So if you see AI is like the superset, where, everything that we make machines learn or make machines do comes under AI. Machine learning is where so if you think like a calculator, you have fed some instructions to it. You have told him, or, there is nothing that a calculator is learning on the go. 2 plus 2 is always 4 for a calculator, right? But what happens in machine learning is, in machine learning, you basically learn from the past and you try to predict the same patterns in the future. So very, very, very simple example is you go to YouTube and YouTube will start recommending you videos, right? Now, how does YouTube come to know about that? So YouTube, what it has done is it has made the machine learn something about you, your preferences. And when you land up on YouTube, it will show you that, okay, this video matches your preference. Maybe you look at cricket a lot. So it will just throw up the latest cricket video when you go to YouTube. Now this is very different from a calculator, right? Because this time, if I land up on YouTube, there will be different results. In a calculator, if you type 2 plus 2, if I type 2 plus 2, it's the same thing. So calculator is that section, I would say, of AI where you have explicitly programmed a machine. While in machine learning, you basically make the machine to learn and kind of enable it to learn more from data. And what is deep learning? I think within machine learning, deep learning is part of machine learning. It caters to a slightly more advanced kind of concepts where, specifically when the data form is like images, then deep learning has found to be perform better. It's not like that machine learning cannot perform better there, but deep learning is like, going deeper into algorithms. Yeah, that is broadly how it is. So AI is a superset. Within AI, you have machine learning, and within machine learning, you have deep learning. Yeah. Okay, great. As advances in AI continue to progress, do you guys think data science jobs are going to? No, I don't think so. So the thing is like this. So there are two aspects to that. I think this is a very good question. So first question is like, you always ask, like a startup, you had this biotech boom. You thought that the biotech boom will be there, but it never kind of flew. At least when I started my engineering, it was a biotech boom and it never flew. But data science is beyond that. Data science, I think, is going to be there. And one of the main reasons is even though, there could be a lot of automations, maybe people would not be needed, maybe machines could do it, but that's okay. Like a lot of work machines do these days. But behind it, all the concepts, all the basics are still very human driven, I would say. The second thing why I feel that data science will not die is very simple. If you see image, if you see video, if you see sound, all this data can only, at least for now, can only be either read by a human mind or you apply machine learning to read it or interpret it. Otherwise, there is no other way. Given advances in video, so for example, you take any data set, you can do it on Excel. You don't need to code and you don't need to build prediction models. But you can't do that for a video data. You can't do that for a sound data. I mean, you can play around with that, but can you make decisions on it automatically? So that's why data science is going to stay.
Yeah, I agree with Neil. I guess there is a lot to do in data science, and the thing is, as soon like let's say we get stronger tools and technologies, we start looking for more difficult problems. So I don't think in near future or even like whatever I could imagine, it's going to be there. Like let's say you see we would have these many jobs and blah blah stuff. That is something which like let's say I can't comment on, but yeah, data science is going to be there.
Okay, what's the most important skill in data science? So data science, as I see, is essentially three components. Has three components. One is mathematics and statistics. The second is some amount of coding that you require. It's important. And the third is some knowledge about the problem that you're solving, which people would say, many names like domain knowledge, business knowledge. I'd sometimes use common sense as well. So let me give an example. Let's go back 30 years ago or 20 years ago. And you go to a shop and you say, hey, I want bread. And then there is an uncle sitting there on the shop and he says, okay, beta, you are buying bread. Why don't you buy some butter as well? So what he just did a recommendation to you. And he was able to do it because he was able to relate that whoever buys bread generally buys butter as well. Right? So if you see that there is a connection. So he's learned it. And right now, Amazon can't have uncles sitting on their websites who can recommend, right? So it has to be done programmatically. So if you see, all three concepts are here. So the first concept is that you should understand when a person comes at Amazon, Amazon should know that what he's buying and what he or she is likely to buy when they are buying bread. So Amazon should have some engines who should recommend that, hey, you are buying bread, maybe buy butter. So there are two things to it. So first, the understanding of preferences, which largely comes from common sense, I would say. And then you have to do it mathematically. You have to create an equation or a model that emulates that preferences or that relationship, that when you buy bread, you buy butter as well. And now, because you have to put it on a website or an app, you need programming. And that is where programming comes in. So if you see, there are three core aspects to it. My understanding is if you start as a career in data science, then you need to be good at two of them at least.
Personally, for me, I believe like basically the curiosity to go into the depth of the data, that is something like which I really admire. My answer towards Raj Krishan, like what is the most important skill in data science? So I guess that curiosity, if you have it, then I guess you would be able to do things automatically which are required to excel in the data science field. If you get frustrated by looking at the same data maybe 5 times by multiple angles or through different slices and dices, then this is not the field where you would actually enjoy a lot.
Yeah, okay. So there's a question. How important is probability and statistics for learning data science? How important?
So for me, I would say this is quite important if you want to build a long-term career in data science, because you could see like these are the things which are fundamental to data science. And though there are a lot of tools, libraries available by which you would be able to just fit a model on the data, but when we ask like let's say someone to explain those models or to improve upon, then it's a dead end, because all these concepts like let's say mathematics or probability or statistics, they actually help you make sense of the things, what is happening, why something is happening. So I would say this is important, but at the same time, it's like let's say when you want to start with data science, you might want to just touch upon some basics instead of going into too much depth. But yeah, I feel this is important.
Yeah, this is perfect. I think so. The last point is very important. So probability and statistics is important, but to what degree do you want to learn initially? So to start with, you don't have to, learn whatever BSc statistics and ISI Kolkata teaches. No, that's not the amount of proficiency you need when you start. No, a simple understanding of probability and statistics that we did permutations and combinations in 11th and 12th class, some concepts from there, maybe some concepts from statistics, which are really, really basics. And that is good enough to start with.
Okay. How do I keep myself updated with fast developing areas in data science? So I feel like I'm not updated because things are changing rapidly. And when you are in industry, sometimes you have to stick to like, let's say, to the things which you are working upon. But there are two practices which I follow so that I keep getting some new information or I keep learning new stuff, which is like follow some people on LinkedIn whom I know, like they keep posting like let's say new stuff. So I could just give you one example. Bhaskar is one guy who I guess CEO of Analytics India magazine, and his updates on LinkedIn are really good. Like you would get to know, okay, when GPT 2 or 3 got released and what was when basically it was in news. Basically, I have found like let's say I maintain a list of 10 to 15 people who are into these different areas. Data science, big data. Even there is a guy who posts a lot around SQL. So I try to follow them, and then indirectly I would just keep getting new information. The same thing I do with YouTube as well. There are a few channels which are really good, and if you keep following them or if you subscribe to them, you would keep getting new stuff on like let's say daily or weekly basis. But still like let's say it's very difficult in the current scenario to keep yourself updated. Things are moving very, very fast nowadays. So
I think just to put it in a data science way, I think Google engines are pretty good at recommending. So if you start reading something, they'll start recommending you like anything. Like if you see my Google recommendations, 60-70% is data science. And then it's easier to kind of, quickly check which is important. And then like Manish said, it's a very good idea to follow people that feel are into the field. And also I think one of the things is you can follow blogs. There are good blogs on Data Camp is good, towards data science. On Medium, Medium recommends you really nice articles. Yeah, those are the things apart from, as Manish mentioned, LinkedIn and YouTube. Okay, Python versus R. So I started with Python. I am with Python. Never used R. Very briefly, I used R earlier in my career. So the community of Python is much vibrant than R right now. It's a bigger community. It's a vibrant community, and R is good at statistical techniques. But Python, I think, where it kind of goes a step ahead is in terms of, because these things have to sit into some app or in some websites, building these solutions and then integrating them with apps and websites is relatively easy in Python, is what I understand. Also, I've found Python syntax to be easier to understand. So yeah, for me, it's clearly Python, but I think Manish can also add that.
Yeah, I guess different people have different opinion. For me, again, it's on the lines with Neil. I like Python, and that comes from the background also. I used R for some time, and there was a point where we were looking to take things on larger data sets. We wanted to use Spark, and at the time, PySpark was more mature than Spark R. So naturally, like I was already using Python, and then at that time also it made sense for us to like let's use PySpark. So for me, whatever projects we did, they had to be integrated with something else where Python was the natural choice when compared to R. But there might be a lot of use cases where, like, let's say, people find R more useful. But yeah, for me, it has been Python.
Okay. So the question is on anatomy of data science project. So by anatomy, I would say like, what does a data science project look like?
So for me, like let's say a data science project, like typically it would start with a problem statement. Generally, like let's say in organizations, you would have a product owner, product manager, or someone who is looking at business, and they know, okay, what type of problem you want to solve. So that's how like you would start getting a problem statement, which can be solved using the data science practices. So, and once you get the problem statement, then I guess the initial part relates to figuring out the necessary data sources. So, you know, like, okay, you can solve this problem given you have this data. So sometimes collecting that data itself is a challenge. So that's the second part. So first is problem statement. Second is data collection. Third, which I generally focus on, is like, instead of building a model first, do some in-depth data analysis so that you understand the data really well. So later, whenever there are some challenges with the data, you actually know like why something is happening. Otherwise, again, it becomes like, let's say, totally dark. You don't get results and you don't know what is happening again. Once, like, let's say, analytics is done, you start looking at models which really fits your requirement. There are various kind of machine learning algorithms already available depending on your type of problem. You choose one, you define some metrics on which you would actually judge whether what do you call a success or what do you call a failure. And once you get those metrics, after that, it's just going towards, like, let's say, figuring out how to make your project successful. And then I guess the communication is the key part. So that's a brief according to me.
Yeah, I think you covered all the aspects mostly. The only thing that I want to emphasize on is, as you mentioned, there are different parts to the project. 50 to 60% of the time goes in the initial part, which is before you actually start predicting things, to understand data, to play with data, to get the intuition of data. And that is why I think Manish was bang on when he said that, if you don't like, getting a really hands dirty in data, because that is going to take you 50-60% of your time. Even data cleaning, we also say data washing and all of that. So that's a huge part. Okay. Next question is, what do you see when you hire a data scientist? Okay. So multiple things. It will also vary from junior to senior. But a common thing is, as I said, a basic understanding or basic writing of Python code, at least because we've always been looking at Python, but it could be R as well. A lot of companies have choices. So they give Python and R as a choice. So basic is coding skills, and coding skills for data science. So when you say for data science, that means you can wrangle data, you can play around with data with the coding skills you have. And the second thing is, for me, it's to build intuition on data. Are you able to identify patterns? And are you able to identify what the data is saying? So it's never a complete story. Like, even if I do say, a lot of data analysis, there'll be something that I'll catch in the data, some things I'll miss. It's never a complete story kind of somebody who can build a complete story. It will take a lot of time. But in the short time, are you able to look at those patterns, major patterns, and how much of that entire thing can you track? And I think the second point is fundamentals, data science fundamentals, ML fundamentals, which are very important. Like, why do you want to build the models? Questions like, what are the risks of the model? So for example, if you are building a recommendation system for YouTube and you are recommending videos, and if suppose I'm not in a mood to look at a cricket video and you recommend a cricket video, so it has a negative impact. So all models and predictions that you make in data science come with risk. So there is a risk factor to it. It can be successful, which is really good. But if the prediction, etc., is not good, then it has a risk to it. It has a cost to it. Are you able to think about that? Are you able to kind of hang on to a project for a longer term? Version 1, version 2, how can you improve this? So if it is not working, how do you improve? So I think these are the major things that typically, at least what we've been looking at when we hire data scientists.
Yeah, I guess I even look for the similar qualities when I actually have to hire anyone.
Okay, what are the different types of roles in data science? I think data science as such is only one role. But there are multiple roles around data science, around in the sense which data scientists depend on a lot. So for example, you would have heard about data analyst. So sometimes data scientists would depend on analysts who can give them some data. So it depends upon how your organization works. Sometimes data scientists are expected to pull all the data and do the analysis, and even after when you have built the models, then track them, and for that also data analysis you have to do. But in some companies, organizations, you would have people in your team who would do that specific job. I don't know if I answered that question, but yeah, that's how it is. But then there are data engineers, which are different. There will be a data warehouse team, which will be different. So yeah, there are different roles around data science. But as a data scientist, you generally end up using data to make, predictive models, mostly. But that could be other things.
Similarly, there are more profiles like ML engineers, researchers after PhD getting into research labs. What's your view on differentiating yourself as a big data engineer? So I guess the question is like, what is the difference between a data scientist and a big data engineer? So I would say like job of big data engineer is to handle the large data sets, maybe create a stable pipeline, efficient warehouse, which can be used by data scientists to, like, let's say, ingest data and run their experiments or build model on top of it. That's what differentiates a data scientist from a big data engineer. So a company which has like large scales of data, first they would need a big data engineer. Once they have done their job really well, then they would need data scientists.
Yeah. So think of it like a pipeline, like your app, right? So your app starts, so you feed some data into your app. So let's say you're a consumer, and that data has to sit somewhere. So data goes from the app to, let's say, on the cloud where, the data sits. So from app to the cloud where the data sits in form of tables, etc., is where the data engineer basically comes in. And the data engineer would basically take care of maintaining all this pipeline of data coming from here to here. Now, once the data is there, then you can start doing things on it, right? And that is where data analysts and data scientists come into the picture. So if you don't have data engineering team in your organization, better to have that first rather than a data scientist. Because to have data very clean and proper form in storage hugely impacts efficiency of a data scientist. So data scientist is your math resource kind of, right? Who will apply mathematics and coding on the data. But if the data itself is not very clean, then probably you need to first overhaul your engineering pipelines and then probably look into it.
For data scientists, having knowledge of big data is a must or not. So what I have seen is it depends on organization to organizations. I have worked in a setup where, like, let's say the data set was quite large and then you don't have a dedicated data engineering team. So even when you want to, like, let's say, build something out of the data, some knowledge of big data should be there, even with data scientists. So when I say some knowledge, it doesn't mean like you are an expert in Spark, but like, let's say you know how to run Hive queries on top of, like, let's say, cluster, or maybe use Athena to actually ingest through large data sets, so that you are able to get that data set which you actually need for your project. So I would say it totally depends on the project and the job, and also on the setup. So it's never, like, let's say, bad to have that extra knowledge with you, because sometimes it would like improve your speed of the data science project delivery itself.
I would say it's a good to have, like what Manish said, right? So it's not a must have. So as a data scientist, you are not required to know big data or, the engineering part of it. What you're required is mainly how do you understand ML, your fundamentals. If it's a deep learning project, then how do you understand deep learning and all of that. But as Manish said that, if you have that extra knowledge, it just enables you to be faster and more efficient. That's how it is. Okay. So what do people expect from a fresher data scientist? I would say not very, very different than from, let's say, a junior data scientist. I would say so. It'll be like, again, strong fundamentals of ML. I would say again, a decent understanding or, hands-on experience on building data science projects. I think some of them is required. Yeah, I think that is how it is from a very fresher, I would say, data scientist. Yeah. Technical knowledge and the fundamentals that you've learned at school and you've applied. Some application and academic knowledge is important. Yeah, that's how it is. Okay.
So in my experience, I would say it's quite difficult to actually move, but I would say it's not impossible. So that all depends on your prior experience for sure. But I guess there are organizations which don't care about your prior experience in the data science. They might, if you are from the same domain, they might actually give you some advantage because you already know the domain knowledge. and with some required courses and maybe some knowledge, you can actually enter the field. But I would say, like, let's say generally it is difficult. If you are able to crack it, you should be proud of yourself.
Where can I get internship programs to continue the career as a beginner? Okay. I think internships get posted on portals. Like I think LinkedIn also will have internships on data science. I think on portals, you should be able to get these internships. I would say that's how it is.
Again, the similar question, how to get an internship. So I would say, like, keep looking for different companies, maybe through different portals, even through LinkedIn or like, let's say, Internshallah, where people are posting all these internships, and just keep in touch with your alumni to actually crack all this. So sometimes these are difficult, to be frank, but yeah, I have seen people approaching a lot of data science managers or data scientists through LinkedIn and then asking, like, is there a chance of doing a 2-month internship in your organization? So it's a lot of hard work if you are not getting it through college directly, but it's not impossible. People are following these approaches, what I have seen till now.
Yeah, and I would just tell you that how the market right now is. So there is no central course for data science which says, okay, you are bachelor's in data science or your master's. I think masters are there. Don't feel shy about saying that, hey, you are a mechanical engineer and you learn data science. I think that is perfectly okay. All of us know that there is no single course of data science and nobody is going to come with a bachelor's of data science degree and would know everything in this. That's not possible. That's not happening right now. That is very clear. So the only thing that you can show is your interest, is how you have done in the past, recently, what you've learned, how you've applied, how you're getting your hands dirty. So if you show that in your CV, I think people will have a look for sure. Okay.
Already plenty. So it's not any good sources. I guess you would have to spend some time to just filter out the sources which you get on the internet. There are already too many courses on, like, let's say, Coursera, EDX, Udacity, even like, let's say, now there are a lot of institutes. So I would say just filter out your list. Maybe start with one course, finish it end to end. Maybe you can start a book, finish it end to end. My recommendation would be, whatever you start, just finish end to end so that you finish something and you get that knowledge. Otherwise, I guess just do a simple Google search, as Neil said. After that, you will start getting similar recommendations from Google.
Yeah, I think a lot of courses out there which are good as well. And I can't really point one because there are several. So if you go to Coursera, if you go to edX and all these platforms, and other platforms as well, I'm pretty sure there are decent courses which can. And I would say start with the course which is focusing on data science rather than starting with, let's say, some mathematics or statistics. I think because when you start with a data science course, it will kind of scope out mathematics and statistics what is needed. Otherwise, you might get yourself distracted with things that maybe are not required. So I think nowadays plethora of courses, you just have to, as Manish said, start one and finish one, and that is where you start. Okay. How to switch from a software developer to data scientist? Manish, were you a software developer before?
Yeah, so I was a software developer, but then I did my master's, and during master's I took, like, let's say, machine learning. Yeah, this is one way, but the other way is through the industry itself. So
Okay.
I would recommend, when you are working in a company as a software developer, just identify whether there are some data science related challenges already in the company. And so I would assume, like, if you want to switch from software developer to data scientist, you are already building the required knowledge yourself. Like, you are doing the courses, you are doing projects yourself, like, let's say 2-3 projects of, like, let's say, machine learning, classification, or regression. So you know what type of problems you can solve in that particular company. So what I would suggest is, it's comparatively easier if you switch within the company from software developer to data scientist with the knowledge, because company would give you some priority. You already know the things about the company, and you are just changing the role. It is comparatively little difficult, but it's not impossible. Again, depends on your portfolio. What projects have you done? So though, if you are actually, like, let's say, hands-on with a real world problem, the company would see it as a advantage that you know how to build good software, and now you know how to build good data science projects as well. So that should be the approach.
Yeah. How will you judge a potential candidate in a data science? I think we just mentioned it, but I think I will repeat. So I think good understanding and curiosity of playing around with data. So that is one basic thing that is required. And because it has to be done through a coding exercise or something, so hence a decent understanding of how to write code as well for data science and not for web development. Like, let me be very clear on that. So I think intermediate level of data science and structure should be enough as well. But as I said, all of that has to fit into the overall scheme of whether you understand or whether you can do data wrangling, playing around with data, identifying patterns, doing visualizations, plotting charts. All of that is very important before you can do core data science, I would say, like building a model or something. So from that perspective, that is the first thing that is required. That is for sure. And then the second definite thing is data science fundamentals. That, okay, now you understand data. Now, how do you use this data to build a model? And how do you look at that model in a long term? Are you looking at risks, etc., and all of that? So that's, I would say, two basic skills I generally look for.
Okay, we'll take this question. Is intermediate level of data structure? Yeah, I would say, yeah, intermediate level is good enough for DS, because there would be use cases where whatever you have built, whatever model you have built, you would have to productionize it. So it's quite necessary, like you understand a different structure algorithm, though I would not recommend like going into the depth till, like, let's say a software developer goes. But yeah, it should be there.
I think there is a question on Azure and AWS. Azure and AWS are cloud, like we all know. Are they essential to do data science? Answer is no. Is it good to know them? Answer is yes, because eventually your data will reside in these systems, right? And they also provide tools to do data science. So maybe you sometimes might use those tools. So one thing is that, so your data resides there. So your input for any data science project is there. Sometimes your output also resides there. So sometimes you also deploy your models in Azure and AWS by using their standard tools. So it's not bad to know them actually, right? And sometimes, companies prefer people who already have an understanding of Azure or AWS because they are working in that, or they're using that cloud. So you might get some preference. But again, is it a must have? No. The must have is ML data science fundamentals. That is the must have.
All right. Thank you so much, Manish and Neil, for taking time.
Thanks. It was fun. Thank you.
Yeah, thanks.
Bye-bye.
Hey everyone, we have Bhaval with us. Bhaval is moving to London to join Facebook London. During this conversation, what we would be getting to know more about, we'll be getting to know more about Bhaval, of course. And then in addition to that, we would also talk about his journey to Facebook London as a machine learning engineer. Machine learning, do we call them machine learning scientists or machine learning engineers?
So I think the technical term would be machine learning engineer, or the official term for that Facebook uses is software engineer for ML. So that's what they call it. But honestly, there's just a lot of variants now in the industry. There's data science engineer, there's machine learning engineer, there's AI engineer, there's software engineer for ML. All of them kind of mean the same thing. There's data scientist, there's research scientist, right? So in my previous company, I was called research scientist, and I'm going to be doing the same sort of work.
Right. I think the only title that is scientist is kept for data scientist, which makes it a bit cool,
Yeah. So I think outside, although some startups are using scientist terms to hire anybody who does ML, usually these FANG companies or any big company giants, they reserve the scientist terms only for those who have a PhD. So I've not done my PhD, so I can't apply for a scientist position. Even if the work is same, it's gonna be reserved for those who have a PhD under them. Yeah,
I'm familiar with this particular terminology for Volvo, because I think Volvo follows the exact same thing.
Yeah.
Even if you have done your masters, you can only be a data analyst or a software engineer. But the scientist term is only reserved when you have a PhD in the topic. Pretty interesting. But you have also been a data scientist, right? How different is it? Is it significantly different? Is it exactly the same?
No, it's kind of the same. So it kind of depends. Honestly, company to company, it differs. Even now, although things have changed and streamlined quite a bit since like I started with my ML career, but even now, I think it depends a lot from company to company. So you could be given a title of research scientist, but then a work might involve mostly data analyst. So that can still happen. And the other way around could also be true, right? You could be called a software engineer. Forget about having any ML thing in your position, but then you might be working on some cool ML stuff. So it comes down to company. I think job description is where you get to know about what you're gonna be dealing with.
Amazing. And we'll talk all about that. But first of all, I would want to know more about Bhaval, who you are, where do you come from? So where are you from, Bhaval? Where are you staying right now?
Yeah, so I'm in Delhi. I'm from Delhi only. Delhi is my hometown. I've been brought up here only. And then I moved to Goa. I studied there. I studied in BITS Pilani Goa campus for 5 years. I did my computer science bachelor's there and master's in mathematics.
Why Goa? Why not BITS Pilani, the main campus?
No, I was just better. Also, I did not score high enough, honestly.
So, with Pilani, computer science, was that your first interaction with computers, or have you been coding for long?
No. So my first interaction with computers would have been back in 6th or 7th standard. But that was not coding. I think I started coding in 9th standard. Again, just like Mohit, I think I was introduced to HTML and these sort of things, web designing sort of thing. But from 6th standard itself, I did a lot of graphic designing. So I worked with a lot of Photoshop during that time, and I designed a bunch of things for some websites back then. Then it went on to front end. In the college, I did some front end work, some designing work, just kind of carrying on to whatever I had learned during school time. But my proper coding experience started in 11th standard when C++ was taught in my school. That's where I was fascinated. Honestly, I was very fascinated by a simple for loop, what it could do and what all we could accomplish by writing a simple program, right? And that fascination has been there for each and every sort of subfield in computer science. So it was always a known for me that I'm going to take computer science up. So I was sure from then on that if I'm going into a college, it doesn't matter which college it is, but I want to make sure it's computer science. And then, it kept on going. I tried almost every sort of thing, right? So graphic designing front end, I've done a lot of back end work as well during college, after college. But I was introduced to machine learning in my second year in the summer vacations. I tried to do this course that was becoming very popular by Andrew and Coursera, original OG machine learning course. Went through that. I was again completely fascinated by what machine learning can do and what it is basically. Right. And then that caught my eye. I tried to take up every single course that my university offered related to machine learning. I remember continuously knocking on the door of professors that I want to do some project with them. I even stayed back the next following summers in the campus alone just to work with a professor on a research problem. So that was where the entire machine learning journey started for me. I worked on support vector machines, which are not so popular nowadays. It's a machine learning algorithm, one type of algorithm. And some papers came out of that, but that's where my journey started, and it's just been going on from then on. But yeah, after that, after college, I went into DirectEye. There I joined as a software developer. So initially I was just working on backend stuff. Slowly I transitioned into some machine learning projects, and then since then it's just been machine learning.
Amazing. So Facebook London, right? I mean, before Facebook London, you were working at Zapper.
Yeah.
What does Zapper do?
So Zapper is a company in a media advertising space. Their primary source of revenue is through advertising. They help advertising agencies and advertising partners to kind of build a strategy as to for offline advertising where they should be advertising, right? Which channels would give them the best yield of reaching out to the target audience while still being able to optimize their cost, right? So that's their primary source of revenue. It works. The entire backbone is a lot of data, right? So they have some patented signal processing tech through which they're able to identify who is watching which TV program at a given time. Now, this is obviously integrated into some applications and platforms, and it happens via a consent form. But whoever signs up, we can obviously through this way, in an anonymized manner, get an idea of who is watching what sort of a serial or what sort of a TV show or what sort of a movie. And that sort of a data is quite helpful in then identifying which sort of an audience a particular advertising agency should cater to and which channel are they usually on a given time and date, right? So that's where the backbone is built up. Recently, Zapper has been trying a lot of new things in voice domain. So voice and speech domain. So they're working on some new speech tech and it's all in-house, the speech recognition to the chatbot building process. And we're trying to work on voice bot related technologies wherein we try to work with certain clients and try to solve their problems of, automating part of their customer center calls. At least the more common use cases. So these are some of the things that Zapper is working on right now. And there are a few other projects that Zapper worked upon that when I was in Zapper. Now it's been a month. I miss Zapper quite a lot. It was an amazing place to work actually. Yeah. And it gave me the opportunity to actually own up a lot of modules and work on all the cool machine learning stuff.
Right. This actually brings me to a very interesting learning that I got just a couple of days back. Right? Machine learning in itself does not have implications only towards fan companies. It has implications all around. For example, just a couple of days back, I'm a big time automotive fan. I think most guys are. So I was looking at this particular brand that is based out of Europe, and their entire car is designed by machine learning. So not a single person is involved, and they have brought down cost by 95%, 99%, sorry. So the cost to develop a hypercar usually is 500 million. Just because a machine is doing it and no human is involved, the cost to develop that car was just 5 million. And I think the implications of machine learning is very, very wide. It's across the industries, and I think that is one of the biggest places for people to experiment, learn, and try. So among all of these opportunities, what made you choose Facebook? Because Facebook has been doing the same thing for a very long time, at least to the outside world.
No, yeah, that's true. So Facebook was always one of the dream places to be. They do work on certain very challenging problems. Like some of the problems that I'm particularly interested in, for example, is fake news detection, for example, right? That's a very crucial problem that we are all facing, especially if we have looked at our parents' WhatsApp group. I think we've all seen these problems, from like preserving integrity while still maintaining freedom over a social network, right? These are some of the things. Facebook seemed like one such place where, get to work on these. I was even happier when I got to know that these teams are specifically placed in London itself. There are a bunch of other teams as well in London, but this was something that attracted me quite a lot. Although it was not a outbound scenario, I was reached out by a HR from Facebook, and that's where it all started. Like that got me for the thought flowing that, hey, maybe this would be a great idea and let's try it out. And then this entire thought process began, and I gave it all my time that was required.
How was that preparation? I mean, for example, let's say when the HR reached out to you, did you immediately interview or did you take some time off for preparing first?
No, I took a lot of time. So I think this is where my journey would differ from quite a lot of folk. My entire interview process lasted over 6 months, and that would be a surprise to almost everyone, I guess. The reason being, even though this is a machine learning role, Facebook as such, even though it's a tech giant, right, it tries to work in very small teams, like small startups of their own. Okay. So they still try to retain that sort of a culture within them, that you should be bold, you should try to move fast, and you should try to own as much as you can and build things completely, right? So it kind of gives you that all the positives of having a tech giant, as well as all the kind of ownership and freedom that you need in a startup, right? Now with Facebook, what was happening is, even though it's a machine learning role, it's very unlike all the other companies that will take machine learning rounds. So usually other companies will end up asking you, taking 2 or 3 technical rounds, all of them will be machine learning based. So if you've been working in the ML space, you need a few revisions and you can kind of crack them. Okay. And you can crack most of those rounds if you've been working in machine learning or if you've studied well in Facebook, it was not that way. So in Facebook, it was primarily a software engineering interview with a 1 ML round in between. So what that meant was that I had to kind of relearn everything that I had learned back in college time.
Go back to the basics.
All the basics, right? Data structure algorithm, I had completely forgotten about all of that. So it was a lot of relearning. It was also a lot of new learnings, right? System design is something that I got to work on here or there during my first job, a little bit in Zapper as well. But again, I had not worked at the scale of Facebook. Like I had never built a system which would scale for, say, 10 million users or 100 million users, right? I got to work on that in Zapper at a particular time where I got to think about that. But usually software engineers would get to do that more often than a person who's working in the ML. So that was something that had not occurred so many times that it had become natural to me. So these were things that I had to learn. So I took my own comfortable time. One lesson that I would want everyone to take from here is that I personally used to feel very anxious that, hey, I should probably not ask for more than like 2 weeks of time or 3 weeks of time from the HR. But it's completely fine. Through my preparation, one day I was reading some blog where a particular guy, some lead engineer, had basically broken down how much it costs to a company to hire a person or reject a person, right? Any candidate that gets rejected, a company loses close to $5,000 on. That's a huge cost to a company, right? Yeah. So you would be more happy if you take your own time and prepare well and then appear for the interview, because they're going to lose more than you would actually. So that's what I can talk more in details as to what rounds were there and how much time I took for each of them.
Yeah, we'll come to that. We'll just come to that, Bhaval. I would want to maybe break down a bit of that last component that you shared. It is the economics of hiring, because, for example, we talk about how much do these companies pay and the kind of crazy pay scales they have. And in the end, it's these engineers who are interviewing you, right? So their hour has a cost. If they talk to 5 people, they would want to hire those 5 people, right? If they are unable to hire 4, those 5 hours that have gone in hiring that one person become a cost. So if any, I mean, I think what Bhaval also put together very well is take as much time as you need, because the companies also want you to do your best and hopefully come on board and work with them, right? No company is trying to reject you. We're all trying to do our best to make you extremely productive, extremely good, and work together. Can you, before we go to the interview pattern, can you give us a quick overview of your preparation plan? What was that 6 months preparation plan? Where all did you spend most of your time?
So my initial plan was just 2 months long. It was not supposed to go 6 months. But this is a common problem that I think software engineers deal with, that spillovers happen. So now my initial plan was that I need to do well in all of these rounds, right? There was primarily a coding round. There were a few coding rounds, which were data structures and algorithms. There was a system design round. There was an ML system design round, which is not the usual ML rounds that startups take. So it had to be completely new sort of learning as to how you need to structure your answers for any sort of question that appears in this. And again, there was behavioral, for which there isn't too much of prep needed, but I can talk about that later, right? So these were the 4 rounds. I was primarily focusing most of my time for the preparation on the first 3. Now for coding, I think my initial plan was that, okay, I was scared of coding, honestly. So I've not been that guy who used to always do well in data structure algorithms. I've been a good problem solver. If you give me a good problem, software to build, an application to build, I'll happily do that. Okay. It's not like I'll write very bad code or anything like that. But somehow just this idea, if we go 1 year before this and if we were having this conversation, I would not feel very excited about solving a DSA problem. And the reason for that was simple, that it was more like a puzzle and I did not see it impacting anybody out there other than me. Of course, it could impact me, but there was no social impact too. And that somehow used to keep me away from it unless there's a need. But here there was a need. So at this point, I tried to prepare a plan. There was a book named Cracking the Coding Interview. So that was my first part, that I need to go through that book completely. Then I started going through one of these platforms. So I chose LeetCode and I went through, I solved about 150 questions before I interviewed for my first round. And yeah, that was my main plan for coding, that after that it'll be LeetCode. I can talk a little more in detail, but let me cover the breadth first. Then for system design, again, since I was more new to this, with only, few technology stacks that I've used here or there at various places, I started from the basics. Again, there's a course on Educative, Broking the System Design Interview. So that was the starting point for me. I also read a bit of, there's this excellent book. If somebody has the time and bandwidth, I would highly recommend reading Designing Data Intensive Applications, Martin Kleppman. So again, a highly recommended book. If you got the time, it will build your thinking about scalability and about building these data intensive systems which are having millions or billions of users, right? And then those were the 2 primers, right? After that, a lot of knowledge I received from YouTube itself. So there's this guy, Hussein Nasser, on YouTube. He has a channel on backend engineering. He has a lot of videos, I think hundreds of videos on backend engineering. And he has covered almost all kinds of technologies and, the comparisons. So a lot of insightful content you will get from there, that, okay, if you get to know that there are message queues, such as you can use Kafka, you can use Redis as a message queue, you can use, I'm forgetting the third one. But if you have 3 different message queues, now as a newbie, you might not know which one's the better choice at which time. There were some insightful videos on this guy's channel where you'll get to know these kind of stuff. So Hussein Nasser was one. There are a lot of playlists on system design as well on YouTube. If you just search system design playlist, you'll get through a lot of them. I remember Code Karle is one channel. Gaurav Sen is one channel. There were a couple of more channels, I guess. All of them are good. If you're somebody new, what you want to get to know initially is a lot of breadth, right? But one very important point is that there needs to be feedback loops when you're learning. So you cannot learn in this way where you go through a video and then try to understand what they said. I used to look at the problem that they're solving, pause the video, make the solution, and then go through the video. There have been a lot of times where I designed a very terrible solution. I've spoken to my close friends on a telephone saying, dude, I'm going to fail this system design interview and I'm not going to do well at all because I just suck at it. But it improves, right? With every single video, every single try that you do, you will improve and you will see that improvement. And either you're doing mock interviews or you're doing this sort of a feedback loop mechanism, it will help you know that as time processes, as you've gone through, say 20 to 30 problems, you will see a definite improvement compared to the design that you'd built on your first few problems.
Have you had a chance to look at interview bit system design questions?
I haven't. I do recommend interview bit. Somehow I just didn't go to that website, but I love that website. I had checked it out few years back. I've not checked out recently yet.
Question, why I brought it up is because the format in which we give system design question is very much the same. You have the question and then when you click on next, it would ask you to now you think about it. And then when you have given it a time, then you click on next and then it will say, okay, did you think about what was your approach? And this is what we recommend. So it is sort of developed in the same fashion. So that's why I brought it up here.
Oh, that's awesome. That's awesome. It should be that way. So that was a lesson as well. Another lesson was that with system design or ML system design, both of them are open-ended questions, right? So your solution may not be the optimal solution, but it can still be the right solution, and it can get you to be hired still. So the thing is that one aspect for system design is that you need to become okay with uncertainty. Like when you are going for an interview, most likely in these fan companies, you're going to come up with a problem that you've never heard before with these open-ended problems. So you're not going to see the kind of problems that are mentioned online on these platforms. Most likely you will not. For system design, ML system design, it will be something new. Now, when you come across something new, you need to be prepared and you should have gone through enough of such problems that you're okay with any new problem. And that's another thing that I learned which makes mock interviews very, very crucial for system design, I think. Because you are experiencing that exact same nervousness, anxiety, whatever goes on in an interview. And you have to experience it so many times that you become okay. Now throw me a problem and I'll try to take a stab at it, right? It should not be that, oh shit, I've not seen this problem at all. I don't know which pattern it belongs to and what should I do with it. You have to get from there to this other place where you get a problem and you're in that mode that, okay, I'll take a stab at it and this is what I'm thinking about.
I have a question at this point. So for example, let's say system design, is it specific to the level at which you were interviewing or is that asked across all levels?
That's a very good question. So I think Facebook has levels in their hierarchies for software engineers. So from I'm not sure of their E3 levels and below, but E4 and onwards, which is categorized from senior engineers to tech lead to so on, managerial positions. I think system design stays as a constant round of interview. Some positions will even face 2 system design interviews. So that also happens.
Okay. And I had another question on the previous pointer that you mentioned that you were preparing on lead code. Now, one of the challenges that I've heard from people who prepare on lead code or any open-ended platform is that you can solve a lot of problems and then you can still not cover everything, right? So what was your approach to make sure that you have some self-discipline to make sure that you cover a bit of everything and not just stick to something that you like? Because that's what people end up doing, you know?
There are a few things that I want to talk about there. One, the lead code part. Second, the self-discipline part, right? So let me go at lead code first. My lead code started after I was done with cracking the coding interview book in its entirety. So which meant that I have gone through each chapter, each sort of type of data structure and algorithm sort of problems on their own, right? So initially when you're just starting new, it's good that you take up a sort of problem like arrays problems or strings problem. And then you try to solve only a bunch of questions related to that sort of topic, right? But once I was done with the book, and I tried to code all the exercises also that were mentioned in the book for every chapter, as many as I could. Once I was done with all of that, that's when I moved to lead code, right? And that's where I moved to a completely random solving because it will be random at the end, right? So you will not know what sort of question you're going to get. And it's pretty important that you become okay with a new question appearing from a completely different topic. So that's where I started with lead code. Another thing that I tried on lead code was I used some extension to hide the difficulty level altogether. So when I'm solving a lead code problem, I open the problem And my mind is not biased by seeing if it's an easy, medium or hard problem, right? Because you will not know these things when you're actually appearing in the interview, right? So that was
Right.
another thing that I tried to do. And I used to make me very happy when I used to, solve a hard question in like 20 minutes or 15 minutes. Yeah, then realize it's a hard problem. So there are some extensions like that. If you just search for lead code in Chrome extension, I think you'll get through one of those. But yeah, I did that. Initially, I was trying to do, there are some 100 top interview questions. I was trying to take a stab at that, but later I just purchased the premium account from LeetCode, and there were questions there which have seemed to appear on previous Facebook rounds. They were tagged with Facebook, so I tried to make it more focused because I was only targeting Facebook at the time. That also helps, I think, because one thing that I realized quite later on was Facebook. I'm not too sure again on this, but it just seemed that Facebook was not asking a lot of dynamic programming related questions as much as say some other companies do. So just doing slightly more focused way of solving DSA problems will help in such manner, right? If a company is focused towards a certain kinds of question and not towards certain kinds of question.
Got it. Yeah. One last question that I have been waiting to ask. So machine learning is definitely a buzzword, right?
Yeah.
I mean, it is very safe to say that it is one of the top buzzwords in the tech industry, right? Everybody who talks about any new product, oh, we have applied machine learning, oh, we have AI. When is it okay to chase after machine learning, and when is it not okay to think about a career in machine learning?
All right. So honestly, I will be my opinion might be a little biased, right? Because I believe machine learning will be like, I am sticking to this because I am fascinated by all the aspects of what all it can enable us to do in future, right? I believe that it will get us in a couple of decades. It will be one of the primary factors which gets us to a future place where we are right now will seem very archaic, right? So maybe children or children of ours will feel that you lived in some very old age time. That's where I think it can get us, right? And that's why I think it's going to become an important aspect of software engineering in any way, right? Regardless of whether you chase after it or not. Now I can talk a little bit about where the industry is right now and what you get to do if you are getting into machine learning and what you don't get to do and what kind of myths are there, and how I can try busting a few of those, right? So now, as a machine learning engineer or research scientist or data scientist, you should understand that the good part is that you're going to mostly work on some cool problem. The reason is that a business is going to take up a problem with machine learning only when they are kind of sure that it can't be solved via plain old engineering. If they are doing the other way around, I don't agree that's a great way to do it actually right now. And this is not just me. Even Google says so, that when you're starting with a product, start with engineering. So engineering will get you 50% to where machine learning can get you with some very basic rules, right? Inherently, you will get to work with very cool problems, which will make you think that, hey, this is something complex, but this is something that can be achieved only by machine learning at this point. And that inherently has a cool factor of its own, right? But in reality, any problem with machine learning is built on data. So it's not built on you using your own logic, writing out the rules, right? Usually with a problem, like for example, any DSA problem, you are thinking about the logic, right? You're not writing a program which will write the code for the DSA problem. With machine learning, what you're doing is you're relying upon data. There are a few algorithms. There can be few tweaking around these algorithms, but there are a bunch of algorithms that work. And what you have to work on is building and having good data with, so that these algorithms can do the job and solve your problem. So out of work for a data scientist or a machine learning engineer is about building this data properly, right? So any new problem you get, maybe 5% of your work will go into initial research of what people have done or how people have tackled this problem. After which you will be spending 50-55% of your work just building the data correctly. And by building the data, I mean getting the data, whether it's by scraping, whether it's by writing on your own or hiring agencies to do it for you, and then pre-processing the hell out of it, right? So you will write a bunch of scripts to kind of get it in the form so that these algorithms can learn properly from.
Right.
And then there's the cool part, which everyone thinks is cool and which every course also teaches you online, right? Most of the courses, when they're teaching machine learning, are going to talk about these algorithms, that what are these algorithms and how they can learn to do something, right? It is the core aspect, but in your job, it's going to take up only 10 to 20% of your time. Here's where you get to tweak around these algorithms, try to see which algorithm works, which doesn't work, which one will scale, which won't scale, and just try a bunch of them and it's an iterative process. So if again you're the kind of person who doesn't like iterations, machine learning might not be the place for you, because machine learning, and why jobs are called scientists, is because it's based on science and not engineering. So there's this science aspect to it, that you try out something and it may not work at all, and then you're going to try again with something else. And there is that aspect which, yeah, you don't usually get in engineering, right? I'm not saying that either of them is less beautiful. I like both of them honestly quite a lot. But
this is very closely reminding me of humans. Like, how we talk about humans, that you only see the success and the fancy part. You do not see the failure and the years of hard work. So when you think about machine learning, it's exactly the same. There's a lot of hard work, training your machines and all of that. And people only look at the fancy part. Oh, you just did it and machine did everything. I think that's what it makes it very, very, very interesting. Awesome.
Right.
Okay.
Right. The last part of what you will be doing in your machine learning job is communication. So exactly this part, right? A lot of people in the industry still see machine learning as a fancy tech that you can try to apply and then it will do the job for you.
Right.
It's not that way. It's a very iterative work. And because of that, you need to be good at communication, specifically how are you promising things? Because an engineering pipeline, you can design the architecture once and then kind of plan ahead of time how many months or how many weeks or how many days it's going to take, because all of the tech is done and this is all deterministic. With machine learning, it's not deterministic. So you have an idea that, okay, if I prepare data like this and I use this algorithm, it should mostly work. And it may not work after 1 month, right? And then you have to inform your stakeholders that, hey, this did not work, but this is other algorithm which will work, because by then you've gotten to learn about it. So there's this iterative aspect for which your communication needs to change. And I think a lot of stakeholders also learn while they're working with machine learning that about its iterative nature. So a good part of being a machine learning engineer or scientist is being able to communicate these things with the stakeholders properly.
Amazing. What's the difference between AI engineer and ML engineer?
Short answer, not so much. And I would say look into the JD. There are a lot of different terms that are being used to describe an ML engineer. Job description or talking to the HR will tell you exactly what the job will entail.
Is it safe to say that a lot of times these titles are used interchangeably?
Yes. It completely depends on which term looks fancy to a particular company, I feel.
If it's a startup that's trying to attract a lot of people, it might just say AI engineer.
Yeah, it could even say scientist of some sort.
Can you explain any DSA problems, any DSA topics that are not needed in data science at all?
Not needed. So here's the thing, right? If you're appearing for most of the companies, right, I'm pretty sure that these tech giants will take data structures and algorithm rounds if you're appearing for an ML role, even if you have a PhD. But other than that, most of the companies will not. Or even if they do, they will have a very simple round. So because most of your work is not going to be centered around the kind of things that an back-end engineer or a front-end engineer would be doing. So the work in itself is quite different, right? There is some aspect of coding involved. Of course, you need to be a good coder, but then DSA is something on which not a lot of people test you, right? Most startups will not. Some will, but even they will be usually simple problems. So as long as you have some basic knowledge, you've done some top 50, 75 most asked questions in DSA, you'll be sorted out.
But is it like if somebody has a very strong base in DSA, I think it doesn't hurt. It's always good.
No, it doesn't hurt at all. It helps only, right? Because I think one thing that I learned by solving a DSA is it does train your mind quite a lot. Thinking
intuition building.
Yeah, intuition building.
How many rounds did you have? How many were machine learning and how many were DSA and how many were design?
So there will be total 6 rounds that you will have usually. One would be screening round initially, tech screening, which will be a DSA round. And this is an elimination round. So if you do well, you proceed to on-site rounds. If you don't, you're out. On-site, once you've proceeded to on-site, you will have all the rounds. There'll be 5 rounds there. There'll be 2 coding rounds again, which are again same DSA sort of round. Could be slightly harder problems. Then 1 system design round. General system design, any backend engineer usually is asked. 1 ML system design round, which I just realized that we have not covered too much upon. That if we get some time, I can cover a little bit of ground on that. And 1 behavioral round. So that's the rounds that you will have. I did have 2 extra rounds because for one of the rounds, it did not go that well, but my communication was very well and my method of approaching the problem was interesting to them. So they thought a stab at it. And that's what happened with me. I did not do well in actually a couple of rounds and then but they still felt that I was approaching it in a nice way. So sometimes that helps.
I think that again goes to prove that the companies are not trying to reject you. The companies are
Yeah,
actually hoping
not at all.
that
Yeah.
you make it through.
Yeah.
Awesome. What do you think got you the call?
Got me the caller. That's an interesting story. I'll try to shorten it. So I regularly try to keep myself updated with machine learning as a field, right? There's a lot of interesting stuff happening every day. And I usually do this via some newsletters. Now, one of the times there was this GPT-3. I don't know how many people in the audience have heard of it. It was an algorithm that came out that did a lot of things at once without training it automatically. And it was done by OpenAI, the company headed by Elon Musk. So when it came out, before it got all the mainstream attention, I had basically just posted a simple post on LinkedIn about it, about my own thoughts about it. And somehow the next day I had received a message from the Facebook HR. Are you interested in this sort of an opportunity? So I'm not saying that it's completely a causation aspect there. It could just be two completely different things, right? But I do think that it could have been possible due to that. But yeah, that's when they reached out. I think the lesson there is that if you get to know about something, just share it on some social media. It might help you. You never know who's reading it.
Just put yourself out there. The more you share, the more you talk to people, the more eyeballs you have. We have somebody from college. He knows some basic machine learning. What should be his pathway?
I'd suggest try to do as many projects as you can. The real experience of working on a machine learning project will make you learn about aspects other than just the algorithm aspect. So a lot of courses and materials online will teach you about algorithms, but in your machine learning job, you're going to deal with data processing a lot. You're going to deal with which should be the metrics, how should you deploy it, what is A/B experimentation, A/B testing, a bunch of things, right? That come up only when you have a project with you. So I would suggest try to work on some projects. It could just be simple as Kaggle competitions. Kaggle is a website where there are usually machine learning competitions. So they will pose a problem and a data set and you just work on, right? Or it could be something that you just think of on your own, right? And then try a stab at it. Open source it, do not open source it, sell it, that's on you. But I would say as much as possible, get like practical experience. And if you want some resources on courses, if you still need to learn more, Fast.ai is the platform I recommend the most. Deeplearning.ai is another website that has a lot of good courses now. So these are two platforms that will give you a lot of content if you want to learn about different aspects of machine.
Awesome. If you look at the career growth, is there any pros and cons of ML versus software development?
Honestly, I do not believe it to be so. I think forget about software engineer, you pick up any position, right? Everyone's making an impact. And it may not just be Facebook anywhere, right? When a product is coming together, there is a lot of engineering, a lot of product management, a lot of designing, a lot of machine learning that's going into it, a lot of QA work, testing work is going into it, right? And each of them are equally important, I feel. I would suggest whatever technology excites you the most, try to follow that. Like listen what seems to be exciting. Or if you are at that place where you don't know what's exciting, just try out a bunch, right? Maybe in the course of next 6 months, pick something from machine learning, pick something from backend engineering, pick something from front end, right? Maybe pick up React here, pick up Kafka in backend, pick up trying to do some Kaggle competition on machine learning and try all of them and see which seems most exciting to you, right? And then go ahead with that.
Pretty amazing. What skills should a fresher have when they are approaching data science? Do data science jobs expect a lot from a fresher? Nowadays, I know software engineering expects a lot. Like even if you're a fresher in software engineering, you should have done a lot of work.
Yeah, so I think machine learning is always, I don't think that a lot is expected from freshers. So what's expected is that you are willing to learn. As a fresher, I think that's the most important aspect, right? If you really want to learn to do this well, right? The passion aspect or the willing to learn and solve problems, that aspect is the first most critical thing for me to hire somebody. The other things would be that, yeah, you need to show some sort of interest, right? In some way on your resume, that will help a lot. Nowadays, I think a lot of companies have opened up taking freshers for machine learning positions. When I was sitting in my campus placements, there used to be only one, maybe couple of companies that will come for this. Yeah. In 2015, most of the companies were not hiring for machine learning roles out of college. Now there are a lot of companies, so there is a good chance that you get through. just try to show a little bit of interest through projects or through the work you've done, through research papers, anything, right? If you've done some courses and some projects, I think that will show a good range of interest and that can get you through. They're going to ask you the same machine learning algorithm related stuff only. They're not going to expect things like ML system design, for example, from a fresh. So it's going to be mostly knowledge based and what algorithm would you use? Can you explain this algorithm? Can you explain something like decision tree, random forest? Why one is better? In this situation, what would you use? Things like that.
Right. I think projects are very, very critical, whether we talk about machine learning, whether we talk about software development. Projects show that you like to build things. You don't just like to the theory aspect of it.
Right.
How important is it to understand the maths behind the algorithms? And how deeply must we dig into the mathematical aspect? Do you love math?
I like maths. The aspects that are involved in machine learning, somehow those are my favorite aspects of math. I did do a master's in mathematics from Vitsvilani while studying there, besides computer science. So, but there are also some aspects of math that I do not like so much. Like there is an entire field on abstract mathematics. Wasn't my cup of tea, but probability, statistics, and algebra and calculus. These are the four things that will play a role somewhere in machine learning, right? And these are the things that you need to cover. Now, there are very good places to go now. You can try to check out StatQuest as a YouTube channel. StatQuest, and then there's 3 Blue, 1 Brown, right? So you can try to cover a lot of math ground behind algorithms and behind what goes into machine learning just through these two channels to start with. If it feels interesting, try to go deeper into it. I feel a lot of software engineering ML jobs nowadays do not require so much of you delving into the mathematics of it. However, the maths is always a bonus aspect. It will get you far. So if you like it, if you do not mind it, try to study it and understanding it in more depth.
I think knowing how something works always helps. You can that's how you go towards the other side where you create libraries for others to use.
Yeah.
Awesome. Okay. Can you maybe tell a bit about the importance of statistics in machine learning and performance of ML models?
I'm assuming this is regarding studying statistics to understand how models are working. For that aspect, there are essentially a lot of models work on probability and statistics. So you will come around with terms that are often found in statistics books or probability books, normal distribution, p-values, null hypothesis. These are some things that become common when you're working in an ML job. I would say at this point, there's enough material on the internet. If you do not want to do a deep dive of a statistics course on its own, you don't need to. You can study the aspects that appear in machine learning and they will be covered in one or the other platforms or courses or even some Medium articles itself.
What did you exactly mean by ML system design? How to prepare for case-based ML questions like A/B testing?
This is the aspect that makes FANG companies ML positions different than rest of the companies. ML system design is where you will be asked a problem statement just like system design that, hey, you will need to design, say something like Facebook feed or YouTube feed, right? The home screen. But now you have to talk about this problem from an ML perspective. Okay. So now what usually is expected in this problem is to cover the entire ground of all that is utilized in ML. So first you will need to understand the problem. Like if they are talking about Facebook feed, okay, then what am I trying to optimize? I would want more engagement, for example, right? I would want more people to stay on the feed, right? So this is more product level related discussion that you'll start with. You'll talk about the problem itself and what sort of metrics you will be following, right? Because any machine learning problem you're solving, you are going to be looking into some metrics to see if this is going well or it's not going well. So metrics becomes a part of it. You need to discuss metrics. Then you go on to discussing about the data. So what data will be available to you? So you have to think about, okay, if I'm designing a Facebook feed and my idea is that if a person logs in, I'm able to show relevant recommendation of posts, images, videos, etc. to the person. Then what data do I have available with me as a Facebook engineer that I can utilize for this? Okay. So you need to think about user profile data that will be available to you. Maybe data about what day it is, what time it is it a holiday, right? A bunch of things about what sort of data is available to you. What sort of groups is this person in? What sort of friends does he have? What sort of topics has he liked, right? This becomes your data. So you have to think about what would be the data part, right? So you're not given any data set. You have to come up with what would be the features that you will be using in your machine learning problem here. Okay. And you come up with that feature set. This is called the feature engineering part. So we covered problem statement, metrics, third is feature engineering. You try to then talk about, okay, if I have these features and this data and these metrics, what algorithm will I use? Okay. Now, when you're talking about the algorithm, it could be something simple as logistic regression. It could be like decision tree, random forest, XGBoost, neural networks, deep learning based, any sort of architecture. And you have to be able to justify the decision. Just like in system design problems, you have to kind of justify your architectural decisions. Here you have to justify which metrics you're choosing, why these features and why this algorithm, right? Will it scale for this problem? There are going to be 1 billion people using Facebook every day, these many calls happening to the feed. Will your algorithm be able to make enough predictions at runtime, right? So you talk about algorithm aspect, after which you talk a little bit about deployment aspect, right? So how are you going to deploy this? Is there going to be A/B testing used? What sort of debugging strategies would be there? What if something goes wrong? How will you debug it? Are your models interpretable in nature or not, right? So these are some sort of questions that you try to cover in the deployment aspect. That what if something goes wrong? How are you going to tackle it, right? So
Right.
when you're given a ML system design problem, you have to kind of cover ground on all of these topics, one by one, go through each of them and go into a little bit of depth of each of them. And if an interviewer wants you to, talk more about any particular topic, you need to talk more about that particular topic. But yeah, that's the idea. Time management becomes very crucial because each of these topics can easily take up half an hour if you want to. And it's on you, the onus is on you to kind of shortly cover a particular area and move it to another area and make sure that entire ground gets covered.
How important is data engineering for FANG if applying for machine learning or data science work?
Yeah, so I think data engineering is important because data engineering, I feel at this point, overlaps quite a lot with what you learn in system design. So when you're dealing with system design problems that would be asked as at FANG companies, they're going to ask you things which scale up to billions of users, and they are
Right.
usually going to ask you things which are running on their product. So maybe a feature on Facebook or on YouTube or something like that. So in that case, there is already a billion user platform. So there is a lot of data. So when you're data engineering, a lot of the lessons there overlap with the system design part, I feel. So I think it becomes pretty important.
Awesome. Great. Thank you so much for your time, Bhaval.
Hello everyone, my name is Tarun Malhotra. I am a lead software engineer at Intuibit. Before Intuibit, I was working at DirectEye. That's about me.
Cool. So my name is Pragya Agrawal and I'm also a senior software engineer over here at Intuibit. Today's topic is a very interesting topic since you all know that AI is the new thing. So today's topic is going to be, first of all, what is AI and what will be the impact of AI in our life? So will AI be taking away our jobs, or basically what kind of new jobs will AI create, and how do we prepare ourselves for the future? So yes, let's begin with Tarun. So Tarun, how do you define AI? What do you think AI is doing?
So first of all, guys, as Pragya said, all of us are worried about that, hey, what kinds of jobs will AI take away? But before that, what is AI? What is artificial intelligence?
Is what AI is. So if you look at it from the perspective of the science of AI, right, then AI, the ultimate goal of AI is to basically create something that can mimic a human mind, right? So we are trying to create an artificial brain. That is what artificial intelligence is all about, right? Now you can think of AI from a lot of different perspectives. So one of the perspectives that you can take AI from is basically AI research concerns itself with a lot of things. One of the things is what AI really is. What do we really mean by intelligence in the first place? Like, what are the capabilities of intelligence? How do we produce intelligence? Right? All these things are part of the AI research. And there are some philosophical considerations as well. So what is consciousness? What is free will? All those different. However, as you can understand, we are not here to talk about those philosophical parts of the AI. We are here to talk about the practical scenario. Basically, what can AI do for us? Right? What are the capabilities of AI and how will AI change the future as we see? So, leaving aside the theoretical definition of AI, what can AI do? Right? So, yes, sir. Could you tell us what AI from a practical perspective?
Yeah, so basically AI, artificial intelligence, trying, as the name suggests, that you are trying to generate intelligence which is artificial, which is not human. As of today, historically, we have been trying to look at intelligence from a human prism. We have intelligence, we are intelligent, we can look at data, figure out patterns, take some decisions based on those patterns, and trying to figure out that, hey, that is what we have always called intelligence. Now, AI is that you are trying to recreate that by using the computation power of your computers
and trying to figure out those patterns and predict outcomes based on that patterns, or in a way, structurally trying to mimic human intelligence and making machines capable of that level of intelligence, or maybe an intelligence which is beyond our human intelligence also. So that's what AI is for me.
So what we can do is we can draw analogies of AI with what kind of technical revolutions we have seen in the past. So one very interesting thing that we have seen in the past is the Industrial Revolution that began in the 1760s and so on. So yes, we did see a lot of new technologies come up in the Industrial Revolution. So perhaps could you talk about that, Tarun?
Okay, so first of all, guys, all of you would have heard about the term Industrial Revolution. Industrial Revolution essentially is the revolution which actually gave us these machines, these steamed power machines, and actually ended up in automating a lot of things that were done by hand before. But I will actually give you a much more deeper perspective here, and will try to actually tie that with this new revolution that is going on. And people actually call this the fourth industrial revolution. So actually, before coming to the fourth industrial revolution, let's try to imagine the history, our past, and see how all these industrial revolutions actually changed things drastically. So the first industrial revolution, as Pragya said, was in the 17th century or the 18th century, is the industrial revolution which actually gave us the steam-powered engines. And that is when, back in the day, the textile manufacturing was entirely by hand. And that first industrial revolution totally replaced that hand-woven clothes and gave us machines that are going to create our clothes. This had a massive impact and led to a much higher level. We actually went to a much more optimized world where things could have been done at a much larger scale, which you could not have imagined earlier. Then the second industrial revolution, which is also known as the technological revolution, happened when the world actually saw the invention of a telegraph. So people started building these great networks where people can talk to each other far off to each other. And then they also started building extensively the railroad network. That is, you can very easily transport yourself from one place to another, and also via telegraph, you can also communicate your ideas, that is, transfer your ideas to much larger geographical regions. Now, the second industrial revolution also changed the way we have been living, right? It actually drastically changed things. Early on, if you can't actually move very quickly to different parts of your country, what would really happen is that there are some centers of all the innovation, some centers of all the trade, and some centers of all the education also, and everything beyond the geographical reach was a place where not a lot of things happened. But with this industrial revolution, things changed a lot in that aspect. Now, the third industrial revolution, which is very closer to us, we know a lot more about that as of today. We actually appreciate that a lot better, is the digital revolution that happened. These computers, which actually started doing a lot of logical tasks for us and doing a lot of computation using these chips. This is the third industrial revolution. Now, this fourth industrial revolution is actually the AI revolution, where not only some computations can be done using machines, but you can also hope to deduce a lot of inferences using these machines. So basically giving machines the data and asking them to figure out more about that data, figure out patterns in that data, and then trying to also predict things. This is what the fourth industrial revolution is, and very similar in a lot of sense to the previous industrial revolutions, but also very different in some aspects. So Pragya, I would want you to add in your 2 bits on how is this revolution different, let's say, from the early 3 revolutions that I talked about. And then maybe we can also discuss about how this can also be seen very similar to the earlier revolutions.
So you have already drawn the analogies with the past. So basically, the AI revolution can simply be seen as a continuation of the previous industrial revolution, right? The previous 3 phases. However, there are still a lot of dissimilarities. Right? So we have to understand that earlier in the industrial revolution, what was being automated was the labor-intensive part. Right? We were automating power. We were automating mechanical things. Now, what the AI revolution will allow us to do is it will allow us to automate the process of thinking itself. Okay. And thinking, if you look at it from the perspective of the things that we can do, thinking is the center of the human being. Right? So everything that we do, everything that is logical that we do, everything that is creative that we do, the science that we do, and even the very human connection that we establish with each other, right? The kind of emotional bonds we form, all that stems from our capability to think. Now, because the AI revolution is going to automate this AI thinking, basically what we will be able to do is we will be able to put all these human traits of logic, science, even the human connection into a machine, right? And maybe perhaps we will be also able to make that machine much, much better, 10, 100, 1,000 times better than the humans, right, in achieving these things, right? So even though AI revolution is simply a continuation of industrial revolution, this might perhaps be one of the most significant bits of the industrial revolution, because the kind of impact, the kind of life changes in the society that AI revolution will bring will be very, very drastic.
Pragya, I would just want to add one thing here. Of course, this revolution may actually take us to a world where rate of change is going to be very, very high. We all appreciate that. But there is also, I would want to point another underlying similarity. So the rate of change today seems to be very, very high with this fourth industrial revolution. But if you try to imagine the kind of world that was before the earlier industrial revolutions also, you would realize that actually the world changed a lot with those revolutions also. But now when we look in hindsight, it seems that, hey, it was a small change, but that was a small change only because where we are today. But if you look at the perspective from that time of the world, then you will realize that maybe the changes then also were very, very huge. For example, just imagine that if there were no machines whatsoever, right? If there are no machine, the humans can actually hope to be most productive by doing laborious jobs. You actually farming yourself by hand. You producing goods yourself by hand. That seemed to be the most outcome-driven work that you can do back then. But with the machines, that changed. Our perspective changed. What we feel is important changed because there are a lot of things that can automatically be done. Similarly, today also, the things that are very important to us today, the jobs which are very well paid today may change drastically in the next few years, given that our machines are getting more and more intelligent, and a lot of things that seem to be very, very optimized usage of our time today may not be the same as we look a few years later. So that's very, very important to understand.
That's right. So basically talking more about this point, you said that most of the jobs that we thought were productive way back in the time before the Industrial Revolution, after the Industrial Revolution, we realized that those jobs are perhaps not the most productive use of our time. We can invest our time much better in some other job. So if you look at it from today's perspective, what kind of jobs do you think the AI revolution will take up? So the title of our video is that AI is guaranteed to take away some jobs, right? That is beyond question. AI will definitely take away some jobs. What kind of jobs will AI take up first? So yes, what do you think about that?
So the best way to look at this would be to look at the jobs that are already being taken away by AI, right? So the first thing that I would want to talk about is the warehouse jobs. So today we have the Amazons of the world delivering millions and billions of packages all throughout the globe. You would realize that we're housing those packages and then sorting those packages to make sure that you are delivering the right package to the right place. That involved, before this fourth industrial revolution, that involved a lot of manual labor. Today, if you look at the warehouses of these big organizations, you would see that 90% of the job is actually automated. There are humans, but most of them are just supervising, making sure that there are not some exceptions that happens and how do you handle those exceptions. And also then doing some interface job. That is, a lot of work is done by the machines, and you just act as an interface and get the things done, take them to completion. So of course, warehousing jobs are being replaced as we speak with artificial intelligence. The next kind of jobs that I would want to talk about is the jobs of, let's say, customer support. You calling somebody in a call center, trying to get your job done, asking them your doubts, telling them about, hey, why is this not working? How should I get this to work? This happened to be a very big employment opportunity for us. And this was a good use of your time because you are now assisting others to use a product that you have created. But now this is a job which is being disrupted by AI at a very, very big pace. You would see a lot of companies out there in the world today trying to build these chatbots, trying to automate the experience of users and automatically trying to figure out that, hey, what's the right resolution for this particular use case? So all of us are using Swiggy. All of us are using Zomato. Today, if you order something on Swiggy and you realize that, hey, the order is not as per my requirement, the first thing that you do is you actually go to a chatbot. You don't actually get connected to a human immediately. You go and talk to a chatbot, and only in some exception, you actually talk to a human, because most of your otherwise interactions can be handled by a machine itself. So yes, all the jobs, and if you try to understand the pattern behind these jobs, so I talked about 2 jobs right now, warehousing, I talked about, let's say, customer support. Let me also talk about one more job, because then the pattern will become much more evident. And Pragit, then maybe you can add your ideas on the same. The third job that I would want to talk about is the business of underwriting risk. So I will just talk a bit about what do I mean by underwriting risk. So whenever you buy an insurance policy, right, you go and you try to buy a life insurance policy, you try to buy a health insurance policy, the companies are trying to assess what kind of a risk profile do you belong to. And based on your risk profile, do you smoke, you don't smoke, how healthy is your liver right now, how healthy is your heart right now. Based on that, they will try to estimate how long are you going to live. And based on that, they will decide what kind of a premium they would want to charge you so that they can balance this risk. Now, this is a job which requires you looking into lots and lots of data, trying to make sense out of the data and trying to look at patterns in that data and then figure out that, hey, what kind of a risk profile this particular individual belongs to. Now, this is also a job which I am pretty sure will be automated massively in the next few years. Already we are seeing companies emerging in this space which are trying to automate all. Now, if you look at all these 3 things together and try to look at an underlying story, that what kinds of jobs are these, what is the underlying pattern amongst these jobs that AI is very easily being able to automate today, you will understand that all of these jobs are essentially you trying to make sense out of a bunch of data points, right? So you have rich data available. You earlier required a human person there to figure out this particular instance belongs to which part of my data landscape and how can I solve this issue based on how this was solved in the past, or what does the FAQ document tell me to solve this based on. Now, this is basically you looking at an instance, trying to do pattern recognition and then trying to answer how to do it. If you look at all 3 jobs, warehousing, that is how do you transport a packet from here to here? What is the best route here and how can you use machines to transport data within the same warehouse or let's say outside the warehouse as well. And similarly, if you look at underwriting risk jobs or you look at these customer support jobs, you will realize that you required a human to look at an instance and trying to figure out where does this instance belong to and then coming to a resolution. And now AI is very easily being able to remove these jobs and automate these jobs. So the idea being that if there are some repetitive jobs that we as human race is doing, those jobs can be the first jobs that can be automated.
Cool. So the repetition part that you spoke about in the last, that is perhaps the key point over here. So it is not about how skilled a job is. It is kind of a misconception amongst people that only the low skill jobs. I'm not really sure how do you define a low skill job. What is a high skill job? I mean, there's no job which is unnecessary. However, people still kind of believe that low skill jobs are the first jobs that are going to be automated, which is not. A job that is going to be automated, that is more likely to be automated, is a job that has a lot of repetition in it. For example, let's imagine 50 years before from now, if you wanted to send a postcard, if you wanted to send a mail to someone, then there had to be a human that had to read the description, that had to read the address on the postcard, and they had to basically route it to the correct person. That okay, this postcard must be filed in this particular cabinet because it is going in this direction. Now, thanks to AI, this is kind of a repetitive job, right? You read something and you put it in the right place. That job is very easily automatable. And if you see, almost all the postal mailings nowadays, almost all of these things are completely automated by technologies like OCR and basically handwriting recognition technology. Right? Other than that, there are several other jobs. For example, the job of a cashier or the job of an attendant. Right? What is the major job of a cashier? Person comes to you, you hear out what the problem of that person is. Right? Similarly, the job of a customer support executive is the same. A person comes to you, you hear out their problem and you direct them to the correct resolution. Now, this is a very repetitive job that can be automated. So, these are the kind of jobs that will be automated. Apart from that, in the job world, where people see that, okay, these kind of jobs, programming jobs, people believe are very high skill jobs. However, there's a lot of room for automation even in the programming jobs. For example, if you become a machine learning engineer, one of the first things you learn is things like what is linear regression. Right? And you try to learn things like that, okay, if I have a data set like this, then what sort of model should I choose to basically get a good result on this data set? Right? Now, that seems like a very high skill job, but in fact, it is not. And if you see, most of the companies like Google, like Amazon, they are working on auto machine learning techniques. Right? They are launching solutions in which you simply upload the data to their servers, and their AI will choose the best model for your data. The point I want to stress over here is that is this repetition, it is the lack of creativity in a job that makes a job more or less susceptible to automation. Okay. Now, there is one more thing in there which is important that we talk about. Even when we talk about artificial intelligence or lack of repetitive jobs, there's a lot of spectrum in these. Some jobs require only thinking. For example, routing a particular mail, that requires only thinking, reading something and making a decision. However, there are some jobs that require a lot of hands-on activity. For example, if you consider something like a surgeon or something like a hairdresser, the hairdresser is not really doing something very intelligent. However, the kind of skills that hairdresser requires, those skills need very fine motor control, right? Very good eye-hand coordination, very high dexterity, basically with respect to the hands of the hairdresser. Now, even though the AI revolution is taking at a very fast pace, the revolution that is with respect to mechatronics, right, robotics and controlling things, moving things around, right, that is still lagging behind a lot. So these things will still take, the hairdresser job will be automated eventually, but it will take much more time to automate those kind of jobs than jobs like programming. So as Andrew used to say, that I know how to automate a programming job, but I don't know how to take the job of my hairdresser.
That's a very, very interesting point that Pragya you raised. I would actually want to go back a bit on this point and actually hammer this point across, because this should be very, very interesting to our audience. Our audience is primarily programmers. And now what they have just heard is that probability of AI placing the job of a hairdresser is much lower than the probability of AI replacing a job of a software developer. This seems very interesting and maybe also a bit depressive also, that maybe you should maybe become a plumber or a hairdresser today if you want to have a job in the future. But now let's talk a bit more about that. When Pragya said that, hey, the programming jobs can be automated, of course they can be, but it's very important to understand how can you sail through this transition without you personally getting hit. Now, in a programming job, there are multiple aspects, right? The first part is that, hey, what most of us actually usually do is we build some APIs, we build some CRUD applications, right? Now, building a very simple API where you would want to pull out data from one side and then show it in a view somewhere else. So basically building these basic API is a job or a part of the job that you can also imagine is very repeatable in nature, right? You just need to repeat a few steps over and over again every single time. Now, this is a job which is perfect to be automated. AI can automate this very easily. But at the same time, there are some other parts of a software engineering job that will not be that easy to be automated. For example, a software engineer also needs to architect systems, right? You need to architect systems. You need to figure out that, hey, how will my system handle scale? What kind of a layer do I want to introduce? Do I want to cache some of this? Do I want to store this in what kind of a data store format? How do I want to retrieve it? And basically trying to build the architecture of a system. This part of the job is not very repeatable. You just can't look at system design of YouTube and say, I'm just going to copy that verbatim while building a new application. You will have to make tweaks. You will have to come up with new designs with each and every problem that you are solving. This is not going to be very easily replaced by intelligence. And when I say this, please bear in mind that we are talking about the next 10, 12 years. We are not talking about the next 200 years. In the long run, all of us are dead, right? So let's not talk about what happens 200 years from now or 100 years from now. But let's talk about what happens in the near foreseeable future. If you are a software developer and you want to make sure that your job is not going to be automated in the next 5 years, you should invest in upskilling yourself in the skills that are not very repeatable. So how do you design a system? And also, let me talk about one more aspect here. So a lot of us are product engineers, right? So we are the owners of a product, a small product, and we also code it. We also build it. Now, building it up will require, again, two kinds of things. One thing which is very, very repeatable, most likely that will get automated. But then there is the other part. That is what to build, how to build, why to build. Maybe talking to a bunch of hundreds of your customers, trying to figure out what exactly your product can help them solve. Now, this is a job which is not going to be automated by AI very soon. Of course, you have a technology, but how do you leverage that technology? What do you build using that technology? There is where human ingenuity, human intelligence is required, and you should ensure that you're upskilling yourself in these skills so that you don't become irrelevant in the next few years. That is very important.
Fair enough. So, I mean, I usually give this analogy in my classes a lot. There are basically two types of programmers. One of the programmer is a typist, right? Their primary job is to take some specification and to convert that into. The second type of programmer is a thinker, right? They take a problem and they figure out how to solve the problem. Now, what you have to do is you have to become the second kind of programmer, because the first kind of programmer is going to be automated in the next 5 to 10.
Absolutely. There is where upskilling becomes very, very important. Because if you look at the mix of software engineering jobs out there are millions of software engineers. But in reality, a lot of us are not doing the second aspect. A lot of us are just focusing on what Pragya called a typist job. That is just getting some things done, a very, very repeatable process. You know how to code this up. You just create a few APIs and get done with it. This is a typist kind of a role. And a lot of us are actually in this kind of a role. We need to transition from this and move up this skill ladder so that we are not just doing this repeatable job, but you are actually bringing something more to the table. You are not just typing a few lines of code, but you are ideating what to build, how to build, and that becomes very important. That is when you become least replaceable. And just to add one more point, guys, even if you forget about AI for a minute, if you want to become a software engineer who is very much cared for by your organization, or very much all the companies trying to hire you, the kind of software engineers that people would want to hire are the folks who are problem solvers. You can give them an abstract problem and they can solve that problem to you. So that is what you should ensure that you are defined by. You are a problem solver. You are not a coder. You are not here to just copy 5 lines from Stack Overflow, copy them, run them, solve a few bugs and get done with it. You essentially are a problem solver. If you make yourself a problem solver, you can be much more respected and wanted today. Also, you will be at a much better place to overcome this tide of AI and artificial intelligence replacing jobs. You can still remain relevant. So that's the basic point here.
Cool. So basically diving further into this, if you look at the kind of things that a software engineer is expected to know, right, the kind of subjects that a software engineer is expected to master. So subjects like learning about frameworks, learning different tech stacks like Python and Django, or Java and Spring Boot, or React and the Merge stack and things like that. There are other things that a software engineer is required to do, things like knowing data structures and algorithms, right? Knowing about system architecture. So Tarun, what do you think out of this spectrum of the kind of skills that a software engineer is required to do, what kind of skills are the most important? What kind of skills are the skills that people should invest learning in today so that tomorrow their jobs are more future-proof?
So there is a question: which new software engineering roles related to AI will be in demand in the future? So this question has two parts. First of all, what are the skills that we see today are very important? What are the evolving skills that may become very important as we move along? That is, how can AI bring in a lot more skills that you should master? And the other part is, what are the skills that are relevant today will become a lot more relevant in the future because of the advent of AI?
So basically, if you look at AI jobs are basically, you can dissect them into two major categories. Right? One of the jobs is kind of the research job, and the other job is kind of the implementation job. In the research kind of job, what you try to think is, you try to research the nature of artificial intelligence itself. You research different models, that okay, if this is the kind of data, then what kind of model performs best on that? Right? Coming up with things like neural networks, coming up with things like convolutional neural networks. Right, researching things like generative adversarial networks, all these things, they are part of the research of AI. On the other hand, we have the implementation aspect of AI. Right, the implementation aspect of AI deals with that, okay, I know that these models exist, but solving a real life problem is much more than simply talking about the theoretical perspective of it. Right, so I have to understand where I'm getting the data from, how do I clean that data, how do I make sure that the models that I'm applying, they actually are performing well in practice, and my customers are getting what they really want, right? There are two parts of, this AI field. Now, in both the parts, there are some jobs which can be automated, and there are some jobs which are more difficult to be automated. If you look at it from the research perspective, there's a lot of people that are coming out nowadays which are not doing any innovation. They are simply saying that, okay, we have this kind of problem. Nobody has applied this model on this problem, so let's apply this model on this problem. Let's see what the result is. Let's just publish that. That is something that is highly automated. So you can expect in the future that those kind of research activities, those kind of jobs will be reduced in the near future. The new jobs that will come up in AI will be the jobs that research new models, right? Okay, what sort of new idea can I come up with that is going to help improve my model. Right? So drawing analogies or drawing inspiration from the nature, just like we have convolution networks, drawing inspiration from the way our basically visual cortex works. Jobs like this will be more in demand. Similarly, if you talk about the practical aspect of artificial intelligence, the jobs that will be created in the near future will be jobs that will be looking at, given a particular problem, what sort of model or what sort of decisions should I take? The kind of problems that require you to architect the solution and not just code the solution. So you can expect that all these frameworks that you currently hear about, that okay, should I learn TensorFlow? Should I learn something like PyTorch? All those jobs are going to very quickly become irrelevant. The jobs that are going to remain relevant are the jobs that require you to understand the basic principles behind artificial intelligence. What is linear regression? What are neural networks? How do they actually work? The theoretical aspects, basically the understanding, the deep understanding of those things are going to be relevant in the future jobs. So I hope that answers the question. Is there something you would like to add to this, Sarun?
No, absolutely, Pragya. But I would just want to hammer across the points again. A couple of points here which I would just want to highlight, but you covered exhaustively here. Guys, as Pragya said, in research, so for example, AI, there are two aspects to AI, right? You would want to research new and new models, and then you would want to implement those existing models and tweak them to solve a real life problem. In both directions, you have some jobs that are very repeatable and can be automated very easily. For example, if you look at the folks who call themselves, let's say, data scientists, you look at and try to figure out that, hey, if you try searching LinkedIn and try to find out for jobs that are out there in the domain of machine learning, you would see a good proportion of them actually over-indexing on you knowing a particular framework. Hey, can you build a model using TensorFlow for me? Can you implement this for me? Those kinds of jobs are going to be very easily replaced, very easily automated. On the other hand, the other side of implementation, where you actually figure out how to tweak this existing solution to solve for a real life problem. This is an abstract model. How do I tweak this? How do I configure this? Maybe how do I use multiple models in conjunction to solve this problem? That is where the architecting part is going to remain relevant for a long time. If you want to become a machine learning engineer, you rather should focus on problem solving. That how do I use this to solve a problem, and not over indexing on a bunch of frameworks that, hey, I know this framework, I can code this up, I will read a research paper, I will just recreate that model here. That's all about my job. That is very easily replaced. At the same time, there is a wrong notion in folks that, hey, the research aspect of machine learning, the research aspect of AI, you can't automate that. But as Pragya rightly pointed out, there is a good chunk of human effort that actually goes in research where you just try to explore multiple configurations of the same model. You actually try running it through different configurations and then publish a paper that, hey, these are the results that I just got out of this configuration. Now, this is a very repeatable job. If you find yourself doing the same steps again and again and hoping for a new outcome that you can publish, these kinds of jobs can very easily be replaced. On the other hand, thinking from ground up, leveraging the basic fundamental mathematical machine learning principles and coming up with a new model altogether, coming up with a new way of looking up for patterns, that is something which requires human ingenuity. That is something which requires human intelligence, and you can't just replace that very easily. So irrespective wherever you are, in what segment, in what vertical you are currently, try to ensure that you move towards more intelligent aspects of job rather than the repeatable aspects of jobs, because knowing and being good at those repeatable stuff is only going to help you for a few years at most. It will not build a strong career for you for the next 20 years. I am very certain for that. That is what we should all keep in mind, that, hey, what are the skills that require intelligence and what are the things that just require repeatability? Move towards the skills that require intelligence.
So maybe what the viewer was trying to ask is, what is the future prospect of machine learning jobs? So one thing that I would also like to point out over here is that if you look at the global supply and demand of machine learning engineers, there's a huge shortage of machine learning engineers in the world right now. Right? I mean, if you look at places like Silicon Valley, if you look at places like Bangalore, the IT hub of the world, there's a huge demand of machine learning engineers, and the demand is so much that companies are struggling to meet that demand. They're struggling to hire good quality machine learning engineers and good quality software engineers that they actually want. So if you look at it from the perspective of the next 5 to 6 years, even though we are talking about AI automating a lot of jobs, AI taking away a lot of jobs, in the next 4 to 5 years, you will only see an exponential increase in the number of machine learning jobs that are available in the industry. investing in learning machine learning right now, that is still a very good endeavor. That is something that is going to secure your future for a long time. However, while you are upskilling yourself in machine learning, just keep in mind that don't upskill yourself only in the frameworks. Upskill yourself in the problem solving part as well.
Absolutely. And if you can, as Pragya rightly mentioned, as of today, there is a lot of demand even for people who just know a few frameworks, who can code things up. But what the right way to look at it would be that, hey, I can maybe use that opportunity to get a foot in the door. I can use that opportunity to get a relevant job, but then it becomes very, very important for you to upskill yourself in the right skills so that your job does not become irrelevant in the next 10 years. So absolutely, it's very important to make sure that you don't get us wrong. It is not as if learning TensorFlow today is of no use. It will help you a lot. It will get you several job opportunities because there is a big shortage for companies trying to figure out people who know those skills. But if you use that, just use that to get a foot in the door. But then it becomes very, very important to make sure that you keep on upskilling yourself. If you feel that, hey, I got a job because I knew this framework and this is what is going to help me throughout, maybe you are mistaken. And if you are in the AI domain, maybe you know it best that, hey, that we are mistaken here. Just knowing this framework should not be. Similarly, I would just again talk about software engineering because there are so many people here who are software engineers. Guys, today, there is a big dearth of software engineering talent, right? You talk to any startup founder, the single most important resource that they will talk about is that, hey, I have capital. There is, because of the Fed, US Fed, you have so much capital out there in the world. Capital is very cheap. But the thing which is most difficult to find right now is tech talent. And a lot of that aspect is just knowing coding. That, hey man, this person is good in Java. He can code. I can tell him what to build. He can just build that for me. That's great. But don't assume that that is going to stay as it is for the next 20 years. You can use that opportunity to get into the door, get into a good organization, start contributing, but make sure you don't stop there. Because if you stop there, then there is a very high probability that you will become irrelevant. But if you use that opportunity to then start tinkering with that, hey, how are products built? How is this architecture architected? Maybe I should upskill myself in understanding that, hey, what's the best architecture for this problem? Maybe I should contribute that, hey, you should change this caching layer. Maybe you should introduce a new kind of a caching here. Maybe that will help. Making sure that you move and do that transition is very important. And all of us should be cognizant of that.
True. And basically, there's one thing that I would like to mention over here. So you talked about upskilling, right? And this is going to be a very common thing. Upskilling is going to be the common theme of the future. So if you look at jobs today, people don't really invest a lot in upskilling themselves, in learning new technologies, in learning new skills. We're not just talking about software engineering jobs. We're talking about new skills in general. So you are going to notice that in the near future, learning new things, being able to quickly change your domain, basically quickly be able to switch from doing something to doing something else, picking up new skills very quickly, that is going to be a central theme. That is going to be a central skill that people will need to acquire in the near future.
Let me add one thing to what Pragya just said. Of course, the agility of learning new skills is very important. You need to upskill yourself, keep on learning new skills. Another thing that I would want to point out is being at the edges of two domains. For example, that, hey, you are a great software engineer, but you also understand human psychology very well. Just an example. Similarly, let's say you are a great software engineer or you are a machine learning engineer, but you also understand finance very well. Being at the conjunction of multiple skills, this is, in my opinion, going to be a very, very highly rewarding journey to take. For example, if you are very good in one skill, do try to look at that, hey, what are the ancillary skills, maybe in different industries that I can pick up, and then move to a very, very important position where I know one domain very well, but at the same time, I also know a few things about a different domain, and I can work at the very edges, the contours of those two domains and do something great. That is going to be very, very respected and very, very required in my opinion, guys. So, what are the prerequisites in order to learn machine learning? What are the things that you should first of all focus on?
So, machine learning, if you look at it from the academic perspective, machine learning is not a very difficult skill to pick up. If your aim is to go into the strict research part of machine learning, if you're saying that, okay, I want to perhaps do masters in machine learning, or I want to do PhD in machine learning, I want to basically end up in a research profile, you need very good skills at mathematics. Right? What kind of mathematics subjects I'm talking about? Subjects like linear algebra, right? Subjects like statistics and probability. Right? These are some things that you definitely need a lot of skill. I mean, a lot of people, I understand, they're kind of afraid of maths. They're kind of shy of maths. However, if you build these foundations in a solid manner, that will help you a lot in basically preparing for machine learning. Then, if you don't want to take a research kind of position, if you don't want to very skill in things like probability or linear algebra, then you can also look at machine learning and AI from the perspective of a framework of solutions, right? Just like Lego blocks. So basically, when you are building a structure out of Lego, you all have played with those Lego blocks, right? You have bricks. Those bricks have something poking out of them, and you can basically fix one block on another. So you can treat AI in a very similar manner. You can take common solutions that are applied to problems, and you can use those common solutions to tackle a bigger problem, right? You can figure out, okay, what solutions or what kind of structure, what kind of organization do I put these different solutions in to solve my bigger, larger problem. So if you look at it from the academic perspective, you can take either of those channels. You can either become very good at things like linear algebra, mathematics, statistics and probability, and then start learning about the basics of machine learning, things like linear regression, things like what SVMs are, right? Things like what different kind of problems are, things like what probabilistic models are. Or you can take the other approach and you can start learning different ways that people are applying these different models to different problems.
Yeah, just to add one thing here, guys. So as Pragya said, that linear algebra, understanding probabilistical models, these concepts of maths are very, very important for you to become a good machine learning engineer. And some of you, as he said, that are shying away from maths, that, hey, this is too abstract for me, I would not be able to understand this, maybe I should not pursue that. Let me tell you one thing, guys. There is a big static friction there that it looks very difficult at the very beginning. When, for example, if you're starting with linear algebra for the first time, you will feel that it is very difficult. It is difficult, to be honest. But then if you spend enough time, after a couple of weeks or a month or a two, when you start appreciating things and when you are able to identify unstated patterns, when you are able to identify and understand things at a intuitive dimension, things become very simple. So if you are scared of linear algebra today, my advice would be, please try to invest, let's say, a month at least on it. And after that, there is a big probability that you will start finding it a lot more intuitive and you will feel that, hey, you can do that. From the outset, it may look very difficult. For the first few weeks, it will look difficult, but do give it a try. In my opinion, having a good grasp of these basic mathematical concepts is very, very important for a machine learning engineer, irrespective of what you want to do. Of course, the degree of your understanding may vary if you want to do research or if you just want to play and tweak these things to build a solution to it. But I would say that understanding these things, in my opinion, is very, very important. So should not shy away from it. Invest time. You will be able to do a lot better with that. That's my suggestion.
In fact, I would like to say something even more stronger at this point. So I truly believe this fact that if you are weak at mathematics or if you are scared of mathematics, it is not your fault. The fault is of your teacher, whoever taught you that particular subject. Right? If you're weak at mathematics, if you're weak at logic, then most likely you have not had good teachers in your life. Now, it's okay, right? Not everyone is fortunate to have enjoyed the support of the best teachers. I personally have done my education from both a third-tier college in India and the best college in India. So I'm speaking from experience. I have perspective of both the sides. The difference that a good teacher can make, like a teacher that really cares about your learning, the teacher that can intuitively explain a particular topic. The difference that a teacher can make in your understanding is huge. So if you are feeling shy of mathematics, what I would like to say is, don't give up just yet. Just try out some other resources. Just try out some better resources. There's a lot of resources, free open resources like ocw.mit.edu, right? MIT's open courseware, a lot of courses online that Stanford provides, a lot of hands-on training that companies like Scalar, right, like we provide.
Right. And education is one domain that may be totally revolutionized with artificial intelligence. This access to good teachers, this is a big, big problem today. Do you suggest to focus more on code optimization techniques and code design or anything else? Okay. So as we said that, hey, focus on code design is one part of it, but I would say focus on architectural design. That's something which is much more vivid. That, hey, how are you going to architect systems? How are you going to solve optimization problems? Of course, very, very important. I would say that in general, how do you optimize something beyond which a pot of gold is hidden? If you try to optimize things, that can be, you can try to optimize your code solution. You can try to optimize a problem in general. That is something which is very, very important, a very good skill to have. I would say that, hey, focus on understanding that, hey, how systems are built, how systems are architected, and focus on developing the problem solving aptitude that, hey, how can I solve a real life problem using the technology that I have? This is the skill which is most important in my opinion. When you say code design, to be honest, I totally appreciate that, hey, writing code the right way is very, very important. It is very, very important if you want to keep your code modular, if you want to keep your code extensible. The first thing which is very, very important of a good piece of software is how well is it written. For example, I will borrow one example from Arvind. So he happens to be the founder of Zeta. He always, if you go and look at all the talks that he gives, he always says one thing, which is that the present banks that we have, if they want to make a new product feature, if they want to add a new product feature, they actually are going to take several years to just add a small feature. The only reason for that is the bad way they have architected their systems or the bad coding principles that they might have used. Because now adding features on top of it is very, very difficult. And this inefficiency has actually created $1 billion market for companies like Zeta, who can come in between there and try to create solutions where banks with their old technology can somehow leverage their solutions and interact with the newly changing world. So yes, code design is important, but I would still say that, hey, architecture design, in my opinion, is much more important than code design. Code design can be automated. You will see as you move along, you will see that, hey, refactoring code will become more and more automated, but designing scalable systems, coming up with architectural solutions is something which is going to be much more important and much harder to automate, in my opinion. Pragya, what do you feel about that, man?
Right, so I totally agree with that. As Tarun said, most of the refactoring things can be automated. However, in refactoring as well, there's a huge spectrum. Right, so things like indentation, things like variable name. Nowadays, if you're using a modern IDE, you almost never care about indentation, right? The IDE automatically indents the code. So those are the skills that you're not supposed to learn. The skills that you're supposed to learn in design, in even low-level design, are breaking down a problem, right? Taking a problem, collecting the requirements, figuring out how to design the solution for that, right? Learning the design patterns, learning the large-scale architecture, or learning the different ways, looking at the different kinds of jobs, of how different companies have implemented their architectures. Those are the kind of skills that you have to learn. Similarly, skills like understanding data structures and algorithms, right? Because those skills are central to your problem solving. Those skills are the things that are going to be important to you. Learning things like, okay, am I very good at Spring Boot? Am I very good at .NET? Am I very good at JavaScript? Those are the skills that are less relevant to you. And as time moves forwards, these things, these frameworks, these technologies, they are going to be phased out eventually. Right? They are going to become irrelevant. The problem solving is going to remain forever.
Absolutely. He says that he has read some articles which says that AI can be very dangerous as well. How companies are taking care of bad aspects of AI so that this awesome evolutionary change due to AI does not end up misusing the technology. So yeah, that's a very, very interesting point.
So first of all, what I would like to say is that yes, I mean, the picture is not all rosy, right? We are not here to paint the utopia over here. Like with any technology, AI gives us a lot of benefits, but it also comes with very significant risks. And since AI has the potential of being one of the most powerful technologies, the risks are also very significant. So let's go back to the invention of AI, right? So perhaps the first artificial intelligence system that was theorized was by Claude Shannon, right? So I'm sure that all of you have heard of that person, the father of information technology. In his bachelor's thesis, he gave information technology, but very few people know that in his master's thesis, he created something called the Shannon's mouse. And that was the first artificially intelligent device, basically, right? And he used to believe that in the near future, basically 100 years or 200 years from now, what we will have robots take over the entire world, right? And Shannon had that opinion. Now, I'm not saying that is going to happen, but a lot of very powerful, a lot of very knowledgeable people also share that opinion. So if you take example of Stephen Hawking, people like Stephen Hawking, people like Elon Musk, people like Bill Gates have warned us about the very real risk of AI taking over the world, right? Now, there's a way to handle this. It's not like there's nothing that we can do about this. This, like most problems, is definitely a solvable thing. However, if you expect just large companies to solve this problem, that is not going to happen. The solution has to come from you. So what I would basically stress over here is, since you are the engineer, since you are the future of the world, it is your responsibility to take these things as a challenge, to upskill yourself in these fields, and to make sure that the AI in the future is safe here. So there's a lot of research that can be done about things like what safe AI is. There's a lot of research that can be done about basically making sure that the AI is not trained on biased data. Right? So you might have heard cases in which Facebook's AI, right, that started tagging black people as animals, right, as orangutans, because it was trained only on the images of white people. It is your responsibility as a machine learning engineer to take care of these things to understand and come up with solutions for these. Apart from that, there is also a lot of research that can be done in how to best apply AI in the large scale society. So as we understand that, if you look at any particular technology, whenever a new technology comes into the picture, it only increases the distance between the poor and the rich. Right? So this income gap, this disparity between the powerful and the less powerful, this only increases because of a new technology. And that is a very real concern with AI as well. Right? So if you look at billionaires, if you look at large scale companies that are using AI to basically remove out any competition, right? There's also a very real risk of AI being weaponized. So if you see nowadays, there's companies like Boston Dynamics, there's several other companies that are basically trying to automate killing machines. So that is a very, very real risk of AI. And the only way forward, the only way we can tackle those things is, first of all, right, to upskill ourselves in this field, and secondly, to be more vocal, right, to actually bring ourselves into these fields and basically shape the future ourselves.
Right, Pragya, I would just want to add a couple of more points here, which are very, very near term. We can actually see those things happening in a very short duration of time, and maybe we are already seeing those things happening. And this is a very, very interesting conversation. So I will maybe just take 5 minutes to discuss a few things here. So the point that Pragya said that, hey, with new technologies, one unintended consequence of a new technology may be that your bar to entry increases a lot. Let's talk about that a bit. For example, if you want to come up with a new Google Maps today, will you be able to do that easily? The answer is no. It's very, very difficult. The point is that the amount of data that Google has accumulated, it has set a very, very high bar of entry for new solutions to emerge or new competition to emerge. And to be honest, from a very structural point of view, any domain where there is no competition, we are headed in the wrong direction. Similarly, let's talk more about that. For example, Amazon today has so much information about what are the things that we really would want to buy, what are the things that the market wants. Now, if I come up with a new product today, which is very, very interesting, I would want to use Amazon's distribution to be able to reach out to the masses. Now, Amazon can very easily, and it is what it's actually doing, unfortunately, it is very easy for them to copy my idea to create a clone product and to use their distribution to now actually sell that at a much cheaper price now and just gobble me up so that there is no competition. For example, the companies like Swiggy, Zomato, they are valued so much. We have a Zomato IPO coming up in the next few months. Now, Zomato is not only valued because the deliveries that they are making, but a very, very important part there is that the data that they've aggregated. Zomato would know that, hey, if I want to sell curry chawal in Delhi, what's the best price to sell curry chawal in Delhi for? What is the time where people are actually going to order a lot of curry chawals? What happens in different seasons? What happens in different parts of the city? What's happened in different times of the day? Now that data is invaluable, right? And this actually increases the bar to entry. For example, tomorrow if I want to open my own restaurant, or if I don't want to open my restaurant, I already have a restaurant. Now it becomes very difficult for me to compete with a company like Zomato or Swiggy because they can actually use that data, leverage that, and come up with a new cloud kitchen tomorrow, which will perform much better than me because they have access to a lot more data. Now, what I'm trying to say here is that a very real risk is barrier to entry may increase significantly. The companies that are already powerful may become significantly more powerful, and the others may actually be left out. They do not have the possibility of competing and coming up with ingenious ideas. That is one thing that I fear the most about. And this is not only for AI, this is actually for any new technology that comes up. But this is one thing that I really fear about. Another thing that I would also want to talk about is the information warfare that is happening. So now, guys, if you appreciate, all of us have our own social media presence, right? And the main source of our news happens to be social media today. I hope everybody agrees to that. Nobody now, very few of us actually read newspapers today. Our news actually comes from our social media. Now, try to imagine, try to understand that what we are essentially doing, we are exposing ourselves to the possibility of an information warfare. Now, if in my echo chamber of my social media, I only see the news that somebody else wants me to see, do you understand that you can actually change the way a society thinks? You can change the way a group of people think and maybe hide the things that would have mattered to them and only show them the things that you would want to show them. So this information warfare, you would have heard about companies like Cambridge Analytica. So this is a company which actually helped different political parties throughout the world trying to tailor make their reach, their outreach to potential voters. Now, what they do is they would want to hide all the negative things about a particular candidate that you would not want to show to a particular set of people and only amplify the messages that are very, very heartening for that group of people to see. So if you think about politics, in all honesty, politics or governance is a monkey balancing activity. There is no easy way out. You can't come up with a new scheme which is going to make every single person happy. Now, if you come up with a new bill, you come up with a new law, there is bound to be one segment of people who will be happy about it, and there is bound to be another segment of people who will not be happy about it. Politics is all about monkey balance. Now, if you leverage this information warfare, what you can do is you can put anybody on a spectrum and say that, hey, these are the things that I like about him. These are the things that I don't like about him. Now, what with information warfare you can do, you can only expose the things that somebody would like about you and just make them they would not even know about the possible downsides that you actually come up with. So this is very, very interesting and a very, very important field. The first thing that we should do is to make ourselves cognizant. That is, before making our very strong beliefs about something, just because of a few articles that we read online, first thing that we need to do to fight this is to be cognizant of the fact that, hey, maybe our source of information is biased. Maybe we don't have the full picture in front of us. So it's very important for us to first of all absorb everything and only then try to make opinions. So this is the first thing that we should do. Be cognizant of the possible effects that technology can bring with itself. Yeah. Okay. Difference between a machine learning engineer and a data scientist. How do these two roles differ from each other?
Right. So, there's not a lot of difference between these two roles. And in fact, if you look at most companies, they don't really care about the title. So, there's a lot of gray area in these things and there's not a clear delineation. However, traditionally, if you look at the data science role, the data science role is more about looking at data and simply making inferences manually from the data. So, for example, imagine that you are part of fintech company, right? You're dealing with a company like DE Shaw. And what DE Shaw does is basically take investments from different investors, from large scale investors. And DE Shaw figures out that, okay, what are the best companies to invest into, right? Best equity companies, best different types of stocks to invest into to give the best return to their investors. Now, if you're an analyst, if you're a data analyst with DE Shaw, your job is mostly looking at a lot of data about these companies, looking at the past performances of these companies and coming up with predictions that, okay, this is how the company is going to perform, right? That is the job of a data scientist, looking at data yourself and coming up with inferences. The job of a machine learning engineer is primarily to take this and automate this completely. The job of a machine learning engineer is not to say that, okay, given this data, what are the inferences I can make? The job of the machine learning engineer is to say that, okay, given this data, what algorithm can I apply on it, right? So that the algorithm does the job of the data scientist for. Now, as you can imagine, both these jobs have a lot of overlap between. Right? If you are a good data scientist, it is very likely that you are also a good machine learning engineer. Similarly, if you're a good machine learning engineer, it is very likely that you are good at making those data inferences yours. Right? So there's a lot of overlap, and mostly the companies don't really care about whether you are diving into a data science profile or whether you are diving into a machine learning profile. So what you should focus on is learning the basics of machine learning and data science. You should learn the basics of probability, the basics of this machine learning theory. You should not really focus on what the exact job title is, because those job titles are very meaningless and they are very flexible in the current.
Yeah, just one thing there, Pragya. Of course, there is a lot of overlap between these two job titles, but one thing that I have noticed after looking at multiple job openings and multiple job offerings, I have noticed that companies usually give the title machine learning engineer to folks who are much more heavier on implementation. Their job role will involve a lot more implementation versus people who actually call themselves data scientists are usually folks who would want to just build models and then give those models to somebody else to actually implement. But as Pragya said, if you want to become a good machine learning engineer or a good data scientist, then you will notice that there is a lot of overlap, a lot of skill overlap between the roles. But one thing that I would just want you guys to be wary of, that I have seen a lot of machine learning engineers would not necessarily have a very good grasp over the fundamentals of machine learning. That is something that you should personally avoid. If you want yourself to call a machine learning engineer, that's great. But make sure that you are not somebody who does not have a very strong grasp over the basics, the basic understanding of data science, the basic understanding of machine learning models. This is something which is necessary if you want to have a good career ahead of yourself. Okay, is there a demand for people who have both the skills? They have data science skills and they are also good software developers. The short answer is, of course, yes. There are lots and lots of companies who would love to hire people who are good software engineers. At the same time, they have a good understanding of data science as well. So if you are somebody who has both these boxes checked, I can assure you, you are going to be in great demand. That is a very, you should actually, if you are a software developer and you are figuring that, hey, maybe what's the next one skill that I should add to my understanding that will maybe help me grow a lot, you can think about data science machine learning. If you understand the principles of data science machine learning, maybe a lot more doors will open up for you. Similarly, if you are somebody who is very good at theoretical data science, you know how machine learning works, you know how different models work, and you are good at understanding models, trying to figure out that, hey, what model to apply in what problem. If you also pick up the skills of implementation, if you also pick up the skills that are important for a software developer, that is, you pick up the skills of architecting systems, then you can increase your value by a lot. You can also increase the kind of impact that you can make by a lot. So that's my short answer. Yes, there is a big demand for people who have both these skills.
Right. And in general, Tarun, I think pointed this out earlier in the conversation as well. The most important and the most impactful jobs that are there in the world are the jobs that are interdisciplinary, right? The jobs that are at the edge of two different skills, right? So it is always a good idea to be a kind of a T-shaped person, right? You should have a broad perspective. You should try to make sure that even though you have mastery on one skill, you should try to expand your horizon, because the true innovation that happens at those bounds. True innovation happens when you mix two ideas and you come up with a new idea, right? So, yeah.
Will ML be the road ahead in tech? Okay, so will machine learning be the road ahead in tech? That yes, in my opinion, machine learning or data science or artificial intelligence will become the dominant player or the dominant theme in the next industrial revolution, the industrial revolution 4.0 that we talked about. So yes, it is going to be a very dominant theme, in my opinion. You are going to see lots and lots of new companies and ideas mushrooming, where you are going to leverage data science and build a lot more impactful products. So you think about anything in general. For example, if you pick up any domain whatsoever. Pick up, for example, education. Now, you will have a lot of great companies emerging in the domain of edtech, but you can see that in the future, data science, artificial intelligence is going to be a big part of the story in education also. You pick up any other domain. For example, you think about getting people to move from one place to another, right? We already have airplanes which are almost automated. The pilots come into play only for very short durations of time, and also for some of the exceptions that actually can arise. A lot of flying the airplanes is totally automated. Similarly, you are going to see in the future that, hey, a lot of trucking industry, actually interstate traveling over highways, where you have a truck trying to move some goods from one part of the country to another part of the country, you are going to see that this will become automated in no time. There are some very interesting organizations, some very interesting companies that are trying to automate a big portion of the trucking industry. Of course, there will be a truck driver, but that person will just be there to handle exceptions, and majority of the boring truck driving on highways at a constant speed will be automated. Similarly, if you look at, let's say, self-driving cars is going to be a reality in our cities also, maybe in the next 15-20 years. So yes, machine learning, data science is going to play a big role there as well. You talk about Uber, you talk about Ola. These are big organizations today, right? And you see that, hey, they have utilized tech in a very ingenious way and solved a real life problem. But now, what is the major problem that Uber faces today? The major problem that Uber faces today is the driver side of things. If they want to maximize their profits, the first thing that they would want to get away with is drivers, unfortunately. That is what decides in different geographies, different kinds of profits that a company like Uber can make. So now, if you have a scenario where you can use machine learning, you can use data science to actually automate this intra-city driving as well, then these companies can actually become much bigger, and you can have a scenario where tech and data science being a very important part there can actually revolutionize industries altogether. If, for example, your driving becomes automated, you have artificial intelligence driving your cars. Now, it's very important for us to understand that this will have a big implication on, for example, the insurance industry. Now, if there are no humans driving cars, the probability of you requiring insurance, car insurance, most of the accidents actually happen because of human error. If humans are thrown out of the picture, now the probability of you getting into accidents is very less. Why are you going to pay hefty premiums on your cars to insurance companies just to keep your car insured? If the probability of accidents reduce, then this entire industry ceases to exist. Similarly, you can imagine that yes, the next wave of revolution will have data science, artificial intelligence at its very heart, and you are going to see lots and lots of ramifications, and we as humanity moving to a much more optimized version of ourselves. Yeah, that's what I feel.
Cool. So one thing that I would like to point about here is that machine learning is like a spice. Like with any technology, it spices things up. It adds on new capabilities to what you can already do. So it is not going to be the case that machine learning is going to be everything in the world. Right? It is going to be at the center of everything, but it is not going to be everything. What you have to understand is that the future is going to be, everything in the world is going to involve a bit of machine learning. However, the domains are still going to remain wide, right? So what you should focus on is learning how to apply these skills of machine learning, right? This technology of machine learning in different domains. And that is true with any emerging technology, be it machine learning, be it something like blockchain, be it something like quantum computing. What you have to understand is how these technologies work, and you have to get that understanding so that you can know how to apply these technologies in different problem domains. So the point over here is that machine learning is a theme. It is going to spice up everything. It is not the entirety of the world. Okay.
What are the bare minimum hardware requirements that are required for me to do something meaningful in machine learning?
That's a great question. Now, if you look at most of the science, if you look at something like physics, there's an amount of physics that you can learn via the books or via video. So anything up till class 12th level, you can fairly do. However, as you move higher, you have this requirement of really amazing machines, right? You require laboratory equipment. You require large scale machines, be those particle accelerators, be those CNC machines, be those a lot of different things. You require a lot of expensive equipment to grow further. Now, traditionally, computer science has avoided this problem, because all you need to be a good computer scientist is bare minimum laptop, and you just need your brain to think about things and basically come up with new solutions. However, with the advent of machine learning, especially with the advent of big data, this scenario is changing. For example, if you consider something like OpenAI's GPT-3, it is estimated that training that GPT-3, right, coming up with the architecture is different, but just training that GPT-3 on the data required a person to invest $16 million. So if you don't have $16 million, there is no way you can train GPT-3. So that is true. That is true that because of AI and because of machine learning, you cannot train large models unless you have access to those expensive resources. However, that is only a very small part of machine learning. If you still want to do very core research, right, if you still want to contribute meaningfully to the domain of machine learning, it will remain possible to do that for the next 10 to 20 years. You can still meaningfully contribute to machine learning without having fancy equipment. Don't try to think that, okay, if I want to become a machine learning engineer, then I definitely have to have a RTX 3070, I have to have a top of the line CPU, I have to have a top of the line machine. That is not true. In fact, with companies like Google, right, I'm sure you have heard of tools like Google Colab, right? So a lot of these companies, what they're doing is they're providing free resources for students, for researchers, for startups, free resources in the cloud. So you don't have to have a powerful machine. You can have a very, very basic laptop. You can connect to Google Colab, and Google Colab will provide you the necessary GPUs, the necessary computation power that you need to basically grow in this field and to do important research.
Absolutely, guys. So if you want to start, Google Colab is the answer. That how do you start, right? If you want to train any of your models, go ahead and use Google Colab.
You can learn almost all of the machine learning. You can learn all the systems. You require fancy equipment only when you are dealing with industrial level problems. Only when you are saying that, okay, I have data of millions or billions of users, now I have to train a model on that. That is the only case when you actually require those large machines, those large clusters. For learning machine learning, you can simply have a basic laptop and use Google Colab completely. Right? That is going to be more than enough.
What are the chances of a bot gonna have emotions and become biased? Okay, so what is the probability of your AI become biased? We have talked a bit about that already, but yeah.
There's a lot of debate around this area. frankly, from my perspective, I am a firm believer in the fact that everything that humans do, it can be automated, right? Simply saying that you can totally have a bot which shows emotions. Now, I'm not talking about the big picture. I'm not talking about the philosophical things over here. I'm not talking about whether the bot will have free will or whether the bot will actually be conscious. I don't care about any of those things. What I am saying that the bot will at least be able to mimic human emotion. That is a very real possibility, and that is going to come sooner, right? 20 years down the line, that is going to be a reality. Now, what are you going to do with this bot? Are you going to take a bot like that, and are you going to put that bot in charge of important decisions? Right? That is not likely a scenario, right? Why would you do that? We already have seen that humans make a lot of errors. It is not a very likely scenario that we will have an emotional bot be in charge of important decisions, right? Be it governance or political decisions. Once again, taking your question, having a bot that has emotions is a very real situation, but that is not going to be a big problem for us because you won't have that bot in important decision-making places. Okay?
Right. So, of course, your artificial intelligence can become biased because just by the kind of model you build, your models can always be biased. Pragya gave an example where some machine learning model of Facebook was not identifying people of one particular color as people, which is, of course, your systems can be biased because of the kind of data you feed that to. Emotions, as Pragya rightly pointed out, you can mimic emotions, but to be honest, I personally am not very worried about AI actually being consciousness of its own. It's a very, very big topic. There are very, very strong arguments on both sides, but let's not go there, discuss that right now. But yeah, I would say that, hey, of course, your systems can be biased. You can also mimic emotions to some extent, but that's not the most worrisome aspect here. But yes, how to make sure that your systems are not biased, that is important. And we should take efforts to ensure that the systems do not get biased because it's very, very easy. You can always have a sampling bias and patterns that you show can always be biased, and your machine as a result will always end up being biased.
The only way of making sure that that does not happen is to take action, right? Don't let your future be dependent on what other people do. Upskill yourself in these areas, be vocal about these things, learn these things, and take action yourself. Shape your own future. That is kind of the summary of this talk, basically.
Makes sense. Make sure that you have a seat on the table. And to get the seat on the table, make sure that you are upskilled enough. So yeah, that's a very nice way to summarize the session, that yes, it's important to maybe try to upskill yourself in these domains, and then so that you can also have a say in what happens with your future. Just one reminder, guys, we are starting with a course on machine learning and data science at Scalar Academy YouTube channel from next week. If you are interested, feel free to join us in that course. It's going to be a totally free course where we are going to take you through the basics and help you become better at machine learning data science. And if you have any questions, feel free to write to us. You can also connect to us on LinkedIn. My name is Tan Malhotra. Pragya was there with me. Thanks a lot, everybody, for joining in. Hope to see you guys again pretty soon. Bye-bye.
Talking about research papers, one of the things that's helped me often is known as Google Scholar. This is a repository where you can go and see multiple different papers. You can read papers, see who has published these papers, how many times they've been cited, what years they came up on, and everything. This is a good way of getting into research papers. And my personal suggestion, as well as my own experience, has been based on reading multiple such research papers. Over here, you see my specific profile, which lists some of the papers that I've had published year over year with several of the authors that I've published such work with. Without getting into too much detail here, I think it becomes important to look at what does such a research paper look like. So here's one of my research papers that was presented at a natural language processing conference earlier in 2020. The key idea of a research paper is to succinctly present some novel ideas or some new improvements in methods that already exist for solving some new kind of problem. The idea of a research paper is different from that of a project report, where one would maybe repeat experiments that have already been done, but rather with a research paper, one needs to publish new findings that would further the community. Specifically, a research paper then consists of a certain title, which is a brief summary of what the research paper is about, the authors and their affiliations of who have contributed to this research paper. Being an author on such research papers is a good way of showing that you're capable of doing independent research or in groups, as well as contributing to novel open problems in the world. Research papers then often include an abstract. The abstract is a good short summary of what the research paper constitutes. In this paper specifically, we look at using historical data to predict a person's suicide on social media. The idea here is social media often has many people exhibiting suicide ideation, thoughts of suicide. And what we're trying to do with this research paper is take one step ahead in showing how neural networks can be used to improve prediction of suicide ideation on Twitter. Often research papers after an abstract consist of an introduction. The introduction and the key idea here is mostly to emphasize and motivate why we want to solve this problem. A pattern I like to follow in such research papers is first explain why is the certain problem that we're tackling important. In the case of suicide, we've discussed some certain statistics on why we need to study it in general, as well as why we need to study it on social media. Often introductions can have figures, which are a good, easy way of introducing the reader to understand most of what the research paper is about, or the crux of the problem that we're trying to solve. In a sense, an interesting thing that I've learned and seen over the years is that maybe 100,000 people read your research paper title, maybe 10% of that read the abstract. Even a smaller 10% of that fraction is the one that reads your introduction. And the tiniest portion actually goes through the entire paper. So it becomes increasingly important to have a strong abstract and introduction that can motivate the reader to continue reading through. As we proceed ahead, another interesting section that research papers often consists of is known as related work. The idea of related work here is to contextualize where does your work stand with respect to other work. For example, what has been done in suicide ideation already? Why is the work done in this paper important, and why can't it be done by existing methods? So the key idea of related work is to contextualize where your work stands and motivate to people who will read the paper that this method is something that brings a new contribution to the world. Often after the related work comes one of the most important sections, which is known as the methodology. The idea of the methodology is to summarize your algorithms, your neural network models, the problems you're solving, and mathematically define what you're trying to do. In our specific case, you'll often see that methodology includes heavier mathematical notations, includes diagrams that helps explaining what is being done in this paper. So the methodology is often a section that takes a long time to write, where we need to go through several iterations, making sure that not only does the mathematical aspect tie out, but also formally follows all conventions and is easy to understand. With research papers, although we often have great ideas, it's very important to also make sure that these ideas work in the real world settings. Often for this, we need to do experiments. And with how fast machine learning and AI has advanced, it becomes easy to do these experiments on repositories like Google Colab, Kaggle, etc. Experiments often involve real world data sets. In our case, we look at a data set back from 2019 on suicide ideation detection and solve a classification task on predicting if users are suicidal or non-suicidal based on their tweets. Experimentation or experiment sections often involve descriptions of such data sets. For example, how many data samples were there? What was the data set imbalance? Where did this data set come from? What kind of pre-processing was done on such a data set, etc. Speaking to my earlier point, an interesting part of research papers is to demonstrate that your method works, but also how well does it work in comparison to other research that has been published. For example, in this part of baseline methods, I compare our new proposed approach with a paper of mine back from 2018. The idea here is to establish quantitatively and qualitatively on why the certain approach in the paper works better and how much better is it. Do we actually need this to be in a paper, or is this something that the community can live without? The key idea I like to always think about before I publish a research paper or submit a research paper is to make sure that whatever we're presenting contributes positively to the world and brings new insights to the topic that's being studied. Once the settings, method, related work, and reasons on why this work is being done has been contextualized, the most important part comes on summarizing how well does the model do. For example, in our case, comparative performance can be summarized through tables, bar plots, which all summarize based on different metrics how our model compares to other existing models. An example here is one of these baselines from 2018 performs or gets an accuracy of only 55%, but our latest model gets an accuracy of around 85%. Presenting these results in such a manner is an important step in terms of convincing readers as well as people that the problem we're trying to solve with this complex a method will add certain value. Results can often be in several different dimensions, where we can do comparisons across the model, within different components of the model, do analysis over time, and also qualitatively look at some samples. For example, here we study certain users, see what kind of tweets they've made, and then analyze what kind of embeddings have been generated and see how different models perform. In short, the results section is a good way of convincing reviewers as well as people who would read this research paper that this research makes a certain contribution and this is how well the proposed model works. Talking further in terms of the kind of aspects and parts of a research paper, usually we often have a discussion or a conclusion section which talks more about the practical implications, ethical considerations, if any, and concludes on how such a paper would contribute to the real world. At the end of a research paper, after conclusion, we often have acknowledgements, and at the end, we have references. The key idea of any research is to build on existing research. And often with references, we tie out to earlier published research papers and see how they compare to our method, or see what we can add to our paper based on the findings made by these research papers. In short, a research paper is a document of varying length. I've seen research papers go all the way from 2 pages, such as student papers or extended abstracts, all the way to over hundreds of pages, such as a research paper about the common Python library NumPy. In short, research papers are a good way of summarizing why we need to solve a certain problem, give a background on why this problem is being solved, say how we have specifically solved this problem, and at the end of the day, convince through experiments and results that our method produces ABC list of contributions, and that's why this paper would be a good resource for the community to come ahead. The process of publishing such research papers is a different aspect. Specifically, research papers can be published in conferences as well as journals. Often we submit a research paper anonymously. This is known as a double-blind submission, where we make a submission. We have reviewers who don't know what our identity is, and we don't know the identity of the reviewers. These reviewers often are experts in the fields and match to these papers based on their own prior experience. At this point, reviewers then anonymously review the paper, identify strengths and weaknesses, and give feedback on how the paper can be improved. At this point, there are multiple different outcomes that can come out. The paper could directly be accepted, it could be rejected, there could be revisions suggested. Ultimately, if a paper is accepted, the paper is often published, as you see the paper on my screen right now, in a certain conference proceedings or in journals, and is also presented. The key idea of getting such a research paper is then to build a repository of the kind of work that you publish, as well as communicate with different people on your key ideas, contribute to a field, and most importantly, network and talk to people who work in similar research areas collectively to make the world a better place. In short, research papers have been a good way of allowing beginners to step into the world of research, first by reading, then by experimenting, and finally by writing their own research papers. Personally, I feel research papers have been something that have helped me drastically build on research in my career experience. And I hope that through this video, there's a greater interest in how one publishes research papers, the brief understanding and logistics involved, as well as what are research papers. That being said, I am Ramit Sahani. I can be contacted through LinkedIn or can be contacted in general. In case you want to talk about research papers, feel free to hit me up and I'm happy to chat. Thank you for your time. Bye-bye.
Thank you so much for joining us on a Sunday evening. Just wanted to borrow some time of today's evening from Ramit. Ramit is a celebrated data scientist researcher who has, whom we have been talking to help us figure out the intricacies of data science. And we thought, let's use this holiday, let's use this a bit of free time that all of us have to catch up on what makes data science so elusive, what makes it so exciting, why so many youngsters are just talking about data science, artificial intelligence, machine learning, why those buzzwords are so frequently seen in resumes, and how can people actually start exploring that domain, right? So just for everyone who's joined in, thank you so much once again. We have Ramit with us. Ramit, would you like to maybe introduce yourself, who you are, where do you come from?
Yeah, sure. Cool. So thank you everyone for joining. Happy Independence Day. And yeah, really grateful that people had an hour to take out on a holiday. I'm sorry for doing this on a Sunday. And yeah, really grateful for all your time. And thanks to Scalar and Saurabh for hosting me. Hopefully we can take some of your questions and answer some of the things that we will have in mind. A little bit about me very quickly. So I'm Ramit. I finished undergrad just 3 years ago. Although 3 years ago feels like a long time. I've aged very quickly. But just 3 years ago, finished bachelor's from NSIT Delhi in computer engineering. Since the last 3 years, I've been working as a technical lead at Tower Research Capital. It's a high-frequency trading firm. And over these 3 years, I've also expanded some of the machine learning research I do. I think, like a lot of people here in this session, the whole era of machine learning, although started a long time ago, it started picking up more commonly in India, etc., over the last few years. And during that time, I was also getting interested in research, undergraduate thesis, things like that. And that's what led to me getting involved in machine learning, artificial intelligence. Over these 3 years, I guess I've been honored to have collaborations with several different universities, professors, and everything. And it's all led to a good number of research publications and output. And the whole idea behind this is as a community for India especially, to contribute to research. I think research has made a lot of progress abroad, but in India, although there is a huge demand in terms of understanding how we get into research, there's little to do in terms of how people are actually achieving it. And the goal of this session is hopefully to bridge that gap a little bit.
Right. Amazing. I mean, I would love to know all the juicy details about research and everything, but before we jump into that, maybe give us a quick walkthrough of what your introduction to machine learning was. What got you excited about this field?
Sure. So it's a rather funny story, and it's not the most inspiring story. Back when I was in my last year of undergrad at NSIT, me and my friends decided that we need to get a lot of marks. Okay, so we decided we were hungry for marks. And interestingly, I'm department rank 1 in NSIT, and the thesis had something to contribute towards it. So I figured that doing any kind of research papers might be a good way. Like if we can publish our thesis, it might lead to more marks. So very selfish, useless agenda, nothing more than that. So we wrote a paper, and the thesis advisor suggested that let's publish it in a local conference in India, which is what most people do. Our group decided that why don't we try something a little more ambitious? Let's try one of these big international conferences. And the teacher initially discouraged us. We decided that there's no harm in trying. Let's just go with it. 2 months later, the paper got accepted with some great feedback saying that although it doesn't look like a research paper, because we had no experience about research papers, but they said the core ideas make sense. So we're happy to publish the paper. And this happened in ACL, top NLP conference. Once that happened, I figured that maybe this was just luck. I wasn't sure. In fact, the conference coincided with my first day at Tower Research. So, like any sane person, I decided that full-time employment matters more. I decided to skip the conference. But then part of me realized that that's something incomplete. I would like to go on a free trip. So research papers involve free trips. You get to go to all these conferences and all of that. Eat a lot of good food. So I figured, why not? So as within Tower Research, I was still connected with some of my college friends, and I think this is something for everyone. Although you can't reach out to professors and all immediately, your friends are still people who can help you out. So as friends, we continued publishing some papers in small workshops, not student tracks. When you start, you don't want to start very big. You can't directly compete with Google Brain and Stanford. So we decided, let's start easy, small. We published some work on very tiny applications like tweet classification for suicide intent. And as you attend these conferences, so I think the key idea is you need to start somewhere. Like a lot of people I see take a lot of time thinking about roadmaps, making plans, doing courses. All that's great, but you need to start somewhere. If you don't start, then you're wasting some time there. So after I began, we got a few papers published. Once we published a few papers, I finally got to attend ACL the next year. This was in Florence. And that's when you meet like tens of thousands of researchers, Google Brain, Stanford, DeepMind, everyone is there. And they're all willing to, talk to you, guide you. That happened, and so it was just luck in a way. The paper got accepted. We just friends did some stuff just for an undergraduate thesis. No advice, no guidance. We didn't even know what a research paper looks like. I spent, I think, nights looking at what other people have published to see, okay, let me copy this from them. Let me copy the presentation. Let me try to make a figure like they do. And today, if you go and see the papers I wrote 3 years ago, in 2018, to the papers now, they've grown in how they look, but the key idea is basically where, it's just what you pick up as you keep going. So I think advice for everyone here is don't worry before taking that first step. Just start. Even if it's with your friends, don't have friends, just do it solo. It works out.
Right. I mean, I can already see that a lot of people in chat already resonate with the statement that you're making. For example, we have Ritvik who is saying that, hey, I get scared with the idea of doing research. How do I even start? Right? We will start taking a lot of these questions one by one. Maybe let's just start at the beginning, right? So you mentioned one very important piece that India, while there's a lot of demand and there's a lot of conversations, it does not have a very strong research platform as of today, right?
Yeah.
So when somebody is thinking about research and they actually want to make it something important, then they have to think about approaching universities outside India, right?
Yeah.
Or approaching research institutes outside India. How do they go about that?
Right. So I feel over time, the research culture has been improving. Universities like IIIT Delhi, Manipal, I think from all tiers, it's not a tier thing. I think a lot of people come to me and tell me that we're in tier three, we can't even think of research papers. But I think times have changed to the place where people alone, you don't need a professor to publish a paper. I know so many people, including myself, where we did not know any professor who had any publishing background, but we decided that we can try doing it on our own. So the worst case scenario, you don't get anyone at all. There are definitely options to do it on your own. But regardless, I think the best idea is to always try reaching out to people. At times, people worry that I have nothing on my resume, so I shouldn't reach out. Well, the one thing I've learned over these 3 years is, the answer is always going to be no if you never ask. So even if you don't ask professors, you should reach out to people who do or publish research papers. For example, in fact, more than 50% of the team that I have today in IIIT Delhi, Georgia Tech, they're all random people who message me on LinkedIn. I had no idea what they were. I've never met them in my life. And I have co-authored papers with them simply because they took the first step in saying, this is our resume, can you take a look at it? And in fact, that's how I started. So it goes back to 2017, 2018, when I decided I want to try looking at what research looks like. So I wrote a message, LinkedIn, like a generic template kind of message, edited it out, made it a little specific for every company, and sent that to over 100 people. Of those 100 people, I think 6 or 7 replied, and most of them replied, we don't have the time. 95 didn't even reply. But one person from IBM Research said that, why don't we have a chat? So out of 100, just one person gave me a chance to have a chat. And within 2 weeks, I was interning at their Delhi office. So the idea in terms of starting out is do things on your own, take those first steps. And if you don't know what those first steps are, try reaching out to people on LinkedIn. I think with how open things are now, you can just message anyone. In fact, feel free to message me, ask me questions, and I'm happy to answer those. In fact, as this exercise of what I'm starting with scale up, you'll see more content around how to get into AI, like more detailed steps. But I think the first step is always this, that you need to start. I think I see a few questions here from Mudit, Tolik, Ritvik, where even Anhad, where people wonder that, for research, you always need an absolutely fresh new idea. It's not true. It's okay if you repeat what other people have done. For example, a very simple thing. I think everyone has studied some problem in data science, like how do I everyone's done things like classifying an email as spam or not spam. Everyone's done that problem. But how do you publish a paper like that? So you don't need to improve performance. You don't need to do X, Y, Z. You just need to do some extra analysis. Why don't you do email classification for spam or not spam in Malayali, for example? That's not been done before. So it doesn't have to be the fanciest, trickiest mathematical idea. It can always be simple things like, why don't we use the power of India? So, a lot of research labs I work with in India, ShareChat is a good example of one of the new booming startups in India where the whole idea is around regional languages. So we've made progress. Like Google search works great in English. Have you tried Google search in Bengali? Have you tried it in Arabic? Maybe not, but how well does it work? So problems are many, and you need to start working with these problems to realize. You start wondering, where do I start? It's difficult to start. But if you start with any random thing, you will find something to take it ahead.
So if we just oversimplify and summarize it, the first step is to get started. You can just think about the smallest or the most closest idea to you, right? It could be geography specific, it could be a cross-domain implementation of something that is already being done, right? Awesome. And for example, you have this idea, you've started reaching out to companies, you've started reaching out to people, right? Now, when you hear back, how should you frame your conversations? Because like you said, out of 100, only maybe 2 might reply, right? Arshit, we would have loved to converse in Hindi, but for example, a lot of our audience members might not be Hindi comfortable, right? So English makes it more easy. No other reason.
Archit, you should message me separately. I'll talk to you in Hindi. I can speak well enough Hindi, so I'll talk to you in Hindi. So
yeah, awesome. So you have this great idea. You reached out to a lot of people, like you said, out of 100, 1 might reply. Right now, you reached out to a lot of people. Somebody has replied. How do you make the most out of those conversations? How do you prepare for those conversations?
Yeah, so I think that's a great question. And I think the main idea in anything, this is not just about research, but even a full time industry role, anything, applying for masters, doing JE and applying for undergraduate college, you need to show that you bring value, right? You can't just claim that I bring value. I can't just say that I've made Google search, so when you hire me, you need to do something and show it. So in something like JE, you need to get a certain rank to get there. Similarly, with research, you need to have something of your own. It doesn't need to be a research paper to start. If you have a research paper, that's great. That shows that you can independently take a problem and do everything. But why not do a project? So, everyone has projects on their resume, right? Try to find a project that's the closest to the company that you're applying to. For example, if you're doing Amazon, you want to apply to Amazon as an intern, why don't you message some people who work in Amazon saying that I'm working on a recommendation system for mobiles or fashion or anything like that. So in that case, the idea simply is have something to demonstrate. If you walk into a conversation without anything to back up your claims, it's not going to work. In fact, when I started out, I would make claims like, I want to do this and I can improve this neural network. But then people would say that, have you done it already? You won't know if you've not taken that challenge head on. So be company specific, don't be generic. Like you can't say the same thing you said to Amazon to also say, for example, Uber, right? It's difficult in some cases. If you've done something around work related to maps, tell Uber that I've worked on some maps recommendation, traffic forecasting, anything like that. And it makes the conversation easy for them. You're requesting to take someone else's time. So in that case, you need to make sure that it adds some kind of value to them rather than just saying, you can't just say something like, and surprisingly, it's very surprising to me that people on LinkedIn, in fact, to me as well, I get messages for referrals, positions at research papers, things like that. And they just say that we want to do this. But there are 100 people who want to do this, including me. So what makes you different? And what makes you different is, some project, something tangible that you have to show.
Amazing. I mean, I think that was a very, very detailed insight. You have to bring something concrete with your idea that shows that you are actually invested in it, right? You're not waiting for us to give you an opportunity. You're not waiting for the institute to give you an opportunity. You've already started. And now with our help, you want to take it to the next level. So for reference, you can also watch Shark Tank, right? Like you go there, you already built some business. You are high probability of getting some funding. Amazing. Another very, very cliche question when it comes to data science machine learning. A lot of people claim to be doing data science machine learning when they are primarily maybe implementing an existing library or when they might be primarily using something that's already there as a plugin, right? How do we build that self-discipline when we are able to assess, okay, where do I stand capability-wise? Am I actually doing something concrete?
Right. So I feel a lot of what people think, and it's a myth that will get busted over time. A lot of times people think that you need to change something mathematically to publish a paper or to get into research, but there's often production related stuff. In fact, that's, it goes with a question on the chat as well around academic research and industry research. Often things like industry research could be more focused on productionizing ML models. So in fact, in industry, very often we don't write our own algorithms. We don't change things. Often you would just implement stuff, import libraries, but there's a whole game around how to optimize these, what parameters are good, and writing production kind of pipeline. So I think it depends on what your interest is. Are you someone who wants to do more ML engineering, more ML ops, maybe more business for data science? Or do you want to be someone who's doing more groundbreaking research work? And the con with doing groundbreaking research work is you're going to hit into roadblocks more often. You'll try 10 ideas. And very recently, I was having this conversation with someone in Facebook research where they told me that in research, if you have 10 ideas and if more than 2 of those work, you're doing something wrong in terms of research. So the whole idea is, you're going to hit roadblocks, and there might be years before you come up with good ideas, or there might be certain cases where you do everything in 10 days. So an example, in fact, of that is, the tagline of this discussion, these award-winning papers. So the first award-winning paper I got, we finished that paper start to end with the idea, like idea conception to writing the paper, code, everything was done in 11 days, just because the first idea we got worked out. And then there have been papers which are, I've been working on since 2018 and they still haven't been published. So it's always a, thing on luck as well. Or even research is something which is like going into a dark alley, but doing ML engineering or things like that are more defined steps.
I think because you just touched up upon, a lot of these industry-related things that are happening can be built into research, right? We
Yeah.
have this question from Rupert. If you can elaborate the difference between academic research and industry research.
Right. So I'd say it depends also organization to organization. So I won't name specific organizations, but there are certain places where industry research focuses more on taking existing things and applying it. For example, there are a lot of startups where they would take something that Google has launched or DeepMind has launched, and then they try to build a product around it. Maybe something like text to speech, maybe something like self-driving vehicle. So a lot of companies would do groundbreaking research on that, and then there's a whole world in taking that to customers. For example, Grammarly is a good idea of it. Grammarly does both. They come up with new ideas and they launch it into their product slowly. But then they have a whole ecosystem built around a product that exists, marketing that to people, etc. So I'd say industry research is more around finding customers and creating value. It can't be a theoretical idea that is groundbreaking. For going even simpler words, I think when something like discovering Bohr's atomic model of all things, discovering that has a huge theoretical significance, does a lot of work for academia and is the building base for hundreds of things. But does it have an immediate thing that you can sell to someone or customers and make money out of immediately? Probably not. So academic research is more about building those foundational blocks, and industry research is more about taking it to customers and monetizing it. And often a bigger organization like Google, Uber, Amazon, they would have both. So an academic team that focuses on their long-term vision, that we want to improve Google search. So what kind of NLP problem should we solve? And then there's a more industry-oriented thing which says that, okay, let's take this small idea, release it to 5% of users using Google search, and let's see how it does. That's kind of what the difference starts.
Awesome. Okay. I think we just have another question by Afla, which is because you're already working and you might be doing other things, you are mentoring people, you are helping others who reach out on LinkedIn. How do you, I have just added that part, do you actively study new mathematical ideas too? I think he's referring to one of your papers, which is on time-aware LSTMs, leverage things like Riemannian manifolds. Was that something you knew already? If no, how did you proceed? And I would just want to maybe add a bit on how do you manage everything together?
Right. So to start with, on actively looking at new mathematical ideas, I think you have to keep up with academic research, like keeping up with industry. Like if new Python library comes up, maybe we all are not up to date with what new is coming up, but at some point pandas didn't exist, and soon enough we've caught on to that trend. Over the next years, we'll catch up to more libraries that keep coming up. It's difficult to keep up with all new research, and like everything, you can't keep up with all new shows, but you end up watching some of them, right? So focus on a subdomain in AI. I think one of the mistakes people make when they start is they don't fix a domain. I've seen people who will do something in computer vision where they're trying to identify hand recognized digits. Then they're trying to build their own Alexa. Like people want to do everything, but when you start, you can't. You have to pick a certain point. So in my case, there are certain domains that I follow, like finance is one of them. And I read papers. I in fact have a few bots on Twitter that keep posting some of the new recent papers that come in. So whatever looks like a catchy title, I'll go through it. If it looks interesting, then I'll read all of it. And that's where your source of new ideas comes in. Second source of new ideas is people. So like anything normally, everyone on this would have watched a movie on their friend's recommendation, although you have no idea about the movie yourself. So it's kind of like that.
Understood.
And,
Sorry. No, so I was just saying, so a community also becomes a very important part. Make sure that you're plugged into a community that is very focused on data science, that ensures that you have the creative juices flowing, right? Okay. Now, from a journey perspective, right? You have your idea, you have started reaching out to people, you have already done some concrete work before even starting those conversations. How to pick those institutes that might be most excited about it, because it's always better if they can find a fitment. Like for example, you may mentioned if you're talking to Uber, if you can talk about map related things that you've done, it's more exciting for them, right? Is there a way that people can test their ideas and see, okay, this company or this research institute might be more relevant for me?
Yeah, I think a lot of it has to do with more around what your interests are. So it's kind of like saying, take something that's more relatable to people. It's kind of like saying, what kind of movie would you want to produce, or what kind of developer do you want to be, back end, front end, etc. So it depends. Like, are you more interested by natural language? Are you more interested in healthcare? Are you more interested in computer vision? At the end of the day, I feel if you're doing something that you're not interested in, even to get into a certain company, it might get tricky. So it's often best to see what you are interested in, and there will be some kind of, like, you would have got idea for that from somewhere, right? Like, if you got into finance, there'll be financial companies, Tower Research being one of them, where they might be interested in finance plus AI. So you kind of need to see what interests you. And like I think Nikhilesh mentions, how do you pick domains? So, and here the idea is there's so many exciting things. What do we do? So it's again a matter of, you look at everything for a little bit. You can't watch every show on Netflix. Well, some of you can, even I can. But at times, you need to pick, what do I look at first? An important thing to do is you need to pick something that also looks like it has an easy place to start. I've seen people start with things like reinforcement learning without having any background, without knowing what a neural network is. Then it gets tricky. Okay. You need to know what linear regression is before you get into neural networks. So start by looking at the very basic things. Don't think that, in fact, even with things like lead code, don't jump into the hard problems. It might sound exciting if you can finish a hard problem, but at times the basics are where you need to start. And when you're comfortable with them, you'll automatically find a path which becomes more interesting.
Awesome. Great. So we have the idea, we have created some research, we've started reaching out to people, everything is all sorted, right? What's next? Now, what separates a award-winning paper to just another paper, right? Where do you draw that line? Okay, these are the characteristics that you want.
Right. So I think the biggest thing is having a paper that produces value. I think, like very correctly Nikhilesh pointed out, people think that research papers have to be maths heavy. You have to come up with some new function. You have to solve some integral that's never been solved before. None of that. In fact, the first award-winning paper I had no novel maths in it. There was, in fact, not a very heavy mathematical background. It was just more around an application that creates value in the world. A paper's award-winning status, like an award-winning thing everywhere, is the impact that it can make. For example, maybe we've not used anything novel to detect suicide ideation, but have we come up with something that prevents even 5 suicides that are happening on Twitter? If it does, then it has created impact, and that's what makes it award-winning worthy. So it becomes important for people to realize that don't chase all the fancy things in papers. In fact, some of my papers might have really complicated maths, but you'll find some of them that don't have any maths at all. So it's not about maths or complexity. It's more about the impact that you'll try to create. If it's a problem that has already been solved, like at present, I think I've seen more than 1,000 papers on COVID-19 since it came out. Most of them do the same thing. They do something like, is this tweet about COVID-19 or not? At that point, are you creating more value? Are you creating more impact? Probably not. So the idea is, let's try to create impact and value that will improve AI, improve some application in the world, rather than just chasing fancier concepts or more complicated looking maths.
Got it. I want to take the next question from Narendra S. Can you list out some institutions or group who are very active in ML research?
Sure. So I'll answer this for India specifically first, because I feel it's more uncommon to find these in India. I'd say all triple ITs that I've seen are very, very, very not just active. In fact, I was from NSIT, but there was no research culture there. So I reached out to triple IT Delhi, and say 95 to 99% of all my papers are with triple IT Delhi. Besides them being active, it's also very inclusive of an atmosphere. So you will reach out to someone who works at triple IT Delhi, even some of the people I work with, you will 100% get a response. They will tell you, what can you do? In fact, a lot of these triple ITs, IITs have slightly higher bar at times, but triple ITs, for example, certain industrial labs, they have these intern recruitment cycles. In fact, I've been part of these like for 2 years now, where we'll release a Google form, you put in your interest, and you get a task. The task can be something as simple as building a sentiment classifier or something, and then they take interviews. So it's almost at the point like getting a software engineering internship. So all you need to do is keep in mind that these institutes are hiring. Look at their websites, look at their research pages. There are hundreds of research labs in India now, hundreds. So if you're an undergraduate student, try looking at what is the research initiative in your college If not, try finding another institute, or if you have the time, why not create one in your own institute?
How does somebody go about creating a club or a lab of their own in their institute?
So I feel if I had started research 1 year before an NSIT, not propelled by my greed for marks, then I felt I could have created such a group, because again, it's the same thing. Why will people join your group? Why will people join your company? If they see there's a benefit, right? So if you publish a paper within your college, you're going to have college people come to you. Like when I cracked our research, people in college came to me, how do you crack our research? Before that, no one came and asked anything to me. So if you create some kind of value, some project, or if you do something like Google Summer of Code, in fact, Google Summer of Code also has ML research kind of projects now. So in fact, I think TensorFlow is one of them who has very ML heavy stuff for Google Summer of Code. So once you get some kind of achievement, it becomes easier to attract people. If not, a group of friends can always come up with it. Like it's like creating a finance society. Find people with like-minded interests, generate some value. If you don't generate value and you're just talking about it, maybe over time.
Awesome. Sorry for that sidetrack.
No.
Okay, we have another question from Namrata, which is again on similar lines. How can we shortlist right publishers to submit papers, and how to customize the papers for them?
Okay, so great question, first of all. And I'd say it requires a lot of research. It took me more than a year to figure out where to go. And it depends on what your requirements are, to be honest. Like, I won't be like other people and tell you that you should only target the top conferences. They can be really tricky. I know people who've submitted papers to top, including myself, submitted papers to top conferences more than 10 times and it gets rejected for years because they have a crazy bar. And then there's some where, you get, it's a lower bar. It might not be the most popular conference, but it's still fine. So you need to decide are you willing to only settle for the topmost, or are you willing to start easy? So my recommendation for people who are starting would be to start with a student track, a workshop paper. I started with something known as a student track in a top conference, and that was restricted to undergraduate students. So you can imagine that I'm not competing at least with people in Google Brain and Stanford, right? But over time, the idea is if you want to create value, you should definitely be targeting only the top conferences. If I can post a link, I don't know if I can post. Can I post a link here?
Yes, you can send a link in private chat, and then the team will post it in comments.
Let me just do that. So I'm going to post a link of how this is a very standard conference ranking kind of rubric. It's what everyone uses. So it has something like a conference tiering between conference ranks like unranked, C, B, A star. A star papers are really, really difficult to get, but they hold the most value. So when you apply to big companies, they don't just look at how many papers you have. They look at how many A star papers you have. So idea is, like everything in life, the idea is not to chase quantity but quality. So make sure that you try to, if you don't go for the best conference, you try for one that has some value.
Understood. Great. I'm just going through the questions that have been posted here. While we have already spoken about it to a certain extent, I still want to take up the question by Soumya Dudeja, which is any prerequisites for getting into research? What should a freshman focus on in terms of academics and learning, studying, and aiming towards research?
Right. Okay. In terms of prerequisites, and this is also around tower research, so that later. Around prerequisites, I would say the first part would be having some basic maths background. That doesn't mean you need to know, complex calculus, but you should know what derivatives are. You should know probability. So I'd say class 11, 12 maths, you should know at least that much. And you should have some kind of computer science background. Very basic, but you need to know things like loops, if-else conditions. If you just start with that much, and you can import some basic libraries, and Python is a very good and easy way to start. You can do ML in other languages, but it might just be tricky. So some basic Python, some basic maths, and you can start looking at courses, and that's a good way to start. Talking about academics, again, if you can take more ML-focused courses, if you can take maths-heavy courses, that's great. And I would say in terms of courses online, I think there are many. There are courses like the famous Andrew Ng course, which is more theoretical. But then there are also courses which are more about, I think one of them is on Coursera only, around building neural networks with PyTorch. Those are more hands-on. So focus on maths, computer science, and the rest will follow.
Awesome. We spoke about our local universities and which one are providing a much higher support. When you talk about foreign universities, you mentioned emailing them, right? But for example, is there any other alternative as well which makes it easier to reach out to foreign universities? The question by Ajay Mehta.
Right. No, great question. And it's something that used to be very, very, very difficult because emails, well, not everyone replies to emails. In fact, I have a huge pile of mails sitting in my inbox. I'm doing nothing about them. But what's changed is conferences now. So with COVID, not that it's the best thing for us, but one thing that's helped with COVID is things are virtual. So conferences happen virtually. Now that conferences happen virtually, you can reach out to professors in conferences. They're sitting there the whole day, honestly. They have a thing like Zoom sessions, or they have something called Gather Town. For those who don't know, you can Google what Gather Town is. If you've ever played any Pokemon game on Game Boy, your character roams around a world where it meets different Pokemon and people. So Gather Town is something like that. It's an animated world, and as soon as your character comes close to another character, your webcam's on and you start a conversation like we're having right now. I've met more than 20 to 30 professors like this in virtual conferences where they're having their morning tea. I'm sitting here late at night, and we talk about common research interests. And this is how I met someone last year who's a professor in Germany. And we had this 5-minute conversation around suicide work. And next thing we know, 5 months later, me and her had published a paper, and we have more coming on the way. At this point, conferences are easy for people to attend because you can do it from your house. You don't have to travel. There's not a lot of money involved. Otherwise, you have to find funding, and you only get funding if you have papers, etc. But in fact, on my LinkedIn, I often post about conferences that I'm attending or presenting papers in. Very lately, these conferences have free registration, most of them. Some of them might have something like $10 US, $20 US, but at times they're free. If they're free, you can talk to PhDs, and companies have their booths. Last week, I was at this conference called ACL virtually. I had a few of my co-authors who've just graduated. They managed to get interviews from Google Research just within 5 minutes because they were in that conference. So in short, if not emails, not Twitter, not LinkedIn, try looking out for conferences, at least while they are virtual.
Amazing. Awesome. So I think one of the key statements is also to just put your work out there, whether it's via conferences, whether it's via online communities, whether it's via social circles. Just, if nothing else, start your own YouTube channel and start talking about whatever you're doing. Right? I mean, I think in today's world, it's just so many channels exist where you can just go out and start sharing what you know. And the more you put out there, the easier you are making it to be found, for people to find you and reach out to you.
Definitely.
Awesome. I think given the junction that you are at, right, you're as a very senior engineer at Tower Research, and you're doing so much work on the research side as well, right? There's a very important question that Prajwal Mishra has asked. How do you go about an approval from your company to work alongside these institutes? Because I'm sure that all of these companies are also very secret about their work, because it's a lot of IPs, a lot of industry first. How do you go about that?
Right. So I think it depends company to company, not even company to company, but manager to manager. I've been very fortunate to, I'd say it's luck, I don't know what it is. I've been very fortunate to have managers who, given me their blessings since day one. It's not just do your research. They want to hear about my research. In Tower Research, I've presented my research papers. They want to hear about it. And they're also open to me using some of the ideas I've got in research within the company. But the trick here is you need to keep them separate. You don't mix the two. For example, Tower Research being a financial trading firm, I can't pick up what I've learned in Tower Research and put it in a research paper. That doesn't work. And that won't work with any company, really. So there are certain domains where I know I can't publish based on discussions I've had with my employer. There are certain cases where I might need to show them a research paper before I publish it. But in most cases, if you can isolate the two, for example, I do research on suicide ideation detection. It has nothing to do with Tower Research. So it becomes easy to do those domains. The only crux here is if you want to manage both, you have to keep them mutually exclusive. And that just means you need to put in more time. So it becomes a matter of don't mix the two. If you can, don't mix the two. Otherwise, try finding a job where research itself is your own job.
Understood. No, that makes a lot of sense. I think the more exclusive they are, the least amount of conflict of interest, and the easier it is. We have a question from Srinivas. I think you've already touched about it. That you have some bots that help you with a lot of content, and then you pick and choose which one do you want to consume. But I think a lot of content consumption also goes into research, making sure that you're updated, making sure about what's happening. How do you keep track of everything that's happening in the industry, and how do you make sure that you are updated?
Right. So two answers to that. One is individually, what can you do? Like I mentioned, I think Twitter is a source I use, but there are a lot of other social media is what I'd say. Like you correctly mentioned, I think there's so many channels where people are putting out stuff. So you end up seeing it on YouTube, LinkedIn, Twitter. You follow the right people, which are just people who are publishing papers, and you get a sense individually. Now you see if it relates to what you're doing. Like, if it's something far off from what I do, I won't read the paper. But if it's something close, I'll read it. The second is through your community. So one is these conferences. Conferences are basically places where papers are presented. So you get ideas there. And then with your friends, right? So depends on what kind of friends you have. But I have certain groups where if a new paper comes in, we hear about it. If we would have a lot of institutes like IIIT Delhi has reading groups. So they take a certain time in the week, and if someone would present a paper and everyone else would talk about the ideas. So individually, you try to look at social channels, everything. As a group, you try to be around people who discuss similar ideas, whether it's research labs, industry conferences, and those people will teach you more and be your source of ideas.
Awesome. There's a question from Vipula Raute. It is something that I'm not able to maybe understand correctly, so I would just read it out. And then, how do you manage your ideas getting scooped?
Okay, controversial question, which I've not faced that often, thankfully. Okay. But it's a sad answer. The answer is you just need to be fast. It's as simple as that. It's like two companies have the same idea and both of them launch it. The one who goes faster usually gets the advantage, while you manage to keep your quality intact. You can't cut corners to get speed, but eventually it comes down to speed. There have been cases, in fact, where an idea we had, and it's not just with me, it's with a lot of people, where you get an idea after doing research for 2 years, you get an idea and think, oh, I've got something groundbreaking. You Google a little bit more and you see that's already been published a year ago. That things like this happen, and all you can do is make peace with it. It's a competitive industry, and you can't really do anything about it.
I think we are 7 billion people, might even be 8 right now. So, it's very hard to make sure that everything that comes to your mind, you are the first one to be thinking about it or doing something about it. Amazing. We have a question on how do you transit from a software engineering job to a research assistant, as both are in different domains. I think we have covered a bit on that, like, both can be done parallelly. Is there anything else that you want to maybe add on to that?
So I'd say the only thing is, I'd say if you don't know, then you try to do them parallelly. If you have even a 10% inclination towards one of them, then make your mind up. Like the longer you, in fact, this is the case with me also, I feel doing both is great, but at some point you need to pick one thing in your life. Like you need to have a concrete goal. So try picking one thing. If research is that thing from a software engineering kind of job, your best bet is that you already have half the skills, right? For research, you need to be able to code. You already have half the skills. Start one of those ML courses and follow pretty much the same steps. Like start reading research papers, put yourself out there, and don't do software engineering to build APIs, for example, or work on databases. Do software engineering maybe to deploy or put in an existing ML model. You'll start from there.
Awesome. Some institutes have good papers, but not traditional. Does quality of paper matters to reputation of the reputation of the conference? I think, just to summarize from whatever I've understood so far, if you don't have a very high quality paper, you would not make it to a conference. So, at all time, make sure that your paper is of the highest quality. It has a lot of information. It is creating a lot of impact. Anything else that you want to add to that, Ramesh?
Yeah, I'd go as far as saying that there are conferences where there's a lower bar. Like I think the ones you've mentioned, NeurIPS, AAAI, ICML. I go as far as saying that one AAAI NeurIPS ICML paper is better than 50 papers in some unknown conferences. One good thing is something that can add to your value. So the conference definitely matters. Like can't emphasize enough on it. definitely matters. And if you can, you should only focus at the top level. The rankings I've shared, I think personally, this might come up as a little snobbish, but personally, anything below B, I don't think people will revert back to you. They'll think that they took an easy way out. They cut out on quality. So, and I myself have some of those lower rated papers. That's why I can say from experience, they've not helped me as much as, and I put in time in them. I put in, let's say I put 10 hours per paper and I got 20 papers. Versus I put the same time in one paper. That one paper of higher quality always has brought me.
Amazing. Do you want to talk a bit about these rating systems and how papers get rated B, A plus, A star?
Sure. So, like we discussed earlier, the whole idea around a research paper being award-winning is how much impact it makes. And impact can quantitatively be measured by something called citations, which basically means how many times has this work been referenced. So, kind of like even in a movie, how many times has this movie been watched? How many people paid to watch this movie? Similarly, how many people read this research paper? More importantly, how many people have used this research paper in their next research paper? So, like, I have 2 research papers published at the same time. Both are in the same conference. No difference at all. One of them has been cited 78 times. One of them has been cited 2 times. That automatically means that the one cited 78 times has had greater impact. And the impact at citations year on year is proportional to the rating. So these A-star conferences simply mean that your paper has a much higher chance of discovery by top people. In fact, I'll go as far as saying that once I got some of these A-star papers, I had recruiters from Google Research, Facebook Research, all of these places reach out to me only because I was associated with these papers, which are easily discoverable and easily cited and follow this hierarchy of ratings.
Amazing. Awesome. I mean, that's pretty insightful. The more higher quality research you have, the more it gets used, the more it, the better rating it gets. Amazing. There's one quick question that I want to take up from Amir Siddiqui. Do you have to pay for your research paper to be published?
Again, controversial question, but at times, yes, you do need to. There are reasons on why, or actually, let me rephrase. You don't have to pay for your paper to be published per se, unless it's like a shady conference. Those happen. Like I've seen a few of them in India where they'll say we want 5,000, 10,000 to publish a paper. That's a red flag. But it happens indirectly where conferences would say if you want to attend the conference, you have to pay some money. And that makes sense because hosting a conference also costs money, right? You're getting food, you're getting accommodation, all of that. So indirectly, you have to pay registration fees for conferences. But let's say you don't want to attend a conference. At times, you don't have to pay anything.
Got it. Namrata has a follow-up question on our recommendation of colleges that how can you go about approaching the IIIT research labs? Definitely, we spoke about emailing them, start cold calling, start putting your work out there. Anything else that you want to maybe add into that?
I'd say one of the mistakes people make is they reach out to professors, which is not a mistake, but you have to understand that they're busy people. What you can do is reach out to people who are interning there, for example. Those are the most, I would say, younger in their career, early in their career, so they have more time to help you out. Think of it like this: reaching out to your friend who does XYZ might be easier. So, for example, if you're interested in IIIT Delhi, reaching out to me is easier than reaching out to my professor. Reaching out to one of my interns is easier than reaching out to me. So you start with people who are younger; they have more time to help out.
Get cracking on LinkedIn, find the right people, connect with them, make some calls.
Networking is key. I think that's also everything around Scalar, right? So this whole concept of building like a virtual university, everything around networking, like ask people and people who are doing what you want, ask them, talk to them, they'll help you out.
And I think just to maybe plug in there, if anybody who's here who's looking to get started with data science, we have just launched an amazing data science program. You can head over to scalar.com. On the top, you'll see Scalar Data Science. Go ahead, click, look into it. You might find something valuable there, right? I'm always happy to chat and discuss if there's any follow-up question on that, right? Great. I'm just going through the last few questions. We don't have new questions coming in. I think we have done either a very good job at answering everything, or we have lost people's interest.
So we
For
still
an
have one
undergraduate,
from what I think we just got 1 minute ago. I think there's a huge. I don't know if there's a lag on your side or my side. Like I seem to have quite a few here. Not sure.
okay. The last question that I have is from like a few minutes ago.
Oh, the last
from
one I
Ravi.
have is 7:49 only. So
Okay.
anyway, I think let's just keep taking the ones we have.
Yeah. So for an undergraduate, is being able to implement research papers from scratch be considered better, or being able to come up with a new novel idea? See, I have to research kind of trail if I want.
I would say that implementing is easier, but the value it might have would be lesser than being able to come up with novel ideas. So if you can come up with a novel idea and it works, 100 times better than implementing what someone has already done. But it's obviously much more difficult to come up with a new idea than just implement someone else's from there on.
Awesome. Manisha Reddy, is academic research a viable option for earning money when compared to a regular ML engineer job? I'm assuming that do you go full time into it?
Right. So it depends, first of all, from even country to country. I would say India, because it's on the, I'd say it's on the curve where people are embracing research now. So I think it's becoming a place where there are jobs like research scientist, ML scientist. These jobs, in fact, as far as I know, pay a little bit more than the engineering kind of role. But if you're talking about academic research, maybe along, say, professors, postdocs, things like that, I feel that's a totally different career path. Then I'm not even aware of what the differences are. But very often, even people who are pursuing things like being a professor, they often get affiliated with industry research labs, etc. And eventually, I think that ends up paying more than just the traditional software engineer kind of job.
Maybe I'll just rephrase with this particular piece by saying that money is everywhere. You have to be really good at what you're doing, right? Even if you become a primarily research-driven research ML engineer, if you're really good at it, I'm pretty sure that there are a lot of people who are willing to pay a lot of money to just get your help and get your credentials and get you to look at whatever they are doing, right? So just focus on what you want to do. Focus on how do you become a master of that craft. And काबिलियत के पीछे भागो, पैसे के पीछे मत भागो. बाबा रणछोड़ दास का डायलॉग है. Is it advisable to put your unpublished research paper on arxiv.org to get initial feedback suggestion? How to avoid your paper getting plagiarized or scooped before publication?
Okay, good question. I personally don't put them on archive, but there's some different reasons around that. In general, I would say it's better to put it. It's like saying that although the paper is not published yet, we have made it public, so it reduces your probability of it getting scooped. It's kind of like saying कि ये movie hall में नहीं release हो रही, but ये YouTube पे डाल दिया हमने, something like that. Right. So at least no one can copy it completely. But then there are also times where you put it on archive and now you've given other people a basic idea to start from. They can modify it a little bit. I've seen cases where you put something on archive, people might take your base idea, change it a little bit, and publish their paper with better quality, more resources, whatever.
Interesting.
And once they do that, that reduces the impact of your paper because something better is already published. So it's a trade-off again. You can protect yourself, but it's like same thing. You put a short movie on YouTube, someone makes a blockbuster out of it, then your blockbuster is gone.
Amazing. I think very interesting topic. I think we recently came across a news around that, but that's a different conversation of all length altogether. Ravi Kiran Reddy, I think you've touched up on how to work with research labs outside India. Start reaching out to them, start reaching out to professors. Is there anything additional that you maybe want to add to that?
No, I'd say if you're in undergrad or if you're basically a student, there are these programs that India has. Like I think DadWise is one of them, which has like a collaboration between Indian and German government. So you can apply formally through these things and do that. If you don't want to do these or you're not a student, the best is through conferences. Go to conferences, network with people, meet them, reach out to them, put yourself out there. And it's a tricky thing, it's not very easy, especially because people abroad, their first question is, why should we get someone from India if we can get someone in our own country? So you need to show that you add a certain level of value beyond that.
Right. Just adding on to that same question by Siddharth Kumar, which country do you think is best for academic research?
It depends again. I'd say, US is great. I think it's at the cusp where it's very, very well celebrated. It's very promoted in terms of things like pay as well. I think certain research-based roles in US pay much more than the normal software engineering kind of track. But then there are other options. I'd say certain countries in Europe, say Germany, Switzerland, certain institutes, they have a lot of great exposure. Another benefit of Europe over US is that education is much cheaper. So if you're considering something like masters, it's in some cases like Denmark, it's free. Whereas if you go to the US, in some cases your masters can cost somewhere around a crore. So there's always that difference. India is making progress, but I don't think I'll go as far as saying that India is amongst the top just yet.
Not yet, but maybe hopefully very soon we'll be there. Okay, one last question from Anish Bose. How to improve research output by knowing whether to publish in a conference or journals?
Okay, I'm a little confused about what the question is exactly, but how to improve
I'm
research.
assuming it's more about how do you get more eyeballs on your paper? Whether do you post it, whether is it big enough to go to a conference, spending that much money, or should you just do journal? Like, how do you evaluate that?
Okay, I think we can consider it something like difference between a conference and journal, something like that. So I'd say conferences it depends on domain. So machine learning AI conferences are what is hot because you have quick sessions. No one has the time to read 100 pages. People want a 2-minute video that summarizes it, and that's what conferences do. Certain conferences you have a 1 minute, like just a minute kind of session. You have 1 minute, summarize your problem, and the next person is going to talk. So those are hot within machine learning, AI, etc. Journal, and the one drawback of conferences, I'd say, is conferences, you submit a paper, 3 months later, you're told is it accepted or not. That's it. It's a binary decision. With a journal, you submit a paper, you'll get feedback, and they'll tell you if you can do X, Y, Z, we will review it again. So it's like an ongoing process. But then for journals, you have to take in the marketing and publicity in your own hands. There's no conference, there's no event. So even if it's a great journal, you have to spread the word that, look, this paper came out in this journal, etc. And journals at times can be more time-consuming. But they are the preferred mode of publishing in anything outside computer science. So bio, chemistry, health, they do journals. Conferences are not comparable. But CS, ML, AI, conferences all the way, at least for now.
A completely noob question from somebody who does not belong to data science. If your work has cross-domain implication, let's say you are doing something in data science that also has implication in, let's say, medicals, right? Then does journal start making a lot more sense?
At times it does. In fact, I published recently, we had the option of publishing in a CSML kind of journal and an Oxford Journal of Medicine. That's kind of where you see what kind of impact do you want your paper to have. Would you rather have medical impact or would you rather have CS impact? In our case, we figured medical impact is more real world tangible. So we did that. And so interdisciplinary, you choose, you have a choice, right? You have hundreds of journals to choose from. You choose where it might fit best. In fact, publishing in the medical journal turned out to be well because if we published it in CS, maybe it would not have got a lot of coverage. It got published in a medical journal. Then we had Times of India and everyone reach out, maybe only because it was medical oriented. So you basically pick where you think, what adds the most value.
Right. No, makes a lot of sense. So that was just a bulb that went in my head. Awesome. We have another question coming in from Mohit. Which plagiarism tool do you use to check your paper?
So a funny thing, I've never used a plagiarism tool. I feel like, I'm very picky about what goes in the paper I write. Till a year ago, I used to not let my co-authors write. I used to be like, no, I have my own way of writing it, you're not writing it. Now I've got lazy, so we use something called Turnitin. So at times, some of the interns would use that tool. But in research papers, it's very, very easy to get caught. You should not be taking any risks. One wrong step and your reputation goes down the drain. So just avoid taking any kind of negative steps. In terms of plagiarism tools, if you're in a university, ask your professors. They have free software. Otherwise, I think these softwares cost a lot. If you're in a company, company should have some kind of software.
Awesome. Great. I think we've answered all the questions. So from a journey perspective also, if I just try to walk through the entire journey, we spoke about how to get good ideas, right? You don't have to think of something groundbreaking. You can also think about implementations that are closer to you, that you don't see happening right now. You can start putting your content out there. You can start creating videos. You can start creating blogs, Medium. There are a lot of ways of just putting content out there that shows that you're passionate about what you're talking about, right? You can start reaching out to institutes by emailing them, by connecting with them over LinkedIn. Try finding people who are more approachable, interns, junior members of the team. They will be much more approachable. They'll be fast, easier to help you out. Network a lot. Make sure that now, in today's time when all conferences are happening online, make sure that you are attending a lot of them. Make sure that you're talking to a lot of people, and you're creating those networks that can help you out. Make sure that you're creating a lot of impact so that your paper, people want to read it, people want to derive some learning from there that can be helpful for them. All in all, if you're doing all of these, if you're checking all of these boxes, your paper has a very high probability of being an award-winning paper, right? And if you are still getting started, if you want a lot of help on data science, again, reach out to scalar.com. We have a data science program that can help you out. We would be very happy to chat. We would be very happy to. Ramit is helping us build that program very closely. He would also, in a way, be guiding you directly, indirectly. So, yeah. Anything else that you would want to maybe add to the concluding statement, Ramit?
No, nothing else. I think I'd say I'm very happy to use this platform that you have and reach out to more people. I think there's a lot of future in terms of improving the research and machine learning landscape in India over time, and in fact, right now it's booming. So there's a lot of opportunity for even people who are employed already. It's not like you need to change your career trajectory or path or anything like that. It's something that's booming a lot. In fact, people often won't talk about things like compensation, but just based on what I'm seeing, there's more compensation on the MLAI side. So it's great to be on that place where we can make an impact and tell people how they can upskill themselves. It's a new booming thing. If it's something that interests you, get your hands on it. It might be beneficial.
Hey Roshni, what are you listening to?
Well, I'm listening to Top 10 Songs of the Week by Spotify. Ever wondered how Spotify or YouTube Music curate top 10 songs of the week? Well, if you don't, we will be exploring that today together on how to predict the popularity of songs. Hi everyone, this is Roshni Tayal, an educator and a lead data scientist at Yum, which franchises KFC, Taco Bell, and Pizza Hut. Let's get started on how to implement an end-to-end machine learning project. Before starting on implementing this project, there is a certain project workflow that we follow. First is getting the data, then cleaning, preparing, and manipulating the data. After that, we train the model. And when you create a model, you test it. And then you make certain improvements on it if you're not satisfied with the performance of the model. Okay, so this is the workflow that we will be following it today as well. But before implementing this project, before following this workflow, we will be installing the environment. Why environment installation is essential? Because whatever dependencies, whatever libraries you install, you require for a certain project, it will be at one place. So library environment setup is essential. So let's see how to create an environment. So I've already searched here Conda create environment on Google. And as soon as you go to it, you will see this command, Conda create -- name my-env. So you need to mention the required name here. So let's create an environment right now. Okay. So what I will do is Conda create . I will give the name as song popularity demo. And what I want to do is I want to go ahead with Python version 3.7. Okay, so I will just write that. So it is working. It will install the environment. Okay. So there are certain libraries that it will install automatically. Okay, so you can see, right, these libraries will get installed automatically, right? Now it is telling you in order to activate an environment, you need to give this command. So I will just copy paste this command to activate. Now you see my environment name has changed from base to the name that I created. Okay, so now I'm inside that particular environment that we created. Okay, so now let's open the Jupyter notebook and create the code that we want. Okay. It will give me a problem here. Okay, it didn't because Jupyter notebook was already there. But if it gives you a problem, let's say Jupyter is not installed, then what you need to do is you need to just write the command pip install Jupyter and Jupyter notebook will get installed. And then you can just directly write Jupyter notebook and Jupyter notebook will get opened. Okay, since I was inside a particular folder, it got opened into this folder itself. Now let's work on the code. Okay. So now I'm inside the notebook that we are gonna fill. So for getting the data, now we want the data to import, right? And to get the data, we require certain libraries. So first library that I require is pandas. Why pandas? Because it will help me in reading the CSV file which I have. Okay. So talking about the data first, we have this song popularity data set from Kaggle. Okay, and let me give you a brief introduction about this data set. So we have 15 columns in this data set. And you see here that this is the CSV file that has been provided, songdata.csv, which I have already installed in my local. You can install it as soon as you see. This link will be provided to you in the description box. Okay, so there are certain columns in it. Like you see, song name is there, song popularity is there, song duration is there, acousticness, danceability, energy, instrumentalness, key, liveness, loudness. Okay, but the project problem statement is to predict the popularity of a song, right? This is a regression project that we are going to implement. So what would be our target variable in this? Definitely, our target variable is going to be song popularity, right? Which is given in the dataset, right? So if I just revise a little bit of basics here, regression is a form of supervised learning problem, right? And that is why we already have the labels here. We already have the song popularity numbers here. We are gonna learn these numbers through the other features that are there and predict the same popularity on our test data, right? So that's the focus. Okay. So as I told you that we already have the data installed in my local, you can install it and import the data here. In order to import the data, I need pandas library. So I will quickly take it. Okay. So I'm importing the pandas library. It is taking some time. Yeah, it got imported. Now read the data. Okay. So for reading the data, what I will do is pd.read CSV function. Okay, let's get the path of the data. So my data set is inside this songdata.csv. It's inside this folder, right? So what I will do is I will just go back and go to this folder. Let me just copy the path from here. Just a minute. Yeah. Let me just copy the path. and put the same path. I'm already inside Carol project, so what I will do is I will take this and of course the data that I want to read. Okay, it is saying path not found. Let me just. Okay, so after importing the library, we need to read the data, right? And in order to read the data, you need to give the location. So what I'm doing is I'm just going to the path where the data is installed and taking the exact path for the file. Okay, and pasting it here. So this should give me the data. Yeah, you see, this gave me the data, right? Now we have already gone through the columns that are there in the data set. Song name is there, popularity, the duration of the song in milliseconds, and the other features are there, right? So we can see it from here as well that there are 18,835 rows in this data set with 15 columns. Or you can do it with this as well. The f.shape will give you these many rows and columns. And you can explore the data with this info function as well, right? So you see this info function is very helpful for us. How? It is giving you multiple things here. It is listing down the columns that are there in this data set. Also, the number of non-null values in that particular column, right? So 18,835 non-null values are there. And we can evidently see here that there are no null values in the data set because this is the shape of the data set and we have all non-null values here. And the type of each and every column can be seen from here, right? So here is the basic thing that you can do with the data frame that you have imported. Also, there is a describe method that helps you get the statistics of the columns generally, right? So you can see the columns which were non-categorical. Their statistics can be seen here, right? Okay. So yes. Now, this is one way to ensure the number of non-null values. The other way to ensure how many non-null values are there is this. You can just do df.isNull.sum. So these are the basic data exploration steps that we followed. Now, let's explore the features and manipulate the data. Okay, so let's go to the data manipulation step. Cool. So in order to manipulate the data, for the data manipulation, what I would suggest is, first of all, let's drop this song name column because it is not contributing much to our purpose, right? So these are the several values that we have. So we want to drop this song name column first of all. So let's drop this. So there are two ways to drop a column. First, you can use .drop method, or what you can do is you can select other columns that you have, leaving the first column. So what I mean is, you have these many columns, right? You can see these many columns in your data frame, right? So what you can do is, you can just select all the other columns that you want, paste it here, and run it. You see, song name column has been dropped, right? The other method to drop a column is using drop method. Okay. So you can just give the name of the column that you want to drop and the access. You see, again, the column has been dropped, right? So yeah. Now after dropping the column, what we will do is we will separate the X and Y variables. What do we mean by X and Y variables? First, let me store this data frame into a new variable. Okay, now my new data has 14 columns and the same number of instances that we had, right? Now, I am talking about separating into X and Y variables. Why I am doing so? Because now we will have in X we will have the independent variables that we want to keep, and in Y we want to keep the independent variable or the target variable for predicting the song popularity. Okay, so let's keep in X all the independent variables that we want to separate. Okay, so our new data frame name is new data. This is the variable that we have created. Okay, and let me just try it and explain you what I'm doing here. Okay, you see, if I do X dot shape, you will see these many columns. Okay. So as we know that song popularity is our dependent variable, is our target variable, we want to separate it. So we can see I have kept it into Y, and this is, we have used the iLock method, and all the rows, we will be taking all the rows and the 0th column because it is in 0th position. We want 0th column. So this is now my Y and this is X. So starting from 1, from song duration, we have the X, all the independent variables, all the other features that we want to store. Okay, so after this, let's do some of the data visualization stuff in order to know about the data. Okay, so what I will do is, okay, now when we have talked about how to detect null values in a data, how to see how many null values are there in your data or no, let's move forward to manipulate the data, how to manipulate the data. Okay, so first what we will do is, these are the columns in our data, right? And I am wanting to drop the column song name. Why should we drop this column? So you see here, there are so many unique values in the data in this column, right? So there are 13,070 unique values in this column. Okay, so we have a lot of values in this column and it is not much contributing to our value which is predicting the song popularity, right? So we will drop this column. But how to drop a column? There are two ways to drop a column. Either what you can do is, you can select the other columns that you want to have, leaving the column that you want to drop, and paste it here. It will give you the other set of columns. The other way is to use the drop method, which is just write the column name that you're wanting to drop and give the access. So what this access equal to 1 does is, why I'm mentioning this access hyperparameter here, because this access will tell you that how do you want to drop a column, right? So access equal to 1 means it will drop a column from the horizontal axis, right? So it will drop the column totally. Okay, but if you're wanting to drop a column from the vertical axis, you need to you do not need to mention any value here. Okay, so I'm dropping a column and you see we are able to get the other variables with it. Okay, so now we see that we have same number of rows and 14 columns. Let's move forward to split this data into the dependent variables and independent variables. Okay, so what is independent variable that I'm talking about? Independent variables are all the other features that we want to keep for the modeling purpose, and dependent variable is our target variable, which we will be keeping in the dependent variable set. Okay, so what we will do here is I'm using the iLog method. Okay, I'm defining x and y, and in x, what we will have is, okay, I will explain you how I'm writing this iLog method and why I'm using it. First, let me write it. Okay, so what iLog method does is, this is index location. And there are two methods basically, lock and iLog. iLog is index location and lock is location based method, which will, where you have to give the labels. That is label based indexing. And this is integer based location. Okay, so you just need to mention the integer numbers. So this is all the rows, you want all the rows, and this is you want the column starting from index 1, right? Similarly in y, since the target variable is in first position, is at index 0, I am taking this index 0 over here. Okay, so all the rows but only the index 0. Okay, so this is how you will get the x and y variables. You see, I'm running it and visualizing the shape of x. We see that we are able to get the value. One mistake I did over here is I dropped the popularity, the song name column, but I did not store this into a new variable name. And that is why I do not have that data frame with me. This data frame has not been stored anywhere, right? So in order to do that, what I will do is, either you simply put it into a new variable, or if you're not wanting to do it, what you can do is, you can add the parameter in place equal to true. It will create the impact within the same variable, which is df. Okay, you see here, I will show you. Now df dot shape, if you will do, you will have 14 columns. It is showing here. Let me see how does this looks like. Yeah, this has been dropped, right? 14 columns. Yeah, 15 columns were there. Now we can see 14 columns. We see that it has been dropped, right? So I can now use df here because we have saved the change in the same data frame. Now x has been, now if we do this, I should have 13 columns in x, which is visible, and y also we have got, which is the first column that we wanted, which is song popularity. Okay, now we have x and y. Let us also see that how the values in the variable x is distributed. So for that, what you can do is simply, let me first import the Seaborn library. So Seaborn library, what it does is it helps you with basic visualizations. Matplotlib is also there, Plotly is also there, Seaborn is also there. But what I want is, I want to have a distribution plot, right? And that is why I'm importing the library Seaborn here. So let me run this. And I will just copy the basic line of code. Yeah. Also, I would need to import matplotlib to have a figure in the Jupyter notebook. So I hope you guys know about the matplotlib and Seaborn library. They are very basic libraries used for data visualization. And whenever you want to have an interactive display of plots in your Jupyter notebook, you need to have this matplotlib. So this is how we import these libraries, right? And you see how I'm using it. First, I'm using this matplotlib to specify the figure size. This figure size is 8,4. You can mention it, you can play with these numbers as many times as you want. Okay, I'm just leaving it constant because I've experimented with this number. Okay, now what I'm doing is I'm using sns.dispplot. We have the df. We are analyzing this particular column, which is song popularity. There are other hyperparameters which I'm not going into much explanation over here. Bins will tell you the number of bins that you want in the distribution plot that you're plotting. Line width will describe the width of the line, and the color is there. So you can just look for these basic hyperparameters when you look for the distribution plot over Google. You do not need to remember these lines. You can Google it over there, and they have a very good documentation of each and every hyperparameter. Okay. So what if I would not have used matplotlib and just gone with sns.distplot? Let me show it to you over here. Yeah, you see. I'm getting this here, right? But what I'm wanting is I want to play with the size of this plot a little. So I will just put these here. I can increase the width, right? So it will increase the width accordingly, and you can just visualize it. Okay. If you want, you can also skip these lines and just use sns.displot. It will help you with the plot. Cool. So yeah. Now with this plot, what we can see is that the song popularity variable is normally distributed. Okay, we can see the normal distribution of the curve, which is very much expected. So let's move forward with this now. Okay. So now we have the plot. Let's move to feature selection. Okay, we have already decided the number of features that we are keeping it as independent. But do you think that 13 columns, out of 13 columns, all these columns will help you decide the best model? Do you really think that all these 13 columns are the best columns that you would like to keep for your modeling purpose? Right? If you don't think so, then what and how to select the best features? Right? So we will talk about that in this feature selection section. Okay? Cool. So there are few multiple ways that I will be talking about how to select the best feature, but I will start with the first one, which is correlation matrix. Okay, using correlation matrix. But before coming to correlation matrix, there is one thing which you might have seen a lot, which is Seaborn's pair plot method, right? What this pair plot does is it will plot the graph between each pair of two variables, like you will see soon. It takes some time to run and give the results. Let's allow it to run. Okay, now we have the output. So we can see that you will see these size as very small. You can also increase the size of it. Like I told you, you can just use these plt.figure and set the size. But this doesn't contribute much to understanding that how all the columns are dependent to each other, and which columns we can exclude and which columns we can include for the feature engineering part, right? So skipping this part, let's come to feature selection. Like I told you, there are multiple ways to select the best feature that is over there. First is using correlation matrix. Then is using variance inflation factor, VIF, which we call in short. Then we have select key-based best method, right? This is provided by scikit-learn, and it has its own set of advantages that it offers. And then there are feature importance technique. that will help you how you can, how each and every feature gets weighed up. Okay, so based on the weight, you can decide that which feature is really important. Cool. So let's go through the first method, which is using correlation matrix. In the correlation matrix, what you will have is, first we want to have, so starting with giving you a little bit of context on the correlation matrix. So what correlation matrix helps us to understand is a basic dependence between the basic multicollinearity between two variables. Okay, so let me show you the graph first and then you will be able to understand it better. So starting with building a correlation matrix, I will just write. So we have X now, right? The data frame that we want is X. All the independent variables are here and we have to filter the best features from this data frame, which is X. Okay, so this is correlation matrix that we have defined. You can just use .corr method, which will help you get the correlation matrix. Okay, now in order to get the correlation matrix, what we can do is we can just use Seaborn's heat map. We can draw a heat map here and we can directly do this, which we will write it as, first let me take out the indices, and this is simple. The matrix that you have created, we store it here, not index, indices, the correlation of it, right? I want the annotation, so I will just set it true. And you have certain color that you want. Let me just take the color from here, which I have already saved. You can also take a simpler version of color. You can just refer to the Seaborn library documentation. You will get enough idea about it. Yeah, you see, I'm not happy with the size over here, right? So in order to increase the size of it, I have already told you what method we used. The PLT library, matplotlib library, right? So I will take this line, play with the size. Okay, plt.show. I would need to increase the size. So I am setting it something around, let's say 12,10. Let's see if it works, if it is clearly evident. Yeah, it works, right? We can see the graph. Now you see, this is the heat map that we are drawing, right? And if you want to see that how a correlation matrix looked like when we did this, let me show it to you over here. Yeah, you see, this is in the form of data frame. Song duration ms, song duration milliseconds. You see the correlation is 1 because these are the same variables. Definitely you will get a full multicollinearity value, right? Similarly, you get some numbers between each and every pair of variables. But to see that in form of a graph, we use heat maps. That is what we can see over here using Seaborn library. Okay. So in this heat map, the greener ones shows that it is completely, there is positive correlation between the two variables. And when there is red, extreme red, then it is showing the negative correlation between the two variables, right? And you see the values, that how it is distributed. Okay, so now you have now we have the values, right? What we would like to do is we would like to list those column names which are highly correlated. Okay, so let's see how we can do that. Let me explain you with the code. Okay, so what I am doing over here is I'm taking the absolute value of all the correlation values that we have got. Okay, so how this will matter is, let me just print each and every thing that we are doing. This will help you understand better. You see, we were getting some minus values as well. Now we have removed that, and we have all the absolute values, all the positive values with us. Okay, now in this graph, if you see, you have two triangles. The part above this green diagonal is the upper triangle, and the part below this green triangle is the lower triangle. Okay, so what I'm doing is, I am taking this only upper triangle to take the values of the variables which are dependent, and we will filter the values accordingly, because these values are repeated, right? These upper triangle and lower triangle are repeated. Okay, so in order to do that, in order to select the upper triangle, I am using this part of the code. Okay, what I'm doing here is, I am applying a where condition in which I'm using this library, which is np.triu. If you will search about it over the Google, you will get a complete documentation about it, that what all parameters are there in it. You see, you get the manual of it. Yeah, see, it will help you select the upper triangle of this array, right? Okay, so this is what we are doing here. In this upper triangle, we are taking the correlation matrix that we just took, and yes, converting it to very well value. You see, if I print this upper, okay, I have not imported the NumPy library yet. Let me import this. Yeah, you see, so we replaced the lower triangle values with the bool values, right? So wherever we have the values, we want the values in the upper triangle, we will get the values. Other part will get substituted with none. You see, we have got the upper triangle, right? Now, when we have the upper triangle, we know that we want only those columns where the column value is greater than, we do not want those columns where the correlation value is greater than 0.6, because we see that those are extremely negatively correlated variables, right? So we want to filter them. So we are applying this filter, greater than 0.6. You can play with these numbers and you can accordingly exclude the features that are there, right? Now, if we just print this, we see that these two columns were there which were highly negatively correlated, and we do not want to keep these variables. So you can straight away remove these variables from your consideration. Okay, so this is one way to select the best features if you want. And also here you can play with the values. Let's say I can take the value as minus 0.4. I can take the value as 0.4 since I've taken the absolute value, and I can substitute it over here. Right, I'm getting the same set of variables. In case if you have more than 100 features and 100 variables, if you're dealing with big data, you will have more amount of variables filtered out in this step, right? Cool. So let's move to the other method to filter the features, to select the best features. The other feature that we want to talk about is the variance inflation factor. What this feature, what variance inflation factor does is, it will help you know that how much variance of the estimated coefficients is going to affect the other part of the variable, right? So because of multicollinearity in the model. So after using correlation method technique, the next method that I want to talk about is the VIF method, which is variance inflation factor. So what this variance inflation factor does is, it helps us detect multicollinearity between the features. It helps you know that how much of the variance of the estimated regression coefficients is increased due to multicollinearity present in the model. And one more thing, if the VIF value is greater than 5 or 10, you need to remove those variables because it tells that there is high multicollinearity between those pair of variables. Okay, so let's see how to implement this, how to implement VIF for seeing for selecting the best features. Okay, so we have a particular library for it. Let me just copy the code from the notebook, which I have already implemented and I have already uploaded in my GitHub. I will give you the link later on. So yeah, you can take this variance inflation factor module from this library, which is statsmodels.stats.outliers influence. If you do not have stats model already installed in your local, I've already told this, how you can install this is, you can simply do pip install stats models over here and you can run it. The particular library will be installed to corresponding to the virtual environment that you have created. Okay, so since it was already there for me, I did not needed to do this again. Okay, so now I have the variance inflation factor already installed. Let's move to other steps. I'm creating a data frame here. Okay, I'm creating a empty data frame here. Okay, and the value that I want is the variance factor. Okay, and in order to get this, what I will do is I will use the variance inflation factor and take the values of this. So what x dot values will do is it will get you the values of each and every column in the form of an array, like you can see over here, right? So now we have x dot values. I will just write I for I in the range of the number of columns that we have. Okay, I will take 1 over here because this will tell me the number of columns that we have. I have written a list comprehension. Let me just have it here. Now let us see this library, how this is working on. Yeah, you see, we have got the variance factor of each and every column that we had. We can see 13 values, and you remember we had the 13 columns with us. If I say x dot shape, you see we had 13 columns, right? And this is how you can just take the y-axis value. Okay, so now we can see this, but we cannot know that corresponding to which column is this value, right? Corresponding to which particular regression column we can see this variance factor, right? In order to get that, what I will do is I will just add on a new column feature and I will add here as x dot columns, right? And now if I print this VIF data frame, I can see this whole set of features and their corresponding variance factor. Okay, now with this I can see that song duration millisecond is exceeding our threshold value, which is 5 or 10, which we decided, right? You can simply discard this column, and there are other columns which is exceeding, like energy is having variance factor of 30.7, right? You can exclude this. Time signature is giving you a variance factor of 88, which you can exclude, right? So this is how you can select the best set of values. You can just take a threshold value of, let's say, 11 or 10, and then you can select the variables which are below that, which have the VIF factor less than 10, and select those features for your modeling purpose, right? So this was one of the method to select the best features. We have another method provided by the scikit-learn library. Okay, and that is select k-best method. So what select k-best method helps you to do is, it helps you select the k most important features from your data. Okay, when I say k most important features, that means either you can select 5 most, 10 most, 15 most. If you have 100 if you have 100 columns available with you, you can select 50 most important features if you want. Okay, so this is depending on you, that how many variables you want to select, and it will give you the best set of features for your modeling purpose. Right, so this is the one which I usually prefer for the modeling purpose when I when I am developing a model or so. So this is the preferred method, and the other one which I will be illustrating after this. So in order to implement this select k-best method, you just need to use the scikit-learn library. Okay, so I am taking this these two libraries over here. You see, this select k-best module was available in sklearn.feature selection library, right? And I have just imported the select k-best method. Now, in order to use this, what we will do is we will just first what I will do is I will just implement the number of features that I want to keep. I am keeping 6 features. You can take 5, you can take 10. Okay, you can just tune these numbers and see that what is working out for you depending on the model performance. Since we have not built the model yet, we are just selecting the best features. We are experimenting with it. So I will just keep a random number over here. Okay, so I've selected k equal to 6. Let's create a new variable with the name xnew, and I'm using the select k-best. Okay, let me remove these. Yeah, select k-best method. Yeah, okay. In order to explain you better, when you will just go to the scikit-learn documentation for select k-best. Yeah, select k-best. You will see that we use the score function as the first parameter, right? And then we mention the value of k, which is int. Okay, so score function is what we need over here, right? So what I will do is I will use this f regression method to get the best score. So this f regression method is already there in the scikit-learn library. If you will see, it's already there, and it helps you get the f score of the features basically. So I'm using this f regression method. I will directly pass in the score function parameter and the k that we have defined. Okay, let me print the head of it. Okay, sorry, this is the xnew that we have defined. Okay, this will be something like this. K equal to k we have already defined, and we will use this fit transform method and pass the x and y variables directly. Yeah, okay, so we have got an array. Next, let's talk about select k-best method. What select k-best method helps you do is, it helps you select k number of features from your data. Okay, the purpose is same. to select best features, but here we have the flexibility of selecting a number of features that we want to have. So let's say if you have 100 features in your data, or let's take a very small data, right? We have 5 columns in our data, and we do not have sufficient space to delete the X number of columns. We do not want to compromise with a very smaller data since we have already small data, right? So in that case, we can specify that, yes, I want to drop only one column. Tell me that which one column should I drop and select 5 best features, right? So in that case, you can mention k equal to 5 and perform this operation. Okay, so let's see that how to implement the select k best method, how to use this. So for that, I have important two libraries, select k best from sklearn and fregression from sklearn. Okay. So why I've taken fregression over here, just to use the scope of using f score, which is the regression value for a feature. Okay, so after importing these two, let's use this select k best method. And in order to use this select k best, what I will do is, first, what I'm doing is, I am defining the number of features that I want. Okay, I'm defining the number of features that I want to have. Okay, I want to have 6. I can have 10. I can have 12 as well because I have 13 features in my hand. But I am just experimenting with the number here. I'm just taking a very random number here. I could have taken anything. Now, in order to use select k best method, what I will do is, I will just use this library which I have imported, the F score. So if you will go to the page that how to use select k best method, yeah, the first parameter is the score function, and the next parameter is the value k that you have already decided, the number of features that you want to keep. So in place of score, I'm using this f regression which we have calculated from the library itself provided by scikit-learn, and the number of k values that we want, and then fit transform on the x and y. Okay. Now, in order to select the feature, the code I have already copy pasted from there. So yeah, now you see that I'm having this. I'm just from I mean I have already run the select k best feature, and I'm just filtering out the features that we have selected, right? So we have this set of selected features over here. So now in this line, what I'm doing is, from the data frame X that we have in hand, the set of 13 features, with the set of 13 features, I am selecting the best features that we have using the select k best. I have directly applied the select k best line that we have done on top, right? It's the same thing. Okay. So this is how you use the select k best method, and this is I have applied it directly. So if I just break this line to make it simpler for you, what we are doing is, we are using select k based in the same way that we have done. You use fit transform fit, it will give you almost the same value on x and y. Okay, so if we do this is the method that we have run. Now we are selecting the k based features from the set of columns, right? Okay, I need to add this .get support. Yeah. And you see, I am getting the set of 6 features that we want. I am getting the best 6 features. It has the scikit-learn select k best method has selected 6 features that we should go ahead with modeling, for modeling. Okay. So now I have the columns. I can store this into a variable which is already there. Okay, and yes, I can just print this. So either I can just write the selected features like this, or I can do print and then selected features. But the best practice is to use the print statement. Okay, rather than just mentioning the variable name, best practice is to use print statement. Okay, so let's go ahead with this. Yeah, now we have selected the 6 best features that we want. So this is how select key best method works, and you can use it in the same way to select n number of features that you want to have in your model. Okay, the fourth and the final technique that I want to talk about is getting the feature importance. Okay, so what expectation would be here is that corresponding to each and every column, we would be getting some weights. Okay, we would be getting some weights, some form of numbers that will help me decide that yes, this is the higher weight, so this is the really important variable that I should keep. This is the lower weight, so I will not keep this method. I will not keep this variable. Okay. So for this, what we will do is we will use the scikit-learn extra trees regressor. I am using this regressor for doing this. Okay, let me just copy paste this thingy over here and do model.fit on x and y. Okay, now this model.fit has run. Now we can continue with knowing the feature importance, right? I have run the extra trees regressor that we wanted. We can directly run feature importances, and this is how we will just use the print statement to print the feature importance that we will get. Okay, now you see it has performed as per our expectation. It has assigned certain numbers to each and every column that we had. Okay, so here you see certain features have 0.093 values, certain feature have 0.03 value, 0.07, and some also have 0.01. Definitely we can judge from here that the values having 0.01 and the features having 0.09 are comparatively on the higher and the lower important side, right? So I am interested to pick those features where we have 0.093 and 0.092 and 0.088. Let's take a threshold of 0.80 and we can select those features. Okay, so what you can do is you can just print x dot columns here, and you can just judge that yes, song duration millisecond has 0.081, so I can take this. Acousticness has 0.092, so I can take this column into consideration. And audio valence has 0.096, which can also be taken. So accordingly, you can just filter out the columns and take it. Okay. But now, just to go for the modeling purpose, go ahead with the best features. Since we are moving to the modeling section, let's select some of the best features from here itself on the basis of feature importance itself. So what I'm doing is I am selecting the let me copy the best features that we have already selected once. Okay. So these are the features that I'm selecting on the basis of feature importance. You will notice that all these features have the value greater than 0.80. Okay. So yeah. Now I will just run this and do this x dot shape. You see, I've selected 9 best features for the analysis. Okay. Now let's move to the very important section, which is the modeling section, where we will talk about how to develop a model towards our goal, which is how to predict the song popularity. Okay, so now we have the feature sets, we have explored the data, we have visualized the data. The point is to create a good model. Okay, so towards that step, let's start with the first step, the very common step, which is train test split. Okay, so what I will do is I will import the train test split. So you will know it very easily that how do you get train test split. It is available in sklearn.model selection module, and this is how you get train test split module. And to use it, I think it's a very common step that we do, and you might have observed we are doing this y train and y test. Okay, splitting it into 4 parts, training and testing for each x and y variables. Here I will run train test split, and we will run this on x and y. Okay, y was this, and we will keep the test size as, since we have enough number of instances over here, which is close to 18,835. I will have the test size here as 30%, 0.3. Okay, now let's run this. We have got x train, x test, and you can calculate the 30% of this number that we have, the total instances that we have, to select the best feature. Okay, this is capital X dot shape. You will see that it has been divided accordingly. Okay, so similarly you can test for x test, y train, y test. Let's move to selecting the best model algorithm that I want to have to create the model. So for implementing the algorithm, I am selecting the random forest algorithm over here to have an end-to-end implementation. You can select decision tree, you can select other regression algorithms if you want. Let's go ahead with random forest regressor over here. So first what I will do is I will import the library random forest regressor. Since it's a regression problem that we are working on, that is why we will be using random forest regressor. Okay, so I will just define the model here, which is random forest regressor in this variable. So we have the random forest regressor. Okay, now we all know, or even if you do not know, you can go to the random forest regressor documentation. You will see a number of hyperparameters which you need to give value to create a model, right? So there are many hyperparameters, and there can be many different values to each and every hyperparameters, right? So here comes the scenario for hyperparameter tuning. Okay, in order to select the best hyperparameters, we have two methods: grid search CV cross-validation technique, and the other technique is randomized search cross-validation technique. Okay, you can either use grid search or you can use randomized search. I am over here going ahead with randomized search cross-validation technique because it is a little bit faster than grid search cross-validation is what I have observed as per my personal experience. But you can go ahead with grid search CV if you're comfortable with it. So in order to use randomized search CV, first we need to import that as well. So okay, it is under model selection, and we just need to have this. Okay, SLP capital. So we have got randomized search cross validation here. Now In order to perform this cross-validation, randomized search cross-validation technique, we need to define certain range of values for each and every hyperparameters. Okay, so what I will do is I will take it from here and explain it to you. So these are the hyperparameters that we are considering and will assign a range of values to. So first is n estimators, which helps you get the number of trees in the random forest. Okay, so this is how we define a range of value to it. I have just taken np.linespace and started it from 100, okay, and stopped it till 1000. You can play with these numbers as in what you need. Okay, and max features, I am iterating with auto and square root. So number of features you need to consider at every split. This is what I'm taking it as. Either you select it as auto or square root. Max depth, you can again play with numbers. I have just assigned it from 5 to 30, between 5 to 30. Minimum sample split, so minimum number of samples which is required to split a node. It can alter between these numbers to 5, 10, 15, 100. Any one you can pick. Then minimum sample sleeve, you can take any of these numbers as in you want to experiment. Okay, so yes, I've taken some random numbers over here. You can change these numbers as you have the data. Okay, now what we need to do is we have this we can create a hyperparameter grid over here. So you see, I have already created it. Let me explain it to you over here. So we have created a small dictionary over here, which I'm calling it as hyperparameter grid. And here we have assigned these values that we have taken to each and every hyperparameter that is defined under random forest regressor. Okay, so we have these 5 features with us. Now, you see, we have these features assigned. Now I will directly use this hyperparameter grid to select the randomized search CV. This is how I will do. Okay, so first comes the estimator that you need to define, and I can directly give the estimator as RF model, which we have defined already over here. Random forest regressor is the estimator for us. Okay, so random forest regression we are performing here, and parameter distribution we can directly give this hyperparameter grid that we have made. Okay, and of course the scoring function that we have, you can take any of the scoring function that you want to. You can take RMSE, MSE, whatever, but over here I have taken negative mean squared error. Let's go ahead with it. Okay, next is number of iterations that you want to provide. Let's go ahead with 2 iterations. You can go ahead with 50 iterations, 10 iterations, whatever you want to tweak it as. Let's go ahead with 5 iterations just to reduce the complexity. Cross validation, let's give the value as 5. The other variables you can take it as, or you can skip. I'm just taking it as random state, some value, some random number, just to make sure that our values are not changing on each run. Okay, so we have defined the randomized search CV, and let's run this. Okay, we can see an error over here. I guess it's okay. I've written param distribution. It's param distributions. Yeah, so we have defined the model, which is randomized search CV. What next we can do is we can just fit the model to our X and Y data. Sorry, not X and Y. We have taken X train and Y train, right? Now, X and Y will not come into picture anymore. So yeah, since we have fitted for 5, the cross validation value is 5, and we have also taken the number of iterations as 5, right? So it's fitting 5 folds for each of the 5 candidates. So it will take some time to run. Let's wait for it to run. Okay, while waiting, let me explain you the further part of it. When this model gets trained, right, and it select the best hyperparameters, and it gives you the best model on the basis of best hyperparameter ranges that we have provided, we can, after this model is trained, we can see the best parameters value through this method, which is best params. Okay, so model best params will give you the best values that randomized search CV has picked up in the range of values that you provided. Okay, so this is there. And after this runs successfully, we can also see the predictions, which can be easily seen with dot predict method. Okay, dot predict, and this we will definitely predict on X test. Okay, so this is predictions, right? We will just store the predictions. Once this model is trained, we are using this for predictions over here on X test data, and we can see the predictions over here as well. Let me use the print statement to print this predictions. Okay, I'm just waiting for model to run. Yeah, so our model has run now. Now you see it has completely run and we have got the output. So in order to know that which best parameters it took, we have already discussed this method. Yeah, it took the n estimators as 836, minimum sample split as 2, minimum sample leaf as 1, and max features as auto, and max depth as 30. Okay, so we have these features. Now let's talk about the predictions. Yeah, we see that some of the predictions we have already got, right? And it aligns very much with what we wanted. Okay. So let's see that how much these predictions are deviated normally. I mean, how can we visualize this? So what I'm doing is I'm using the Seaborn's distribution plot again over here, and what I will do is we have the Y test, right, which stores our actual predictions, the actual numbers, minus the predictions which we have done. Okay, so this is the actual predictions, the actual values that we have, and this is the predictions done by the model, right? So I'm just subtracting these two and trying to plot the difference between the two. Okay, how much deviated we are, I'm trying to see that on a plot. Okay, so when I do that, let me just increase the size of it, although we can see that. Okay, I am maybe using the wrong method. I can just take it from the above part. Yeah, it's fixed size. So what you might be noticing here, guys, is nobody remembers the exact syntax of the methods they want to use, exact syntax of the libraries, or let's say the functions that we want to use, right? You can easily Google it, or you can have it at one place and you can refer it when you want to use it. And nobody expects you to remember as well. Okay. So this is the exact, and you see, let's increase this more. 12 comma 10. Yeah. Okay. So this is the plot that we can see, and it's quite normally distributed, as we can see it already. So there is not much deviation that we can see. So our the predictions are again normally distributed. Okay, so we can visualize this in terms of scatter plot as well. We can use scatter plot here. You can just use scatter and the same thing, y-test minus predictions. It will give you, okay, so this is there in PLT, not in the matplotlib, not in the Seaborn. Okay, so yeah, this will not be there. So it's X and Y. Yeah. Again, you can increase the size of it if you want, but over here we can see that it's not very linear. It's not a very linear graph that we wanted to have. So definitely it requires more of the improvement in the model, more of the hyperparameter tuning, maybe more good numbers that we had assigned. Right? Or you can also experiment with different algorithm if you want. Here, instead of random forest, you can use XGBoost for a better performance. You can try decision tree, but that definitely not will succeed, outperform random forest that we have used over here. Let's also see the matrix, that how much they give here. Okay, so if we talk about the matrix, I am visualizing the MAE, mean absolute error, and I'm just taking the actual value and the predictions that we have. Similarly for MSE and RMSE, root mean squared error. Okay, so let's print these. These all are available in the scikit-learn library. You can just import the matrix module from it. Okay, so yeah, we have small y. So I'm just making that change in this code that I copied. Okay, so we can see that there is a high MSE value over here. MAE value is also high, right? So it needs some hyperparameter tuning, more good model to make. And we can also use the other algorithm and compare both the model performance and then select the best model that we have, right? So you can perform a number of things on it. We just wanted to implement a basic end-to-end machine learning algorithm, that how we start with data exploration, how we import the data, how we explore the data using the info method, the describe method that we just saw, right? How you can visualize the data using few of the basic algorithms, few of the basic methods that we just used, right? In the feature selection method, we saw 4 techniques on how to select the k best features, select the n number of features, right? You can use any of those things, reduce the number of columns that you want for the modeling purpose. You can also experiment with different set of columns that you have for modeling, that can increase the performance of the model as well, right? And then we talked about modeling, that how do we take a model and then perform the fit method, select its best hyperparameters, and then take out the result. Okay, take out the predictions and then we take out the results. Okay, so this is how a machine learning algorithm, a machine learning project is implemented. This was a basic regression project that we did. We can have more classification and more projects on unsupervised learning as well. So for now, if you if you want to push your project in GitHub, I would say I have this link which will attach in the description box as well. So in this link, it tells you that how you can, when you have the code with the data, if you want to push it to your GitHub, right, how you can turn that folder into a Git repository and push it into the repository where you want to keep it, right, where you want other people to see as well, right? So I have already pushed the code in my GitHub. Let me just show it to you instantly. So yeah, it's there in this song popularity regression demo. You can just open it and see the same what I have demonstrated to you, I have done over here for the demonstration purpose. So you can refer to this code as well. And yes, so let me know if you have questions. We can talk about it. So when you're done with the code and when you have implemented it completely, now it's your turn to share your code with other people so that they can collaboratively see your code and take advantage of it, right? So I have a link which we will attach in the description box. So in this link, what you will find is a very starter step to how to set up your folder and push the code to GitHub repository. So just follow these steps that are there. Anyone can push the code to the GitHub repository and you can share it. So similarly, I have pushed my code as well to GitHub repository, to this repository, the name of which is Song Popularity Regression Demo. You can refer to the GitHub link for the similar notebook if you want, or you can push your code by watching the whole video and push it to your GitHub as well. So this was an end-to-end implementation of Song Popularity Prediction project. If you have any questions, please put that in the comment section. Hope you find this video informative. If yes, please like the video, share and subscribe to Scalers YouTube channel for more such content.